सेटल डाउन फास्ट, चुप हो जाओ. 30 सेकेंड्स में वाइंड अप कर लो जो भी बात कर रहे हो, देन विल स्टार्ट. सच में वाइंड अप करने लग गए तो चुप नहीं हुए. आवाज डन. पेन. ये मेरे को याद से दे देना ब्रेक में. हेलो, गुड मॉर्निंग एवरीवन, ऑनलाइन ऑफलाइन पीपल. Am I audible? Is the screen visible? Chalo, great. Now, just a small announcement, although not for you, but if any one of your friends, family, anyone is about to start the preparation, we are bringing up the Kavach Plus batch. It is completely from basics to advanced and the faculties will be same. जिन्होंने आपका boot camp पढ़ाया है, so me, Sugam, Amritan sir and Ankit sir, we will be there. We will be teaching all of these subjects from basics, from foundations also. So if any one of you, yeah, if any one of your family members, आप लोग तो नहीं करोगे, so if any one of your family members is joining, yeah, starting the preparation, can go for this. इसमें सब कुछ होगा, foundation plus all of Brahmastra, all of Marg sessions, Eclipses sessions, everything will be included in this. Chalo, it was just a short announcement. Now we'll move to our class today. Before we start, just a small disclaimer. First thing, I intend to cover complete geography within the stipulated time limits. That means within the 3 class itself. So I'll not take much long. Yeah, I'll not be taking extra classes. Pehla cheez. Second thing, my approach here. Acha, one more thing. I have got a special request from you that you have a Samadhan session also tomorrow. So I'll try to leave by 8, around 8 p.m. so that there is some energy left. Maybe 7:30 so that there is some energy left for your tomorrow's session as well. Third thing, my approach here will be slightly different from other faculties. By this I mean, I won't be writing much here just to save time. I won't be writing much here. I'll have lots of diagrams displayed on the board because geography is all about diagrams. जितना देख के समझोगे, जितना imagine करोगे, the better it will be. So I'll be having lots of diagrams here, and I won't be waiting for the end of the session to take up questions. Every now and then, after every few topics, we'll do questions along with the topics itself, so that you are signposted that what all questions can be from these particular topics. One more thing, after every few topics, we will be having some kind of recalling session. Yeah, some kind of active recalling that we'll do in the class. For that, I want you to be utmost active in recalling as well. जो भी पढ़ा है, let's say from the past 1 years, from the past 1 hour, whatever is we are studying, you have to sit and recall within 2 minutes of the time. In your sheets, I have given the last page as whatever you are not able to recall, just jot it down here, so that even after studying you are not able to recall all those things. Keep jotting down all those points so that ये चीज आप भूल रहे हो, आपको याद रहना चाहिए कि ये मैं भूल गया था. Now just to give you a brief what all things that we will be doing today, first we'll start with very basics. By basics I mean latitudes, longitudes, time calculation and all. Then we'll move on to climatology. Post that we'll also do oceanography, and then we'll do climatic regions. This is what I intend to cover today. About 30 minutes, about 4 to 5 hours, about 1.5 hour, about 1.5 hour. So this much would be the stipulated time length of all these topics that we will be covering today. Now, before starting any of it, can anyone tell me which all areas from geography is most asked? We'll be focusing on prelims right now. So which all areas is most asked in geography? Map and human geography. See, I'll just list down most important areas what you should be focusing on. For prelims, the weightage of topics is very skewed compared to what it is for mains. In mains, it is more or less 50-50 from physical part, and human and economic part is 50%. But in prelims, highest weightage is of climatology. Second comes your mapping. Now mapping is both India plus world. I'm including both here. So these two constitute around 25-25%. So lagbhag आधा geography will be from just these two aspects. Then comes your geomorphology, oceanography, and your economic geography. This constitutes about 25 to 30%. In economic geography, you have everything, like you have agriculture, you have your minerals, and all of these aspects. In economic geography, I'm including. Then last part comes of your other aspects of Indian geography. And very last would be your human geography. So weightage is highly skewed. Sound का देखना एक बार. Online people, is the sound, is the voice okay? Hello, 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 hello. So it is very much skewed towards physical geography and mapping. Mapping is in itself is also one of the physical aspects only. So it is about 70-30 from physical and human and economic. So we will be giving slightly skewed time to physical compared to the human economic geography, because this is what it is in the exam. Having said that, let's start with basics. Acha, one more thing. There was some font ka issue. There was a different font in my laptop. There is a different font here. So कहीं कहीं पर आपको दिख सकता है कि font change हो गया है. Just bear with it. Now see, whole of Earth, we divide them into certain parallels and certain longitudes. So we have, let's say, we call these parallels that are parallel to equator. So let's say you have an equator here. We divide complete Earth into certain parallels. All of these parallels are parallel to the equator. We call them as latitude. Same way, we also divide them from north to south divisions, from pole to pole. We call them as longitudes. So what are these latitudes? These latitudes are the angular positions as measured from the equator. So let's say you have an equatorial plane here. Now if I measure from this particular center of the Earth, if I measure any of the parallels, I'll start measuring an angle from this equatorial plane. I'll keep going upwards. Whatever is the angle, that particular parallel means it is kind of a circle only that is drawn on the Earth. So that particular parallel represents a latitude here of this degree. So let's say if it is 30 degree, so we'll call this circle that has been drawn here as 30-degree latitude. So complete Earth can be divided into various latitudes. We need to focus on a few of them. Few of them would mean most important being equator. Then you have two tropics. Tropics are located at 23.5 degrees north and south of equator. Then you will have Arctic and Antarctic circles. They are located at 66.5 degree north and south of equator. Then you will have poles at 90 degree. So here latitude will vary from 0 to 90 degree north, 0 to 90 degree south. This is how your latitudes will vary. So they are concentric circles and it is measured from इक्वेटोरियल प्लेन. ये टर्म्स आ सकती है आपको कि द एंगल ऑफ दिस इज मेजर्ड फ्रॉम विच, इट इज मेजर्ड फ्रॉम सेंटर of the earth and from the equatorial plane. Talking about this, why are we having certain notations and why I'm saying that these are the important latitudes that we have? What happens is, we'll see that earth is tilted on its axis, and because of this tilt, आगे पढ़ेंगे, we have certain variations in the motion of your sun. What we see is this region that we call as tropics, sun is overhead only in this region of the tropics, and these two lies at 23 degree north and south of equator. Your apparent movement of sun lies within the tropics itself, and that results in very high heat in this particular region. Sun is never overhead in these regions. इसके कारण यहाँ पर you will have very less heat. So within this tropics, we experience very high heat in this particular region. We call this zone as torrid zone. We call this zone as where we don't experience high heat. This is very cool. This is called as frigid zone. And this is your temperate zone. तो यहाँ बहुत ज़्यादा गर्मी है, यहाँ बहुत ज़्यादा ठंडा है. Okay. Will slowly build up, and I'll try not to go very technical. I'll try to explain things in very layman terms here. Now, depending on, just as I was saying, this axis of earth is tilted, and depending on this, you will have different rays, different insolations occurring on different parts. So let's say I'm considering equator. So can I say equator will be the nearest area from the sun? If it is, let's say, straight, यहाँ पे देखते हैं, if this is the equator, can I say sunlight will strike directly on this particular area? We will have a very high insolation in this latitudes. This is your equatorial latitudes. Plus, even in tropics also, some time of the year it will be straight. All the sunlights that are coming will be straight depending on what time of year it is, because your axis is tilted. So even in this regions we will experience high heat. But as we move further, we will have this sun rays coming at an angle. If sun rays are coming at an angle, the heat here in this particular region will be slanted, will be dispersed over a larger area. If it is dispersed over a larger area, heating effect that we will observe in this region will be slightly less. So heating will be slightly less here in this region, heating will be high in this region. This is why we get this particular zonations being formed, high heat in this particular region, very less heat here. This does not mean sunlight nahi jati hai. Sun is never overhead, sunlight is never direct. Sunlight goes there, but it is not striking at perpendicular angles. It always strikes at certain other angles than perpendicular. Angle पे it is striking. यहाँ पर it is perpendicular to the surface. ठीक है. Talking about longitudes, we will go eventually deep into all of this, ki what all effects it has on everything. Talking about longitudes, the longitudes is measured from your Greenwich meridian. So by convention, we have assumed this particular longitude that passes through Greenwich as 0 degree. Anything east of it will be east, anything west of it will be considered west. This passes through UK. So Britishers ने बनाया है, so they have assumed everything from their longitudes. This is also called as prime meridian. All of these longitudes are also called as meridians. Time on any particular meridian will be same. your sun, let's say, starts from here. So when we see on any of the meridian, if when we observe on any of the meridian, you will have similar time here. So all these longitudes relate with the time. यहाँ पर for example, let's say this is the prime meridian. As sun starts rising from here, what we see, apparent movement of sun will be like this, and eventually it will dip here. So if we consider any longitude at a time, we will have same time on that particular longitude. सेम टाइम होगा क्या, या सेम लोकल टाइम होगा? It will always be the same local time. Time depends on which country it is in and what time coordinates that particular country follow. Local time means time that is measured based on the longitude of that particular place. कैसे measure करते हैं अभी, we'll see that as well. So we have an international date line being defined. This international date line lies exactly opposite of your prime meridian. So here we have prime meridian. Exactly opposite of this is your international date line that is there. From here we say day begins, and this is the meridian where day ends as well. So यहीं से आपका दिन चालू होगा, यहीं आपका दिन खत्म होगा. So date is changed on this particular date line. So if we go exactly behind this, exactly behind prime meridian, this is what we have, 180-degree. You can call it as east also, you can call it 180-degree west also, both are same meridians. But as you can see, it is not straight. It is deviating at certain places because of certain reasons. Can you tell me why is it deviating here? Why is it deviating here? See, normal reason for deviation of dateline is to keep certain places of a country within the same time zone. So you have Aleutian Islands of Alaska lying here. To keep Aleutian Islands of Alaska along with the same time zone that is followed in Alaska here or in USA here, they have deviated this dateline. Next, we will see deviation here in Micronesia, Polynesian nations as well. Just to keep all the islands in a similar time zone, they will deviate this time zone here as well. So we will see certain deviations within the time zone as well. As you move from here to here or here to here, depending on that, your date will change and certain terminologies will be used, like you have an extra day, or you lost a day, you gained a day. Last year also there was a question on this, remember? So let's say you are here right now and you are moving to this side. Tell me, if it is 20th here in India right now, 20th of Feb, you're crossing over to this side, what date will it be? You're crossing here to this side. Understand, if it is 20th here, right now sun will start traveling. As sun travels, as sun traverses through after this, sun will traverse from here. As sun goes, you will have 20th, 20th, 20th appearing in all of these countries wherever sun is going, wherever sun is rising. If sun just rose in India, it is 20th Feb. Can I say it is still night here? If it is still night here, it is just a day before there. So this is still 19th of Feb. Can I say this? If it is 20th Feb here, crossing the date line here is still 19th of Feb. Tell me, if I'm going from this side to this side, am I gaining a day or am I losing a day? But date to kam ho gayi. This is a normal doubt that you people will have कि sir 20 से 19 पे चले गए तो it should be losing. नहीं. Understand what is happening is, when you are going from here to here, now you can live 19th again. यहाँ पर it is already 20th, but when you cross this side, you can live 19th again. So you gained a complete day. Let's say opposite was there. If this is 20th here, if this is 19th here, you are in 90th, you have suddenly jumped from 19th to 20th. From 19th, you suddenly jumped to 20th. Is it gaining a day or is it losing a day? You have your date increased. If your date is increased, you never lived this date. You never lived 19th. You directly jumped on to the 20th, so you lost one day. So when you come from here to here, you are losing days. When you go from here to here, you are gaining days. ध्यान रखना, days and date are different. Even though it might seem that date is going back, you are gaining a day. Date is losing, but day is gaining. From here to here, you are losing a day, even though date is increasing. So don't get confused if there is date written or day written usme. So this is what I was saying. This is the eastern side of it, eastern side of your date line. This is the, in general, the western hemisphere that we say. Now we are moving from here to here. If you are moving east, this is moving east. Okay. From here to here, if you are moving east, you gain a day. From here to here, when you are moving west, you lose a day. Again, saying date is decreasing, but you are gaining a day. यही क्वेश्चन पूछा था सेम, अलास्का रशिया, यही वाला आया था. दिस इज द सेम स्लाइड फ्रॉम लास्ट ईयर ओनली. यही चीज लास्ट ईयर पढ़ी थी, एग्जैक्ट सेम क्वेश्चन वाज आस्क्ड. दैट वन नेशन, वन कंट्री वाज हियर. क्या क्या दिया था? अलास्का एंड, I think Alaska and something from Siberia was given. And if a person is crossing over from this side to this side, or if a person is crossing over from this side to this side, what is the change? Whether it is Sunday, Monday or Tuesday, ऐसा कुछ पूछा था. Remember? Yes. Now these longitudes are also involved in time calculation. So overall, when we see Earth rotates complete 360 degree, एक पूरा rotation is done in 24 hours. So one complete rotation is done in 24 hours. In 1 hour, if I calculate, total is 360 degree. In 1 hour, it will be 360 degree in 24 hours. So per hour, it would be 15 degree. Per hour, it is rotating 15 degree. That means, can I say, if I am taking just the longitudinal part of it, so 15 degree longitude is 1 hour. Per hour, it is rotating 15 degree. I am saying 15 degree longitude rotation needs 1 hour. 1 hour means 60 minutes. So if I want to convert it into minutes, that 15 degree is 60 minutes. 1 degree would mean 60 by 15, that is 4 minutes. ध्यान रखना, अभी we'll do questions on this. So every longitude means 4 minutes of time. So crossing every longitude, every degree of longitude will change your local time by 4 minutes here. Is this clear? We'll do certain questions on this. So for India, what is the standard time that we have chosen? What is the standard time that we have chosen? यहाँ नहीं दिख रहा है. IST is 82.5 degrees. Don't get confused. It might be written 82 degrees and 30 minutes. This is not 82.3. This is minutes. Minutes जो है आपका 60 ही पूरा 1 डिग्री होता है. So this is 82.5 degree only. It can be written like this, it can be written like this as well. Both means the same thing. This is, we are writing in degree and minutes. This is, we are writing completely in degrees. So this is where we have 82.5 degrees. What is this extent? In terms of time, if I may ask, what is this extent? Approximately 2 hours. This extent is approximately 30 degrees. Approximately 30 degrees. Every degree is of 4 minutes. So approximate 30 into 4 will give you 120 minutes. 120 minutes is 2 hours. So this time difference between extreme of Arunachal and extreme of Gujarat will always be 2 hours. So you will see northeastern people rising very early. Gujaratis sleeping very late, rising very late normally, because the apparent position of sun is such. Done. There was this question that which all countries had what all number of time zones. Not important, पूछा जा चुका है, but फिर भी रटना नहीं है. See, you cannot keep on memorizing such things कि किस country का कितना time zone है. ठीक है? it is one odd question that you should not be remembering all of these such things. Now we'll move on to Earth. Because of the motion of the Earth, there are certain effects that we'll see. Now, if I talk about Earth, Earth is not a perfect sphere. Earth is not a perfect sphere. What is the shape of the Earth called? Geoid. Geoid means Earth-like. So whatever is the shape of the Earth, that shape is called geoid. But how is it formed? Now, can you tell me what is the radius of Earth? Around 6400 kilometers. This is what is the radius of Earth. Consider a point on the equator here. If a point is here, after 24 hours, can I say this point will come back at this position? It will move one complete circle and will come back here. Can you tell me an approximate speed of this particle? Sir, geography चल रहा है या CSAT? चलो. Can you tell me the circumference? If this is the radius, what would be the circumference? 2 pi r. Approximate, let's say. If this is the circumference, can I say this particular particle that is lying here will travel this much distance in how much time? 24 hours. So if I want to calculate speed, speed is distance upon time. Distance is 2 pi r. So 2 pi into r, let's say, is 6400. Your time is 24 hours. Lagbhag itna. And this is kilometer. Ab just imagine what is, let's say this pi is 3, approximate. If this is 3, 2 into 3 is 6, approximate, this is 6, this is 24. So this is Forza, this is 1600. So that particular particle that is lying here travels 1600 kilometers every hour. Can you imagine the speed with which Earth is rotating? You do not feel it because you are born on this, you have experienced all of this, and gravity is there to hold you. But this particular particle is moving at a very high speed. And if this particular size of object moves at such a high speed, what we see is it bulges out from the equator, and from the poles it is slightly sunk. So it is bulging from here, it is pressed from the poles. So we call this as oblate spheroid. This is not the perfect sphere, it is the geoid, and it is because of great rotation speeds of the Earth. One of the factors is this. Because of this rotation, we experience one important thing, that is day and night. Because sun is here, for now we assume that sun is fixed at a particular place. Although we know that it is moving along with the galaxies, for us it is fixed at a particular place. Now if Earth is rotating on its axis, we'll keep on seeing one half of the Earth completely in the dark, other half of the Earth completely in the daylight. So it keeps on rotating. We experience day and night because of this rotation. So many a times there will be question based on, we experience certain things because of rotation, because of revolution, because of tilted axis, because of spherical orbit of the Earth. So there can be certain questions based on such thing. Day and night is purely because of rotation of Earth. Deflection of winds and ocean currents. We'll go deep into this. We'll understand what is Coriolis. But for now, because of this Coriolis force, we experience an apparent deflection of moving of the objects. This is purely because of rotation of Earth. Revolution ya baki cheez does not have an impact here. So you need to understand here that what all motions are causing what all effects here. We will go deep later on in climatology into the Coriolis force as well, how it happens, what all impacts it has. But it will have a deflection effect. In northern hemisphere it will deflect object towards their right, and in southern hemisphere it will deflect objects towards their left. Next, if I talk about revolution, now see, Earth's revolution is on the tilted axis. So it is not something that is happening in isolation. There are two things at play. One is you have revolution of the Earth, and it is happening on a tilted axis. Earth's this axis is tilted by how much amount? How many degrees? 20, 23.5 degrees. This is why we have apparent movement of sun from 23.5 degree north to 23.5 degree south of equator, just because of this tilt. Experience this position. Imagine this. Summer in sun. Okay. So right now, this is the equatorial plane. At this particular position, let's say sun is here. At this particular position, on which point will you see overhead sun? Huh? Tropic of Cancer. Till this point only you will start seeing overhead sun. After that the sun will start coming down. If I move all over to this place, where will you see overhead sun? It will be Tropic of Capricorn, where you will see overhead sun. So apparent position of your sun, when you see, your apparent position will lie between this and this. Sorry, Tropic of Cancer to Tropic of Capricorn. Between this and this position is where your apparent movement of sun will be there. Ab, one major thing that we'll experience here, see these two positions when sun is directly overhead on the tropics, this is called as solstice. This is summer solstice, this is winter solstice. These two positions where sun is overhead on the equator, this we call as equinox. In equinox positions, you will have same length of your day and night in all the in all the places. But let's say we are considering this particular position when you have northern summers. Length of day and night, can you tell me where will it be more, in northern hemisphere or in southern hemisphere? When you have northern summers, length of day will be more in the northern hemisphere. You can see that till this point it is day. This was the axis, but itna extra day ho gaya, and above the Arctic Circle you may experience complete daylight pura day long. In this northern hemisphere, when you have northern summers, you can experience this. Same way in southern summers, you can experience complete daylight near the south pole, and length of day in the southern hemisphere will be relatively more than the length of night here. In winters, this is northern winters, we'll have length of night more, इसलिए रात ज़्यादा होगी, दिन छोटा होगा. So variation in length of day and night is because of your revolution on tilted axis. Now tell me, had this axis been straight, had this axis not been tilted, had this been straight, will you experience variation in length of day and night? No, you will not experience this apparent movement of sun had this been straight. So just because of revolution it is not there. It is because that it is there because of revolution on tilted axis. Agar tilted axis nahi hota, तो you might not experience this variations in length of day and night. Another thing is you will have change of seasons. So here you will have summer season, then if it is rotating like this, you will have your, for India it would be rainy season at this time, then you will have winters, and then you will have spring season. This autumn and spring, this autumn is for your UK. It is based on British terminologies and all. When do we experience autumn? What happens in autumn? Fall of leaves. When do we experience autumn? Right now we are experiencing, just before the spring we experience autumn. This autumn is based on your climate conditions in UK, not India. ठीक है, तो इससे कंफ्यूज मत होना सर, autumn तो अभी आ रहा है यहाँ पर. It is based on that. Their tree shade lives before winters and new leaves appear in the spring. These terminologies are based on that. So we experience change of seasons, we experience variation in length of day and night, and we experience solstice and equinox positions. Done? Based on this also there was a question, I think 2 years ago. कि on which particular place you will see sun overhead on 21st of June. I think this was the question. That on which of the following places, Tropic of Cancer, Tropic of Capricorn, Equator and all, on which place you will see overhead sun. So such questions can be there from this part. Talking about sun and its motion, earth and its motion, we'll also experience eclipses, although this question has never been asked, but 2-3 दिन पहले ही आया था eclipse, so just let's study. There are two positions that we will see. One is when sun, moon and earth are positioned such that moon is lying exactly between, moon is lying between your sun and earth. Because of this, whatever sunlight is coming from here will be blocked, and from certain positions we might not see sun directly. So this is the place where we will experience eclipse. These positions might not be able, their places on this place might not be able to see the sun when moon lies in between. This is where we experience solar eclipse. यहाँ पर this region will experience complete solar eclipse, this region will experience partial solar eclipse. Opposite thing might happen when earth lies between your sun and moon and earth casts a shadow on moon. Here moon is not able to see, moon does not have light of its own. What it does, it just reflects the light that is coming from the sun. If sun rays are not able to reach the moon, can I say we will not properly see what is here? This is where we experience your lunar eclipse. So positions are such that in solar eclipse we have moon in between, in lunar eclipse we have earth lying in between sun and moon. They are in straight lines, these are straight line positions. They might confuse you. Along with eclipses they will introduce tides, that in which of these, lunar or solar eclipse, will we experience spring tides or will we experience neap tides? Abhi we'll see tides as well, but I've just told you about eclipses. I'll come back to eclipses along with the tides as well. कि in solar and lunar eclipse will you experience spring tides or will you experience neap tides? वहां relate करेंगे हम. हाँ, spring tides होगी, so we'll experience spring tides and such things. We'll see what are spring and neap tides in respective section. अभी के लिए let's solve some questions. This was the question I think which I was saying. On June 21 every year, which of the following latitudes experience a sunlight of more than 12 hours? More than 12 hours. Equator will be exactly 12 hours of day, 12 hours of night every time. So, अब 21st June sun will be in Tropic of Cancer. So can I say northern hemisphere? Anything in the northern hemisphere will experience more daylight. So Tropic of Cancer will, anything in the southern hemisphere will not. Sorry, Arctic Circle hai. So you have 2 and 4 here. 2 and 4. Done. This one. See, all the questions that we'll do in the respective sections, they will be either CSC questions or some exams that UPSC conducts. TDS, CAPF, EPFO, कुछ भी हो सकता है. Earth without rotation. You are not rotating the earth. No sunrise and sunset. Yes or no? Sunrise and sunset is because of your rotation. So your day and night because of this occurrence of day and night cycle. Again, it is because of rotation. Only one season. Yes or no? Chalo. This is where confusion is. You have sun here. Ab let's say you Earth is not rotating. If Earth is not rotating right now, let's say you have Earth positioned like this. अब if this is अच्छे से बनाता हूँ. Right now this particular part, the Earth is not rotating. This particular part of Earth which is facing the sun directly, it will experience which season? Summer season. Earth is not rotating. Can I say this particular part which was here will come to this side? Earth is not rotating, but it is revolving. If it is revolving, this particular part will now be away from the sun. If it is away from the sun, it will not experience light. If it is not experiencing light, can I say which season is this? Winter. So does change of season has anything to do with rotation? नहीं. जो confused थे, is it clear? Seasons can change even if we stop the rotation of Earth. So this is not the answer. You will have these two. Although you will have greater lengths of day, from here to here your day will keep on rising, then your day, the length of day keeps on dipping, then only you will start experiencing lesser and lesser daylights when the particular position moves after this. हाँ जी. हाँ वो पूरा ईयर होगा. हम यहाँ जब सनराइज सनसेट की बात कर रहे हैं तो इट वुड बी इन अ डे. बट आप समझो वो पूरा 6 महीने बाद हो रहा है. So for that we are not saying that it is sunrise or sunset. It normally means in a day. So here we'll have 1 and 2. Sorry. Day and night cycle is also there. Normal day and night cycle will not be there. आप अगर उसको देखोगे तो सर this is पूरा day cycle, this is night cycle. Normally we consider these things in a day. Try this one. Try this one. See, there's a 90% chance that UPSC will give you some kind of calculative question from geography as well. Last year there were two questions from your economy where they made you calculate few things in GS paper, fiscal deficit, primary deficit and all. From geography it will be time calculation. Now tell me, in India if the time is 12 noon, let's say time is 12 noon right now, what would be time simultaneously at Greenwich meridian and international date line? If this is India, time is 12 noon, Greenwich will lie this side. If you are going here, you are going ahead in time or behind? Behind, can I say? अभी यहाँ पे 12 नहीं बजी होगी. This time will be behind India's time. How much behind? India is at 82.5 degree east. If India is at this, how much time India is ahead from this? 82.5 degree. Every degree constitutes how many minutes? 4 minutes. So this into 4. Calculate. CSAT करना पड़ेगा. GS की क्लास है, I know. 330 minutes. 330 minutes means 5 hours plus 30 minutes. This is 5.5 hours, 5.5 hours. So India is ahead of Greenwich time by, this will be 5.5 hours. So can I say if this is 12 noon right now in India, what time will it be on Greenwich? It is 6:30 in morning. Is this clear? 6:30 in morning. What about this? अब ज़्यादा मत सोचो. This and this two meridians are exactly opposite to each other. And this time will be ahead of India's time because this is where date begins. So if this is ahead of India's time, this is 6:30 in the morning. This has to be 6:30 in the evening because these two are exactly opposite. Exactly opposite means 12 hours time difference. 6:30 in the morning, this will be 6:30 in the evening. Is this clear? क्या हो गया आंसर? ऑप्शन ए. डन. हाँ, तो इसमें इट कुड बी बोथ. हाँ, कि इवनिंग ऑफ द सेम डे एंड 24 घंटा पीछे भी जा सकते हो. इवनिंग ऑफ द प्रीवियस डे, both, but they will not give you both the options in the same question. Try this one. This is also a previous year question. You cannot run away from this. IST is 82.5 degree. This is what IST is. Shillong is at a latitude of 92 degree. From here to here, we are going ahead in time. Can I say if I am moving this side, I am going ahead in time? If I am going ahead in time, how much am I going ahead? It depends on how much degree I am traveling. कितना travel किया है? From here to here, can you directly calculate? This is 9.5 degree. Every degree, 1 degree is of 4 minutes. So 9.5 degree means 9.5 into 4, that is 38 minutes. So if this is 10, this has to be ahead by 38 minutes. That means it has to be 10:38. This is 10:38 am. Can you do this? पक्का? अगला क्वेश्चन आप ही करोगे. कैसे करेंगे? पहले 0 डिग्री तक, फिर उसके उधर. Can you tell me, will it be ahead of time or behind in time? Behind. Done. This is, let's say, 0 degree. IST is here at, see, this is 82.5 only. It might seem like 82.3, but it is 82.5 degree. This is IST and the time here is 6 a.m. This is given to you. Now we need to calculate for Florida. Let's say here you have Florida and it is 82 degrees. We need to come behind from there to here. How much are we coming behind? This is also a PYQ. Okay. डरो मत, question is easy. It is just the calculation that is there. So 82.5 degrees from here till here. Then again 82 degrees. Can I directly add both of them? That you are moving 164.5 degrees behind. From here till here, you are moving 164.5 degrees behind. By behind I mean how many minutes? 164.5 into 4. Calculate. 658. Now 658, this is in minutes because this unit of 4 is in minutes. 658 minutes means 10 hours 58 minutes. So if we are moving behind by 10 hours 58 minutes, can you tell me the time now? This was 6 in the morning of Sunday. This is Sunday morning. If I move behind by 10 hours, it will be Saturday evening. So first thing, cancel kar dena isko. It has to be Saturday evening. But in evening, will it be 658 or 702? 702? करो करो खुद से करो. Try to subtract this much time from 6 a.m. on Sunday. Yeah, A. तो ऑप्शन में एम दे रखा है, पीएम होना चाहिए. Now understand, 6 a.m. 6 a.m. minus 10 hours. Total we need to subtract 10 hours 58 minutes. 6 a.m. minus 10 hours would be 8. After this I am again subtracting 58. That means it has to be 702, not 658. So you need to be careful while calculating. Okay? It should be 7:02 p.m. of Saturday. Chalo, enough of CSAT torture on you. Now we'll move to the main topic of climatology here. Acha, are you jotting down some points or am I supposed to say? Am I supposed to dictate? पक्का यार, ये तो बेसिक चीज है, खुद भी लिख सकते हो. चलो, I'll try to dictate from here. Now in climatology, first thing that we'll start with atmosphere. First, let's see how did the atmosphere form. बना कैसे था atmosphere? Going back to 4.5 billion years. 4.5 billion years ago is when our Earth, I would say for now, let's say in layman terms, when Earth was formed. Actually, it is a complex process which took place there. Let's say this is the core of Earth. Then at that point, this core of Earth was at a temperature of around 8,000 degrees. It was even hotter than today's sun. Today's sun is at a temperature of around 5,800 degrees, or maybe 6,000, you can say kelvins mein. So it was even hotter than today's sun. It was happening. Now, when Earth was formed, imagine what happens. Let's say you are eating a Maggie. Garam garam आई है. सबसे पहले which part of your Maggie that was in plate will become cooler? The upper part. So this upper layer or the upper part of Earth starts cooling. भूख लग गई क्या? Upper part will start cooling. This cooling happened for about, yeah, this took place about 1 billion years. Years are not important. This is where your crust started forming. So this cooling led to the formation of very thin crust. Today's crust is very thick compared to this. This was very thin crust. It started forming. When this formed, you still have hot molten lava and all the reactions still going on here. What we'll see is, again, all of this lava that was here, it will rise because of extensive energy that it is storing. So we again see continuous rise of magma and lava that is coming out from here. So here we experienced continuous volcanic eruptions for over lakhs of years. Continuous volcanic eruptions हुए यहाँ पर, and because of this eruptions, this lava and magma came out. Along with this came out your gases. So initially we got gases like CO2, water vapor, you have hydrogen, helium, trace amounts of nitrogen. All of these gases also came out along with this volcanism. But this thing continued to happen for lakhs of years. 1, 2, 4 साल नहीं, lakhs of years there is continuous volcanism happening. What will happen is slowly these gases will rise and continuous cooling is happening. Earth is cooling even today also. So continuous cooling will happen, and what will happen for this water vapor is we'll start seeing formation of clouds here. So extensive huge clouds will be formed. Over lakhs of years we'll start seeing formation of clouds. And also because of this volcanism, what we will see here is formation of certain landforms. जहाँ ज़्यादा वॉल्केनो आ गया वहाँ ज़्यादा लैंड बन गया, जहाँ कम है वहाँ पे कम हो गया. So we'll also start seeing certain landforms being formed here because of continuous eruption of magma and cooling down. This will happen. Now this clouds will eventually cool down and rain. So we'll see rain for again lakhs of years it will rain, and when it rains you will start seeing formation of oceans here. So सारे oceans बन गए, and whatever is this tip left, this is what is today's land on which we are living. So this tip is what your continents are or your land masses, and we saw formation of oceans. But along with this rain, certain other things happened. Along with this rain is water. This water along with it bring down CO2. So water and CO2 they combined, and all of this CO2 was brought down by water here. This hydrogen and helium being relatively lighter, they went up higher up in the atmosphere. So hydrogen and helium went up higher up in the atmosphere. CO2 jitna bhi tha, maximum CO2 was brought back to the oceans. Some amount of nitrogen was also brought back to the oceans, but nitrogen is an inert gas. It normally does not react with water. So now what is left after this rains is your secondary atmosphere, and this secondary atmosphere consisted mainly of nitrogen. And even today, nitrogen is in abundance. Since the secondary atmosphere only, nitrogen is in abundance. But because of all this, certain other things happen. We have nitrogen and carbon dioxide both in this waters, and this led to the coming up of an important organism that we call as cyanobacteria. So we after this we saw cyanobacteria, and cyanobacteria was capable of photosynthesis, and this photosynthesis is from where your oxygen came. So as more and more photosynthesis happened, more and more oxygen came into the atmosphere. So this is where your tertiary atmosphere was formed, and this tertiary atmosphere consisted mainly of your nitrogen, oxygen, and there was one more gas, that is argon. These three main gases was present in this tertiary atmosphere that we live in today, and this constituted of about nitrogen is about 78, oxygen about, I'm just writing about, so it is 20.9, but I'm writing it to be 21%. Argon is around 0.9%. When you add all of this, this is combines to form 99.9% of gases on earth. So today's atmosphere, we have these three major gases which constitute about 99.9%. Remaining all other gases just 0.1. So your CO2 and all other pollutants जिसके कारण से इतना hue and cry is there, it is just 0.1% of our atmosphere. Okay. So three stages of evolution. If you want, I can just dictate, or if you want to write it on your own, you can write. जैसे बोलो, dictate. कुछ नहीं, मेहनत ही नहीं करनी है ना. चलो, एवोल्यूशन ऑफ एटमॉस्फेयर. ऐसे तीन कॉलम्स बना लो अलग अलग. मेक थ्री कॉलम्स. फर्स्ट इज प्राइमरी, देन यू विल राइट सेकेंडरी, देन टर्शरी. हाँ जी. राइट नाउ देयर इज सो मच हीट इनसाइड दिस. कंटिन्यूस यहाँ पर आपके रिएक्शंस हो रही है, रेडिएशंस निकल रहे हैं, उसके कारण से कंटिन्यूस हीट इज रिलीजिंग आउट ऑफ दिस. तो जो मैग्मा चैम्बर से वॉट एवर रॉक इज गोइंग डाउन अगेन बिकॉज ऑफ सबडक्शन, इट इज अगेन हीटेड एंड राइजिंग अप, and all because of the heat that is coming out from here. It is all because of this heat. Hollow means khatam nahi hoga. Understand, whatever is sinking, it is again melting and rising. So whatever is sinking below, it is again melting and rising. ये एनर्जी कहाँ से आ रही है? इट दिस एनर्जी इज कमिंग फ्रॉम कूलिंग ऑफ अर्थ. अर्थ इज कंटिन्यूसली कूलिंग. फ्रॉम देन इट वाज 8000, टुडे इट इज स्लाइटली कूलर देन दैट. सो जितना ठंडा हुआ है उसकी एनर्जी कहाँ गई? इस सब में चली गई, डिसिपेट हो गई. हाँ, थ्री स्टेजेस. फर्स्ट इज प्राइमरी स्टेज. अर्थ फॉर्म्ड अराउंड, एकदम शॉर्ट में बोल रहा हूँ, बस की पॉइंट्स लिखना. अर्थ फॉर्म्ड अराउंड 4.5 बिलियन ईयर्स अगो. It was still hot with a temperature of 8000 degrees in the core. Because of high heat, excessive energy erupted in the form of volcanic eruptions. Yeah, excessive energy came out in the form of volcanic eruptions. Along with it came gases like CO2, water vapor, hydrogen, helium, and trace amounts of nitrogen. शॉर्ट में लिखना है N2H2He. So this formed your primary atmosphere. Secondary में लिखेंगे water vapor eventually cooled leading to precipitation over lakhs of years. CO2 along with precipitation CO2 along with precipitation came down to oceans. Hydrogen and helium being lighter went to upper layers of atmosphere. We are left with an atmosphere with nitrogen in abundance. We are left with an atmosphere with nitrogen in abundance. क्या इस एटमॉस्फेयर में हाइड्रोजन हीलियम है? It is still there, but it is relatively in the upper layers, which is still today in the upper layers. अगर उस टाइम पे होगी तो ट्रेस अमाउंट्स में, इट वाज नॉट मच. SO2 भी होगी, बट इट केम डाउन विथ वाटर सारा कुछ. हाँ, along with this precipitation all the gases जो भी ट्रेस अमाउंट्स में थी वो भी आ गई. टर्शरी एटमॉस्फेयर we saw rise of cyanobacteria in oceans. Which was capable of doing photosynthesis. It led to the formation of oxygen. Thus making today's atmosphere with this composition. लिख लो, nitrogen, oxygen and argon. Sorry, ये सब इसी के बाद आने लगी जब साइनोबैक्टीरियाज एंड ऑल आए. तो यहाँ पर भी जैसे यहाँ पर यू विल हैव सम गैसेस, यहाँ अगर मीथेन भी आएगी, यहाँ अगर SO2 भी आएगी, so all of this can dissolve in your water and they'll come down along with water. तो यहाँ पे trace amounts में होगी gases. All the eruptions that we see from volcanism today, all those gases that can be released from volcanoes can be released in the primary atmosphere, but all of it came down along with water. Secondary stage में वापस आ गई पानी के साथ नीचे. Primary में होगा, primary में it is not just that these gases are there, there can be host of other gases here in lesser quantities, but all of these gases came down along with water. CO2 इसलिए बोला because CO2 was in abundance. ऐसा नहीं है कि बाकी गैसेस नहीं है, यहाँ पर और भी गैसेस हो सकती है, ऑल ऑफ इट केम डाउन अलोंग विथ वाटर. So we understood what was primary atmosphere. Major thing that happened is volcanic eruptions. Because of it, there was a process called degassing. ये term लिखना है, लिख सकते हो आप. Degassing is erupting out of all the gases that was there. Gases that were present were mainly CO2, hydrogen, helium, water vapor, nitrogen. There can be other gases in trace amounts. So this happened in the primary atmosphere that is there. Then came secondary atmosphere, condensation and precipitation. Here we saw the formation of oceans. Gases that are there is CO2 became in abundance, remaining are in lesser amounts. Then came cyanobacteria. This cyanobacteria led to photosynthesis, thus we got oxygen in this particular atmosphere. This is what is today's atmosphere. Although there can be a mains question on, are we moving towards fourth atmosphere because of pollution, climate change nahi, because of pollution? Are we moving towards fourth atmosphere where we are increasing the levels of other gases, anthropogenic changes? Now understand, we are in this atmosphere where we have nitrogen, oxygen and argon, these three gases in abundance, almost constituting 99.9%. These gases we call them as constant gases. अभी जो आपका नीचे composition है ना, वहां पर ऐसे बना लो composition. Just make three constituents are there. One is gases, next is your water vapor, and third is your aerosols. Now keep jotting down along with the board itself. कुछ बहुत ज़्यादा dictate करने के लिए नहीं है इसमें. So we have gases, water vapor and aerosols. Within gases, there are constant gases. Constant gases are these three. By this word constant, I mean if you go anywhere on the earth up to a height of 80 kilometers, their proportion remains relatively constant. So you take an air parcel here, you take an air parcel 10 kilometers above this, you take an air parcel 20 kilometers above this, you will see their composition almost constant. थोड़ा बहुत point में vary कर सकता है, but relatively it is constant. They are called as constant gases. Then you have variable gases. Now these gases, their composition keeps on varying. They are not constant throughout the earth. Within this, we'll understand, yeah, we'll read about two important gases, that is carbon dioxide and ozone. पहले इसको देखते हैं, then we'll move on to water vapors and aerosols. So carbon dioxide is one major important gas that we have. Most important function of this carbon dioxide is it acts as a greenhouse gas. What do you mean by greenhouse? Temperature stabilize. कैसे करता है temperature stabilize? Trap. See, what greenhouse term came from Russia, where they used to grow. Siberia is very cold, so in colder regions they used to grow crops under a house that is covered with green, and this was done with an intent to trap radiations there so that temperature here is relatively higher. So this, the similar role is what is played by your CO2 as well. It allows short wave radiations and it traps long wave radiations. Short wave radiations, the radiations that are coming from the sun is short wave. Whatever we are emitting, whatever earth is emitting is long wave. This short and long are relative to each other. This is not absolute short or absolute long. If a body is at a higher temperature, the wavelength that it will emit will be lesser, short wave. Sun is at a higher temperature compared to earth, the wavelength of emissions that it will have will be less. Earth is at a lower temperature, so if temperature is less, whatever the earth will emit will be at a higher temperature. In physics we have a formula, lambda T is equal to constant. जिसका साइंस बैकग्राउंड में पढ़ा होगा, यहाँ पे नीड नहीं है. दिस इज जस्ट टू एक्सप्लेन दैट whichever body is at a relatively higher temperature will give you shorter wavelengths, the body at a relatively lower temperature will give you longer wavelengths. This happens. So sun will give out shorter wavelengths. This CO2 acts almost transparent. I'm saying almost, ऐसा नहीं कि पूरा ही है, but almost transparent to short wave radiations, and it traps long wave radiations. That means it reflects back all the long wave radiations that are there. And because of this important role, what we see here is it acts like a blanket on the earth, and it maintains the average temperature of the earth. Had it not been there, the average temperature would have been minus 18 degrees. But just because of greenhouse gases, our average temperature is 15 degrees. So there is this difference of, kitna difference hai ye? It is about 33 degrees. Because of this greenhouse gas, we are having this much difference. Imagine पूरे earth का temperature 30 degree से बढ़ा दिया. This is what is this role played by CO2, and this CO2 is not even 0.1% of the atmosphere. CO2 and other greenhouse gas. Now understand all of your hue and cry about climate change. If we keep on increasing the levels of this greenhouse gas, whenever I am saying CO2, this does not mean only CO2 here. I am talking about all other greenhouse gases also. They are also playing the similar role here. So imagine if we increase their level from 0.1% of the atmosphere to 0.2, agar double kar diya, how devastating it would be for the climate of the earth. Just 0.1%. Remaining 99.9% of gases, your nitrogen, oxygen and argon, they are almost inert gases. They don't normally react. All of these gases that are 0.1% of the gases, they take part in all the phenomena. These are almost inert. Nitrogen is inert, argon is inert, oxygen does not normally react. So Sara hue and cry is all about this 0.1% of the gases that is there. And this greenhouse gas is leading to an average temperature of the earth around 15 degrees. So this is one major role played by your carbon dioxide. Next comes ozone. Now, ozone, as we know, protects us from UV rays. Where do we find ozone? In the stratosphere. Okay, so it is not a constant gas, its composition varies. We will not find much ozone here, although we will find ozone as a pollutant. पढ़ा होगा environment में, we'll find ozone as a pollutant, but this ozone that I am talking about is the ozone that lies in the stratosphere. Up there are three things. One is formation of ozone, second is destruction of ozone, third thing is depletion of ozone. Formation and destruction, these are natural things. It keeps on happening regularly, frequently, every day, every time it is happening. What concerns us is depletion of ozone. This is where your CFCs come in. We'll understand formation. How is ozone formed? We have oxygen molecule reacting with normal oxygen atom to give you ozone. This normal oxygen atom was formed because of oxygen molecule in presence of UV rays break down in oxygen atoms. So this happens in presence of UV rays. So this UV rays is absorbed by ozone layer there when it is using this UV to break down the oxygens here. So it is using this UV rays. This is where UV rays are being absorbed there. But at the same time, this is your formation that is happening. At the same time, you have ozone. Because of UV, ozone also gets destructed. This is a natural thing that keeps on happening, and because of this your UV rays are absorbed in the ozone layer, because यहाँ भी यूज हो रही है बनाने में, डिस्ट्रक्ट करने में भी यूज हो रही है. So your UV rays is occupied here. Although I am saying this in a very layman terms, बस ऐसे ही नहीं होता है. There are host of other things, but from exam point of view that is not important. Just to understand, UV rays is occupied with oxygen and ozone molecules there. इसीलिए UV rays are blocked by ozone in stratosphere. अब this thing keeps on happening, but थोड़ा सा एटमॉस्फेयर का देखते हैं. You have tropopause here, let's say. We will deal with this later on. Tropopause, this is your ozone layer. 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 This is your ozone let's say around 15 degree, then you will have for this to happen, you need oxygen and you need abundance of UV rays. Let's say this is tropopause. From here you have stratosphere that is there. Maximum formation happens where we have good amount of sunlight also. UV is for example, I'm just saying sunlight. You have good amount of sunlight and good amount of oxygen. As we go higher up, oxygen can travel till here. Sunlight will also be relatively higher as you are going up. So sunlight is also maximum here in 40 plus range. Your oxygen is also there. So we start seeing good formation of ozone in this region. But because sunlight is higher, we also see high destruction of ozone also. So this is where you have high formation and high destruction of ozone. Tell me, is ozone heavier or oxygen heavier? Ozone heavier. So as ozone is formed, some of the ozone comes, because it is denser, it is heavier, it comes slightly below this. So we start seeing maximum concentration of ozone in this layer, and this is where you have your ozone layer situated. This is where you have your ozone layer situated. Even though maximum formation and destruction of ozone is happening above this layer, maximum layer is situated, yeah, maximum concentration of ozone is situated in this particular layer. So this is where you have maximum concentration. But what concerns us today is your CFCs, chlorofluorocarbons. It consists of chlorine, fluorine, and other fluorides and chloride families. What will happen is you have Cl2. This Cl2 molecule will, let's say, combine with extra oxygen atom that is there, and it will form ClO. So now there is no oxygen left for ozone to be converted, for oxygen to be converted into ozone here. It has used up that. Also, what it will have, it will do, two ClO molecules will combine to form Cl2 and O2. So it will use all of this O to form again O2. Then again this O2 will break, and that oxygen will be used here. So ozone is not forming in this process. Even though ozone might be destructing consistently, but ozone is not forming when you have chlorine atom coming in the picture. And one chlorine atom, now this Cl2 can again be used here in this reaction. So one chlorine atom keeps on doing this. One chlorine atom can destroy thousands of your oxygen molecules, your oxygen atoms. So this is why we have chlorine, yeah, CFCs as a cause of concern, because it destructs this normal natural reaction that is going around. It eats up all these extras O, yeah, oxygen atoms that are present there. Because of this, what we bought, instead of CFCs we switched to HFCs. HFCs का क्या दिक्कत है? This was ozone depleter, but this is greenhouse gases. So for this we have Montreal Protocol, but for this we bought Kigali Amendment. भूल गए हो ना सब? हो गया ना environment? याद रखो चीजें. So maximum formation and destruction. Then we have a layer of maximum concentration. This is where your ozone layer today is situated. And depletion is caused because of your CFCs. It is happening. Important role is it blocks UV rays. That is harmful for us. क्या? हाँ, नहीं भारी होगी, भारी होगी. अब आप चेक करो, क्लोरोफ्लोरोकार्बन, हाँ, ज्यादा होगा. इफ यू कैलकुलेट द वेट, CO2 इज जस्ट 44. अरे ऊपर क्यों जाती है? दिस इज नॉट एब्सोल्युटली हैवी. आई एम नॉट सेइंग दैट इट विल गो हायर अप बहुत ज्यादा, बट थोड़ी तो ऊपर जा सकती है ना. Gases can go above. If the temperature is increased, they'll become lighter, they'll rise. Next component of atmosphere. Atmosphere has right now three components: gases, water vapor, and aerosols. Gases we have seen constant and variable gases. Next is water vapor. Now, role in the atmosphere, importance for precipitation. I think this is self-explanatory. It acts as a temporary greenhouse gas. What do I mean by temporary greenhouse gas? If water is present in the atmosphere, it will act as a greenhouse gas. But let's say precipitation happens. If the precipitation is there, then there is no water vapor. Yeah, less amount of water vapor is left. So its composition keeps on changing depending on the precipitation that is happening. So if it is there, it acts as a temporary greenhouse gas. It traps radiations. But if it is not there, then it will not act as a greenhouse gas. है ही नहीं वहाँ पर. Variation with latitude. How will water vapor in the atmosphere vary with latitude? Will you have, see, this 0 degrees equator, this 90 degrees poles that I'm making here. Where will we have higher water vapor in the atmosphere? Equator pe, do you think water vapor will be high? We have high insolation, high evaporation. This should lead to high water vapor. But at the same time, there is continuous precipitation. 4 o'clock rain we'll also see there in the equatorial regions. So every day, whatever water vapor is in the atmosphere also comes down. So this should lead to decrease in the water vapor concentration. Both the things are happening on the equator. There is continuous evaporation of water vapor. At the same time, there is continuous precipitation. So we will see, even though relatively higher water vapors, but it will not be the highest that we might see. What about poles? Less insolation will be reaching on the poles. If less insolation on the poles, you will see lesser evaporation, less water vapor in the atmosphere. I'm talking about hawa mein kitna pani hai. I'm not talking about ground or anything. Whatever amount of water vapor is there in the atmosphere, I'm talking. Now tell me about tropics. Let's say Tropic of Cancer. Up compared to ocean, will it be less? Will it be more? How will I see? Why? Is there precipitation happening on Tropic of Cancer? It compared to, see, I'm comparing with equator. Compared to equator, very less precipitation. What about evaporation? Can I say अब थोड़ा सा I'm just bringing in आगे वाले concepts जो हम बाद में देखेंगे. But in equator we have rising winds. On equator we see continuous evaporation and cloud formation. On tropics we see descending winds. Descending winds will give you clear sky. Can I say clear sky means continuous high insolation? Continuous high insolation will lead to higher rates of evaporation. So on tropics, what happens is you have continuous high insolation and high evaporation. What happens on equator? Even though you have higher insolation, some of the insolation is blocked by clouds. Second thing, even though water vapors are evaporating, some of the water vapors coming down because of precipitation. Relatively very less precipitation is here. On equator you will have almost a daily precipitation. So here whatever water vapor is there in the atmosphere, even though evaporation rates might be higher, precipitation rates are also higher, we see relatively less presence of water vapor here compared to this region. Comparatively, feel hoga nahi hoga, that is different. What is humidity that you will feel? I know you will see, you will say, sir, higher humidity will be felt in equator. Feeling of humidity is different. I am just talking in absolute terms. In absolute terms, water vapor in the tropics can be higher than equator. Is this clear? Because of two favorable things, high insolation, high evaporation is there. Here, insolation, even though might be there, it is blocked by clouds, and secondly, your precipitation brings down some water vapor on the equator. यहाँ पर again there can be decrease in the water vapors, very less insolation, very less evaporation of water vapor. Is this clear? Do take care of tropical regions. हाँ जी, आपकी आधी आवाज कट रही है. जिसके एब्सेंस लाइफ ही पॉसिबल नहीं होगी. ऑक्सीजन. हाँ, we need greenhouse gases for life as well. मतलब had this not been there, had this not been for life there, your average temperature of the earth will not be maintained. If average temperature is not maintained, life might not be possible for us. Might some other bacteria might be there even if you have minus 33 degree or minus 18 degree. Life can be there because of this, but we might not be able to survive. Will not say सारे important है. They have their roles to play, but they are not the major thing that is there. हाँ, variation with height. Acha, what we'll do one thing. I'll take up all the doubts in the break. If it is very much related to this, then I'll take up in the class. Rest doubts can like we'll do it in the break, because else the complete flow of the class is disturbed. Variation, variation with height. Now as we go above, as water vapor rises, as the water vapor is rising, ये लिखते जाना है ना अपने हाथ से. Variation with height, as we go higher up in the atmosphere, as we go higher up in the atmosphere, tell me what happens to temperature. It decreases by what rate? 6.5 degree. This is normal lapse rate. We'll come to this after a point, but normal lapse rate is this, that it keeps on decreasing. So even we have water vapor at some temperature here on the surface. As you go higher up, can I say its temperature will also decrease? Its temperature keeps on decreasing. अब आप समझो, it is 6.5 degree. If I'm going about 5 kilometers higher, 5 kilometers would mean how much decrease? Approximate it would be 30, कितना हो गया, 32.5 degree. At earth, can I say temperature of water vapor that is there would be somewhere around 30 degrees. So by this temperature, if I'm decreasing the temperature by 32 degrees, that means up to a height of 5 kilometers, almost all of water vapor will cool down. So if water vapor is condensing, can I say it will precipitate also? I'm not saying all the water vapor will precipitate, but what you will experience is almost 90% of the water vapor that is there will be confined to first 5 kilometers, because water vapor yahin se aa raha hai and it keeps on decreasing, it keeps on condensing as we go higher up. Normally we'll have 30 degree temperature yahan par example ke liye. As we go about 5 kilometers higher, the temperature will dip to around 0 degree where water will condense. So you will see 90% of the water vapor confined in the first 5 kilometers. This does not mean that beyond 5 kilometers there is no water vapor. We'll have water vapors even higher up in the sky, but maximum is concerned here. So variation of water vapor with height and with latitude. Is this clear? With latitude, very less at poles, higher at equator, but even higher at tropics. Okay? With height, it decreases, it keeps on decreasing, because जैसे जैसे ऊपर जाओगे clouds बन गए, water vapor is confined here itself. Sometimes it will rain, so it keeps on decreasing. As we go to 5 kilometers, almost 90% of the water is there. Next, third component is aerosols. Now what are aerosols? These are your solid or liquid particles that are suspended within the atmosphere, yeah, within the air. So you have some solid or liquid particle suspended. From where will it come? It could be anything. It could be dust particles, it could be some kind of pollutants, कुछ भी हो सकता है. So all of these particles, it might came from, let's say, your volcanic eruptions and all. So all of this constitutes your aerosols in the atmosphere. They are not gases, they are not water vapors, they are some solid or liquid particles that are there. They have certain role to play in the atmosphere. Most important being, they act as hygroscopic nuclei. What does this mean? They provide a surface for water droplets to condense. So it is this hygroscopic nuclei around which your water vapors will start condensing and they'll start forming clouds. So most important function is they act as hygroscopic nuclei. Exact process is not important, कैसे हो रहा है वो चीज. Next function is reflection. Reflection, they reflect, yeah, they have slight albedo that reflect back all the sunlight that is coming from. So let's say a volcanic eruption happened here, and this is a normal area. Here, if you have more and more aerosols in the atmosphere, what we experience is sunlight that is coming from above, yeah, insolation is reflected back. We experience relative cooling because of presence of aerosols for 1 year, 2 year, 3 years, depends on how much aerosol has been suspended. Because of this, यहाँ पे कम aerosols है तो यहाँ पे greater insolation can pass. We'll see relatively warmer temperatures in this region. So they reflect back solar radiation. Next is absorption. Absorption, have you heard about black carbon? But what happens, what black carbon does? Let's say you have mountain covered with snow here. This black carbon will be deposited on the surface of snow. Yeah, will be deposited on the snow. As it is black, albedo of this particular black carbon particle that was deposited will be higher or lower. Very less albedo because the body is black. Albedo is higher for whiter bodies. So more and more reflection will be there if there is no black carbon being deposited. As more and more black carbon is deposited, it will absorb more and more heat that is there. More heat is absorbed, greater rise in the temperature of this particular area, more melting of snow, yeah, ice जो भी है. So it leads to absorption. So उल्टा effect भी है, it leads to absorption of rays because of which there can be greater melting. One last thing is scattering of light. Because of dust particles and all the aerosols that are present, they scatter the light and we see blue color of sky. This is all because of scattering that happens. Scattering or reflection में difference पता है? What is scattering? What is reflection? Not important from your exam point of view, but let's say you have a particle, sun rays are coming, it is reflecting back. This is reflection. But let's say particle size was very small. Sun rays are coming, it will scatter the sun rays into its components. This is what is scattering. This happens if diameter of the particle is relatively greater compared to the wavelength. This happens when diameter of the particle is very small. बस ये difference है यहाँ पर. So four major things you have. It acts as a nuclei, then you have reflection, absorption and scattering. जो तीनों चीज लाइट के साथ हो सकती है. हाँ, scattering can be refraction से scattering. Refraction is totally different phenomena वहां से, but there can be total internal refraction जिसके कारण से you might see after this surface some kind of scattering that can be there. हाँ, Impact is you see blue color. Heat budget पे scattering का as such impact नहीं है. मतलब normally we will not discuss about impact of this scattering on heat budget. This scattering is the role played by this, and because of which we see blue color. We are coming to the layers of atmosphere now. Now layers of the atmosphere can be divided on two things. One is composition, second being on the basis of temperature. Composition is we divide them into homosphere and heterosphere. By this only you can see homo and hetero. Homo means something is homogeneous. This something is the concentration of your constant gases that are there. So till up to 80 kilometers. 80 kilometers is where you will have your mesosphere. So till this you will see relative consistency of gases that are there. After which you will start seeing, after this you will start seeing your gases based on their densities. तो जो भारी है वो यहाँ मिलेगी, जो हल्की है वो ऊपर चली जाएगी. Till here you can start seeing all the gases. So gases are uniformly distributed. So someone was asking CFCs. CFCs can go up to 80 kilometers as well. कोई पूछ रहा था ना. Heterosphere goes beyond 80 kilometers, and there they are layered according to their molecular masses या densities here. On the basis of temperatures, we'll have layers distributed depending on how temperature is varying within those layers. These are on the basis of temperatures. Abhi we'll see in troposphere temperature is decreasing, then in stratosphere it is increasing, then again decreasing, increasing, and so on. So we will have various temperature profiles for all this. We'll take them one by one here. First is troposphere. Now what happens in troposphere? Tropos means your turbulence or mixing of air. So any kind of weather phenomena that we'll normally study will happen in the troposphere, where mixing of gases is happening. So in tropos you will have turbulence, yeah, mixing of air that is happening. It is the lowermost layer that we have. इसके key points बस jot down कर लेना जो आपको इसमें से लग रहा है. Almost everything is written here. So mixing of air, and it is the lowermost layer. अब height, let's say this is your equator, this is your pole. At equator it will be at a slightly higher height compared to your poles. ज़्यादा नीचे बना दिया, but this would be around 6 to 8 kilometers. This would be around 16 to 18 kilometers. So there is a variation of the height of troposphere depending on whether we are at equator or we are at poles here. This lid, your top layer of troposphere, is what we have, tropopause. We'll have a tropopause here. As we have seen, almost all the water is confined within the upper layers only. So we'll have almost 90% of mass, and almost all of water vapors, I should say, almost all of water vapors will be confined within the troposphere itself. Temperature will be decreasing at a rate of normal lapse rate. Although there are other variations depending on climatic stability, you have wet adiabatic, dry adiabatic lapse rate and all. We do not need to go into the technicalities of it. Normal lapse rate is 6.5 degrees per kilometer. This is the rate at which your temperature keeps on dipping if you go higher up in the troposphere. लिख लिया? Now why is temperature decreasing with height? Can anyone tell me why is temperature decreasing with height? अभी बता तो दिया 6.5 डिग्री से कम हो रहा है, but why? Sorry? Greenhouse gases are decreasing and terrestrial radiations are decreasing. Now you need to understand Earth is not heated from above. Normal temperature that we feel is because of the long wave radiations that are coming. So these radiations are coming from the earth, from the bottom. As you go away from the earth, this heat that you will feel keeps on decreasing. So as you go higher up, this temperature that you can feel keeps on decreasing, because radiations, the long wave radiations, are more near to the earth. So we feel this heat because of long wave radiations here. As we go above, temperature keeps on decreasing. Secondly, you have greenhouse gases in the atmosphere that are trapping this. Relatively, if we keep on going higher up, we will see relative decrease in the concentrations of greenhouse gas. If these are relatively decreasing, can I say they can trap more radiations near to earth? So more and more radiations are trapped near to earth. That means near to earth we should experience greater temperatures compared to higher above. Next, one last thing, pressure decreases with height. ये लिख लेना बस ये 3 पॉइंट आप. Pressure decreases with height. We'll deal with pressure later, but let's say if I want to calculate pressure here at this point, pressure here in layman terms, just understand pressure here is the weight of all the air column that is lying above this. At this point, if I want to calculate pressure, I'll calculate what is the weight of complete air column that is lying above it. Similarly, if I'm calculating pressure at this point, I will calculate weight of all the air column that is lying above this. Up, tell me where will weight more? Weight is more in this point. If more and more weight is there, it will lead to more and more temperatures there. So as you go higher up, the pressure keeps on decreasing. As pressure decreases, particles expand, दूर दूर चले जाते हैं. Less interactions are there in the particle. Less interaction means lesser temperature या lesser energy released. So जैसे pressure keeps on decreasing, your temperature also keeps on decreasing here in the atmosphere. So pressure decreases with height. This leads to decrease in temperature. Three major reasons. They might give you this in the statements of assertion reason type question, that as you go higher up in the atmosphere, there is decrease in the temperature. Statement 2, decrease in temperature happens because pressure decreases with height. So they'll give you such statements in the second statement of your assertion reason type questions. इसलिए ये इंपॉर्टेंट है. ये मेंस में तो लिखने लायक चीजें है ही, बट आपके assertion reason क्वेश्चन के पॉइंट्स हैं ये सारे. Done. Now the top layer of your troposphere is tropopause. Tropo means mixing, pause is we stopped that mixing. So tropopause act as a lid that pauses all the turbulence, that pauses all the mixing. So it is acting as a lid, and beyond this we do not see normal mixing of things or normal mixing of gases, because till here they become cool enough to come down. This does not mean that we will not find any gas or any water molecule above this. Maximum weather phenomena or maximum things that we study will lie within this regions only. Height varies based on the height of your troposphere. Sound नहीं आ रहा है? हेलो हेलो, आ रहा है? अब आ रहा है. मैं ही माइक पास में रख लेता हूँ. See, you can just keep jotting down this key points that are there. पूरा detailed explanation नहीं भी लिखोगे तो इससे समझ में आ जाएगा. You can keep jotting down these points. Above the troposphere you will have stratosphere. Now stratosphere, one major thing that we have seen in the stratosphere is presence of ozone layer. It extends up to about 50 kilometers of the height. Now, as I have said, tropopause is an area where mixing and all the weather phenomena pauses. They ends there. So above this, we will see relative absence of weather-like phenomena, relative absence of clouds and all. That means above this layer, relative less clouds will be present. This does not mean no clouds will be present. Relative less clouds, relative less friction. So we'll see ideal flying zones in the stratosphere. So jets will fly in this layers. There is another reason that we also have jet streams here. उसको हम बाद में देखेंगे. Because of jet streams, we have this layer where it becomes favorable to fly aircrafts, depending on the direction of jet streams as well. Now here what happens is we have ozone layer, and because of ozone layer we have consistently UV rays being absorbed. Some kind of rays being absorbed, can I say, will increase the temperature. So here in this layer we will see increase of temperature. यहाँ लिखा नहीं क्या? हाँ, temperature increases with height, and it increases to such a level that it reaches back to 0 degree on the top of stratosphere. Top of stratosphere will be stratopause. So till that point it reaches back to 0. What will be the temperatures in and around your tropopause? Around -80 degrees. आप ऐसे देखो, कैलकुलेट भी कर सकते हो. 6.5 डिग्री से कम होगा. अगर आप 15 किलोमीटर ऊपर जाओगे तो 6 into 15 is 90. तो about 90 डिग्री से तो कम हो जाएगा. It will decrease by 90 degree from whatever it is there on earth. तो ऐसे करके भी you can get an idea that what temperature will it be in and around tropopause. Very less water vapor, so it is a very dry layer because maximum water layer is confined within your troposphere itself. But this does not mean all the water vapor is here in the troposphere. Some water vapor might move out of this layer, and because of which we see the presence of polar stratospheric clouds. And this polar stratospheric clouds, they are also called as mother of pearl clouds. बहुत ज़्यादा bright दिखते हैं, बहुत ज़्यादा pearlish दिखते हैं. And as the name suggests, they lie in the polar regions. And these clouds, they increase the ozone depletion in that particular region. They create favorable conditions leading to ozone depletion. They, ये जो reaction हमने देखा था, that it eats up all the molecules, this particular reaction is catalyzed because of this presence of polar stratospheric clouds. So they lead to increased ozone depletion in the upper reaches. So if more polar stratospheric clouds are being formed, we experience greater ozone depletion, and this usually occurs near the poles. वहीं मिलेंगे आपको. Now again, stratopause, it will pause whatever thing was happening in the stratosphere. In the stratosphere, one major thing was temperature increases with height. Till stratopause, you will start, after this you will start seeing again decrease of temperature. So rise of temperature is stopped. Pause is, they are stopping whatever activity was happening there. So rise of temperature now stops at stratopause. Then you will again see decrease in the temperature here. See, all these layers that we have, tropopause, stratopause, these are isothermal layers. Isothermal is temperature remains same. So if we, let's say this is tropopause or troposphere that I'm drawing, if temperature is decreasing consistently, then on tropopause you will have relative consistency of temperature. Then again temperature keeps on increasing in the stratosphere. Then on stratopause you will see relative consistency for a few kilometers. So this is stratopause, this is tropopause, isothermal layers, these are there. Relatively temperature is constant in these layers. They create favorable conditions for this, for chlorine dissociation and for oxygen. So chlorine and oxygen reaction, for that they cause favorable reactions. Polar vortex abhi hum dekhenge. Polar vortex is a separate, complete separate phenomena. It is a zone of your pressure there that leads to other kinds of phenomena. So usko hum jet stream mein dekhenge अच्छे से, polar vortex को. This is just a cloud that is there. vortex is a completely different thing. हाँ हो सकते हैं बट इट इज अ सेपरेट थिंग. उसमें क्लाउड हो सकते हैं, दैट डजंट मीन vortex एंड क्लाउड सेम है. Mesosphere. Now mesosphere is the third layer that we'll have. It lies up to a range of 80 kilometers, and here what we'll see is continuous decrease of the temperature that is there. So this is the temperature profile. We'll see continuous decrease of the temperature. Now this particular layer is least understood layer. यहाँ पर बहुत ज़्यादा इसके बारे में नहीं पता है साइंटिस्ट को. What happens actually in the mesosphere? Because even your hot air balloons cannot rise to this layer. यहाँ पर इस layer में. So normally hot air balloons are confined to your stratosphere. So whatever weather studies या upper layer studies are happening, it is normally confined to your stratosphere. सैटेलाइट्स जो है वो इसके ऊपर है, तो उनकी स्टडी सैटेलाइट्स ऊपर कर रहे हैं. इस लेयर में रिलेटिवली लेस knowledge is there for what all things happen in the mesosphere. What we know is temperature decreases and it reaches up to -100 degrees Celsius. यहाँ पर we start seeing noctilucent clouds. So if some water vapor escapes to this layer, we start seeing noctilucent clouds. But understand, for clouds to form, you need some kind of nuclei there. This nuclei is provided by, let's say, some meteor is coming. So this meteor burn. This meteor will release some kind of dust particles, yeah, some kind of particles that are there. This burn because when they start interacting with the atmosphere, they experience friction. As they experience friction, they heat up. This does not mean meteor burns here in the mesosphere. They start burning from the higher layers only. But this is where they almost completely burn out, in this mesosphere. So most of the meteors burn out completely in the mesosphere layer, even though they can start burning in the higher layers also. This is where they completely burn out. And when they burn out, they might leave some kind of dust particles that can act as nuclei for this noctilucent clouds. So यहाँ पर what we see is noctilucent clouds being formed here in the higher reaches. बहुत ऊपर दिखेंगे ये. Temperature was decreasing here. Beyond this, your temperature keeps on rising. So you will have mesopause here. Now decrease of temperature will be paused, and again you will have increase in the temperature in the next layer. कुछ लिखना है? Done. Again, next layer is thermosphere. Within thermosphere also we have one more layer, that is ionosphere. आपके इसमें अलग से लिखा है मैंने. So thermosphere comes, yeah, extends from 80 to 640 kilometers. This is from where you have thermosphere, but within thermosphere you have a layer called ionosphere. So it is not something that we count as a separate layer based on temperature. This is not based on temperature, it is just the presence of ions that is there. So here in this ionosphere layers, we see charged particles are ionized. So it is above your mesosphere, but within the thermosphere zone only. We see charged particles that we call as ions that are there, and this ions aids in the communication. So whatever are your radio satellites and all, they communicate using the ions that are present in the ionosphere. अब ये ions कैसे बने होंगे? These ions are formed because of absorption of your cosmic rays, gamma rays, X rays. So what all other high energy rays are there? Normally we study about UV rays being absorbed by ozone layer, but there are other rays also that are higher in energies than UV rays. So all those rays are being absorbed here by the gases that are there present there. So those gases absorb this and they dissociate into respective ions. इसीलिए above mesosphere we don't see relative consistency of gases. They also dissociate into their ions here. इसीलिए हमने पढ़ा था homosphere lies up to 80 kilometers and this is where you have mesopause. Because above this we start seeing absorption of cosmic rays, gamma rays, x-rays which are higher in energy and they dissociate your gases there. इसीलिए यहाँ पर हमको constant gases नहीं दिखती है because of this absorption. Now all these gases and their ions will lie in this layer depending on their weight. So if oxygen is heavier, we'll see oxygen first, then hydrogen, helium in the higher reaches. So pass mein you will see oxygen, then you will see nitrogen, and then you will see hydrogen, helium in the higher reaches. One major thing that happens because of this ions is auroras या auroral displays. There was this question in mains, याद आ रहा है? So what are these auroras? See, Earth has its own magnetosphere that is there. Sun is continuously emitting some kind of solar flares, solar rays, solar particles, magnetic particles are coming. As they interact with the magnetosphere of the Earth, these particles are deflected and they come near the polar regions where your magnetic field is relatively weaker. If this magnetic field is relatively weaker, these particles can enter to a greater lengths in the greater distances in the atmosphere. So here what we see is they enter to a greater distances up to the layers of ionosphere where these charged particles start interacting with the gaseous ions that are present in the atmosphere. Now this gaseous ions and interaction of this cause continuous excitation of ions, release of ions. In सबके कारण क्या होता है? Energy is released. That energy we see is in the form of light that is there. Now also this light, the color of this light depends on which ion was it. उतना डीप में नहीं जाएंगे कि किस कलर से किस आयन से क्या होता है, but again this color depends on what gaseous ion was present. If it is oxygen, different color. If it is nitrogen, different color, because सबका अपना अपना अलग energy level से. Depending on what energy is released, you will have different kind of light that you will see. But all of these things happen in this ionosphere where you see continuous interaction of charged particles from the sun interacting with the charged ions that are present in the ionosphere. ठीक है, बहुत ज़्यादा लिखने की ज़रूरत नहीं है. It happens in the ionosphere zone. Above this, above thermosphere, what we have is exosphere. So exosphere, there is no limit of exosphere. It extends beyond your thermosphere till the outer space. So it extends beyond thermosphere till outer space. There is no upper limit of this. Beyond means more than 640 kilometers. Temperature here will be high or low? It will be very high temperatures, but the temperatures won't be felt. Matlab, even if you take your hand out, temperatures here will be in thousands of degrees, but even if you take your hand out in such an atmosphere, you will not feel it because there is almost vacuum in exosphere. Particles are at a very great distance. एक पार्टिकल यहाँ है, दूसरा पार्टिकल 1000 किलोमीटर या 100 किलोमीटर दूर होगा. So there are no particles there to make you feel the temperature that is present there. So very high temperature, but temperature can't be felt. Up because particles are not present, can I say very less friction will be there. So in this exosphere is where we'll start seeing your satellites. The orbit of the satellites will be in higher reaches here in the exosphere normally. Uske niche, why are we not placing satellites? Because there will be friction, and because of friction there will be continuous erosion of your satellites. The satellites are placed in the higher reaches where we have almost vacuum. I'm not saying complete vacuum is there, but almost vacuum is there. Done. I think in 2024 there was question on troposphere. Next करें, अभी देखते हैं. Now how is the temperature varying? You need to focus on this. In troposphere temperature keeps on decreasing it decreases up till tropopause. Tropopause is at a temperature of, it varies depending on whether it is poles or it is your equator, but around -80 it can reach. Then you will have a zone of isothermal layer that we call as tropopause here, after which your temperature keeps on increasing. At this point temperature reaches almost 0 degree. Your temperature will reach almost 0 degree. Then again a isothermal layer, stratopause, temperature keeps on dipping. You will have mesopause here. Till here the temperature will be approximately -100 to -90 to -100 degree. Mesopause. Post that your temperature keeps on increasing. Done. Let's recall everything that we have done till now, then we'll move on to the next section. चलो just recall everything with me. कॉपी में मत देखो, खुद से बस दिमाग लगा के try to think what we did. We started with first thing, latitudes and longitudes. Your latitudes are parallels that are there. We measure them from equator 0 to 90 degree north and south of equator. These are your latitudes. Latitudes, based on latitudes you will have your insolation that is there. So maximum insolation within the tropics. Longitudes are meridians that are from pole to pole. We measure them from 0 degree from the prime meridian या Greenwich meridian towards east and west. So 180 degree east to 180 degree west we measure them. Ab this longitudes will have time differences. So every 1 degree longitude have 4 degree time difference. याद आ रहा है सब कुछ? Every 1 degree longitude will have 4 degree time differences. Then we solve some questions of it. Depending on time difference, we can calculate time difference. Motion of the earth. So earth is rotating, revolving on a tilted axis and in an elliptical orbit. मैंने शायद ये बताया नहीं. It is revolving in an elliptical orbit. Elliptical orbit means sun is not exactly in the center of this ellipse. Sun is at a slight focal position of this. थोड़ा सा center में नहीं है, eccentric है. अब these 2 points, this point is called as perihelion. This is aphelion. P से peri, P से pass, ऐसे याद रख लेना. P for peri, P से pass. So this position in which sun is near, you will have perihelion position. This position you will have aphelion position. So sun is revolving in an elliptical orbit, and that too it is not, earth is revolving in an elliptical orbit, it is not placed at the center here. Next, इसके बाद we moved on to evolution of atmosphere. We have seen 3 phases of evolution. याद है क्या क्या हुआ था? Next, composition. Give me 3 compositions. Gases, water vapor, aerosols. Within gases we have seen 2 things, constant and variable gases. Within variable gases we have seen 2 gases, CO2 and ozone. उनके functions याद है, importance याद है, ठीक है. Next we have seen water vapor, its role. Next, aerosols and their role. Hygroscopic nuclei, then reflection, absorption, scattering. Then we moved on to layers of atmosphere. Layers can be divided into based on composition and based on temperatures. Composition में you have homosphere, heterosphere. Homosphere up to 80 degree. Then you have heterosphere. On the basis of temperature, you will have troposphere, temperature declining, tropopause, stratosphere, increasing up to 0 degree, pause, mesosphere, pause, rise. याद आ रहा है? What happens in troposphere? एक एक major thing, all climatic या weather phenomena, ओजोन लेयर, हाँ जेट्स भी फ्लाई करते हैं, ओजोन लेयर भी है, बोथ. हियर मीजोस्फीयर, मीटियोर्स बर्न आउट, समझ नहीं आ रहा है क्या बोल रहे हैं, नॉक्टिलूसेंट क्लाउड्स, ठीक है. आफ्टर दिस यू विल हैव आइनोस्फीयर विच एड्स इन द कम्युनिकेशन, ऑरोरल डिस्प्लेस आल्सो इन दिस आइनोस्फीयर वाला रीजन. ठीक है, ऑल सॉर्टेड. वर यू एबल टू रिकॉल ऑलमोस्ट एवरीथिंग? ठीक है, ट्राई सॉल्विंग दिस. ये तो पढ़ाया नहीं. Thickness of the troposphere at the equator is much greater as compared to poles. At the equator, heat is transported to great heights by strong convectional currents. Is it? Do you have strong convectional currents at equator? At equator, you have low pressure area where you will see rising of air. You will see rising of air, but now understand, this is equator, this is poles. Air is rising here. Here, let's say, for example, I am taking 30 degree. Poles pe, it will be less than 0 degree. Let's say temperature is minus 10 degree here. First thing, energy of air particle, where it will be more. Can I say equator? It will keep on rising as it cools down. In order to cool down, let's say we have seen temperature of troposphere 30 tha, so let's take it 70 degrees. Minus 70 degree as the temperature of tropopause. That means it will cool from 30 to minus 70. How much difference? Almost 100 degree difference. For 1 degree, sorry, for 1 kilometer it takes 6.5 degree. For 100 degrees drop, it will take almost 16 kilometer. For 100 degree drop, it will take almost this much. I'm taking just rough numbers, है ना? Almost 16 kilometer height. But at the same time, let's talk about poles. It is already at minus 10. From here to here, it is a drop of around 60 degree with a drop of 6.5 kilometers. 6.5 kilometers, approximately 9 to 10 kilometers. So height of tropopause is relatively lesser here. Height of tropopause is very high here. We will see this, and this is mainly because winds here are having, air here is having higher convectional energy, and it can rise up to a great heights before cooling down. So it rises up to a great heights before cooling down. इसीलिए for this we'll have answer as it is the correct explanation for the statement given. 24 में पूछा था. Try this one. All are correct. Stratosphere temperature increases with altitude, we have seen because of ozone. Mesosphere temperature decreases, we have seen this as well. Lowest temperature recorded in the upper part of mesosphere, we have seen mesopause almost minus 100 degree. Tropopause is isothermal. All are correct here. Done. What about this? In which of these layers temperature increase with height? Mesosphere में it will decrease, stratosphere में increase, mesosphere में decrease. It will increase both in stratosphere and thermosphere. कर लोगे simple simple. All of these questions are either from TDS या CAPF, इन सब एग्जाम के questions हैं. चलो, coming to the next part, insolation and heat budget. What do you mean by insolation? It is the shot of incoming solar radiation that we call as insolation. Now, whatever solar radiations are coming on Earth, we'll start feeling different impacts depending on what is the position at which we are receiving solar radiations. So, as you can see from here, till this point, let's say, all the insolation will directly strike first here. If I am going beyond this, itna distance the insolation has to travel. Plus, it is also striking at a slant area. It is not striking perpendicularly, it is also striking at a slant area. That means whatever insolation is being received, it was supposed to be received within this area, but this got dispersed over to a greater area at the poles. So even though we received similar insolation, whatever we are receiving here, we received similar insolation in this region also. जितना यहाँ था उतना ही यहाँ है. This insolation was confined to this much area only, but this insolation got dispersed because of angular position. It got dispersed, so जितना आया था वो ज़्यादा लोगों में बढ़ गया. So can I say per unit area, if you calculate, you will see lesser insolation here and you will see greater insolations near the equator. Second thing, as any energy, yeah, heat is traveling, it keeps on losing energy. So insolation here has traveled this much, but insolation that was coming, it traveled this much plus this much extra distance. इतना तो travel किया ही है, itna extra it has traveled. If it has traveled this much distance extra, in traveling this much distance extra, it might have lost some heat compared to this. ऐसा नहीं बोल रहा compared to sun. Compared to this, it has traveled this much distance extra. So while it was traveling this much extra, it might have lost some heat. So again, the insolation that was coming near to the polar regions or near to higher latitudes, it has slightly lesser heat content because heat is dispersed in the atmosphere. It has traveled to a greater distance in the atmosphere. As it travels more in the atmosphere, it keeps on losing heat as well. So because of both these things, we see lesser heat or lesser insolation in higher latitudes, more insolation in the lower latitudes. Is this clear? एक बार just let's understand what is energy spectrum and how do we, what is the spectrum of energy that we receive. Can you tell me an electromagnetic spectrum of energies that we have? Different rays. First, higher energy, highest energies of cosmic, then gamma, X, UV, visible, infrared, micro, then you will have radio. So as you travel from here to here, energy keeps on decreasing, wavelength keeps on increasing. So from here to here, your energy decreases, your wavelength increases. Now understand, this part is absorbed somewhere in the space knee. This part is absorbed in the higher reaches of your mesosphere and above. देखा था, they absorb cosmic rays, X-rays, and ionization happens there. So this is absorbed in the higher reaches. UV rays maximum is absorbed in the stratosphere. Then we have visible light, VIBGYOR coming, but this is not the maximum part that we receive. We received maximum एनर्जी इन इंफ्रारेड, इसका क्वेश्चन आ चुका है। नॉर्मली हम यही लगाते, वी डोंट सी इंफ्रारेड, इसीलिए वी डोंट एक्सपीरियंस इट, वी ओनली सी दिस रेंज ऑफ कलर्स या दिस रेंज ऑफ लाइट. So what spectrum that we see is this much, 380 to 780, this is your VIBGYOR. But the energy that is received on Earth is around 5% of ultraviolet, about 42% of visible, and then we have infrared waves. This is what energy spectrum is received on the Earth, yeah, solar radiation that we receive here. And most of the infrared is absorbed by water vapor or gases that is there. Even oceans absorb. So infrared is absorbed there, visible is what you can see here. Ultraviolet is also present, इसीलिए आप sunscreen लगाते हो to protect from UVA, UVB, UVC and all. So this is what ultraviolet that escapes out from your stratosphere coming to the earth. Most of the light that we have is, yeah, energy is received in infrared. ध्यान रखना, it is not visible. Is this clear? If you want to jot down, you can jot down this aspect, that most of the light is in the form of infrared that we receive, around 53%. Done. Now we were talking about insolation. So insolation depends on angle of sun rays. We have studied that at what angle sun rays are striking, based on that your insolation will depend. So lesser energy per unit area if sun rays are falling at an angle. Next, distance from the sun. Now depending on at what position your sun is, if it is at perihelion position, if it is near to earth, if sun is here, earth is here, can I say this distance will be lessened compared to aphelion position? So if we are near, naturally we'll receive more insolation. So at perihelion position we'll have higher insolation. Duration of day and night. So if we have more daylight, yeah, more duration of day, can I say more insolation will be there? Basic. Sunspot. Now what are sunspots? And will we receive more or less insolation? More. Normally it happens कि हम उल्टा सोचते हैं. Sunspots are dark spots that we see in the sun. It happens every now and then. हाँ, वो sunspot cycle एक अलग है, but it can happen because of other phenomena also. Now why do we see this sunspots? Mainly because if some of the higher energies are released from at a released at a particular point, let's say this point released more flares, yeah, more energy is released, this point starts appearing darker to us. So it is dark because it has released more energy. Normally what we see here is, या जो हम समझ लेते हैं इसमें normally is, it is dark so it will release less energy. This does not happen. It is dark because it releases more energy, it has released more energy. If it has released more energy, can I say if more sunspots are there, that means more energy has been released. If more energy is released, more energy will come to earth, that means more sunspots, we might see more insolation. So more the sunspot, excess energy released, high insolation we can experience. And then atmosphere, you most prominent effect being albedo. So depending on what albedo is there in the in any atmosphere, we will have higher or lesser insolation. For example, more aerosols are present, more and more light will be reflected back, high will be albedo, less will be insolation. If you want to jot down, you can jot down these points. You might get a question on this, that in which of the following factors insolation will depend: angle of sun rays, distance from the sun, duration of day and light, sunspot, ऐसे करके. How many of the above? ऐसे only one, only two, only three, only four, all four, ऐसे करके they might ask a question. Done? लिखो लिखो जल्दी लिखो. Done? अरे sorry. हाँ, if aerosols are more in the atmosphere, more reflection या more albedo will be there, lesser temperature. Listen. Effects of atmosphere, albedo. देखा था ना, हाइग्रोस्कोपिक न्यूक्लियर एरोसोल का रोल क्लाउड के साथ नीचे आ जाएगा पानी के साथ. क्लाउड का भी है, एल्बिडो हर चीज का होता है. Now depending on your color of cloud you will have different albedos. If it is almost white it will have higher albedo, if it is darker it will have lesser albedo. Depending on body कितना white है उसका dark कम या ज्यादा हो सकता है. Done? Now heat budget. One thing, you're not supposed to remember values here in the heat budget. अब heat budget can be, one is vertical, other is horizontal heat budget that we can have. Vertical heat budget is what happens in the layers of the atmosphere that we are having. So let's say we are receiving 100% of the sunlight till here. After this we are calculating albedo. Three things will happen: either it will be reflected and scattered here, absorbed, or it will come to the earth. So within the atmosphere it will be scattered and reflected here within the atmosphere itself. It might be absorbed by the constituents of the atmosphere. It might come to the earth. The rays that are coming to the earth, they can be absorbed also, they can be reflected back also, depending on the surface that it is striking. If it is ice here, it will have higher albedo. If it is water here, it will have relatively lesser albedo. So depending on that you will have different absorption and reflection of different surfaces. Approximately out of 100% we are absorbing around 47% of the heat. एक रफ आइडिया, बिकॉज जस्ट इन केस यूपीएससी गिव यू एग्जैक्ट डेटा वाला वैल्यू, इन दो का बस ध्यान रख लो. आउट ऑफ 100% वी आर अब्सॉर्बिंग अराउंड 47%. but at the same time earth is also radiating emissions. Same thing will happen with this radiation. They can be absorbed in the atmosphere, they can be reflected back, and they can directly be lost to space. So out of whatever we are emitting, around 70% is going back to the atmosphere. We are absorbing 47% and around 47% is radiated back here out of what earth is emitting from here. Main ध्यान में रखने का value है this, that how much of it is absorbed. Remaining is either reflected back or absorbed in the atmosphere. Done? एक एक कंपोनेंट का नहीं पढ़ना है कि किसमें कितना हो सकता है. Horizontal heat budget. Now horizontal heat budget is whatever heat came to earth, how it is dispersed horizontally. So horizontally we will have torrid zone where maximum heat will be present, maximum heat is received in this area, very less या almost no heat is received in the frigid zone, and then you will have temperate zones that are there. So all of the climatology that we'll deal, it deals with how this heat is redistributed. This is redistributed with your planetary winds. This is distributed with your ocean currents. So all of this happen because of the redistribution of the heat that is coming. सबका primary reason is insolation that we are receiving, and that insolation how it is redistributed across the earth. अगर नहीं होगा redistribute, let's say somewhere in mains you are getting a question कि what will happen if this planetary winds are weakened, if ocean currents are weakened. आ सकता है question. What will happen? First major impact is this heat redistribution will be impacted. If this is impacted, more heat is retained in the tropics, you will have greater heat in the tropics, and less heat will be transporting to the poles. अब अगर यहाँ ज़्यादा गर्म होगा उसके इम्पैक्ट लिख देना जब मेंस में लिखोगे, यहाँ ज़्यादा ठंडा होने जाएगा उसके इम्पैक्ट्स लिख देना. So accordingly you can think and write. Primary thing is how is this insolation redistributed across the globe. This is giving rise to almost all of the phenomena that we'll see. Talking about heat, we'll also talk about horizontal temperature distribution. We have already covered vertical distribution. In all the atmospheric layers, we have seen how vertically temperature will be distributed. What about horizontal distribution of temperature? We'll come to isotherms in a while. But if I talk about horizontal temperature distribution, main thing that it will depend on is the insolation that you are receiving, and insolation received depends on latitude, at what latitude we are seeing. So if it is tropics, we will have greater insolation, poles mein lesser insolation. So latitude of the place determines the temperature of that particular place. It decreases from equator to poles, but keep in mind the tropics wala region, maximum temperature should be at equator. Depending on this, if it is decreasing from equator to poles, maximum temperature should be at equator, but it is not. We experience maximum temperatures within the areas around Tropic of Cancer and Tropic of Capricorn. क्यों बताया था? High clouds या high presence of clouds near the equator act as, yeah, they have relatively higher albedo, they reflect back the sunlight. At the same time, near the tropics, you have relatively clearer sky because of descending winds. We'll come to winds in a while, but they have relatively clearer sky. More insolation can be received. If more insolation, greater will be the temperatures. So यहाँ पर भी आप यहाँ पे दिख नहीं रहा है. So near to the tropics, it will be greater temperatures. इसीलिए जब आप यहाँ देखोगे, you will have desert regions also. उस पर भी हम थोड़ी देर में बात करेंगे. Altitude of a place. So even if we are looking on the same latitude, if altitude changes, temperature of that particular place will change. So on the same latitude, if you see, if this particular place is at a higher altitude, this place is at a lower altitude, this will have lesser temperature, because as you go higher up, the temperature reduces. In summers, if you check, many times it might happen that temperature of Dehradun is higher than temperature of Bangalore, because Bangalore is situated almost at a height of 900 meters. Dehradun is situated at a height of 600 or 500 meters. So Bangalore is situated at a higher altitude compared to Dehradun, even though Dehradun is at a very high latitude. Dehradun ऊपर है ना? अरे ऐसे क्यों देख रहे हो कि सुना नहीं है नाम? Dehradun is situated somewhere here. This is where you have Bangalore. It is at a this much higher latitude. I'm saying latitude. But because altitude of Bangalore is higher than Dehradun, in summers अभी नहीं होगा because अभी sun यहीं है. But in summers, if you see, it might happen when sun is on the tropics, it might happen that temperature of Bangalore is even lesser than temperature of Dehradun. This is all because of altitude. Okay? So as you go higher up, you will see decrease in the temperature. Next, distance from the sea, continentality effect. As we move further away from the sea, for example, you have Mumbai here on the coast. If I see on the same latitude and almost the same altitude, या same latitude की बात करें यहाँ पे, let's say you have another city here, Nagpur. So it will have relatively moderating climate या moderating temperatures because of continuous coastal winds या land and sea breezes, but it will have continentality effect. So if some place is situated away from the sea, it will experience continentality effect. It may lead to higher temperatures also and lesser temperatures also depending on the location. So if some place, let's say Siberia is there, Siberia is having lesser temperatures because of continentality, वहां पर moderating effect नहीं लग रहा है. साइबेरिया, रशिया, याद आ रहा है? वेयर इज इट? अंदर एकदम इंटीरियर्स ऑफ रशिया, नो आउटवर्ड्स टू सी, या सी नहीं है पास में वहां पर. सो इट विल हैव लेसर टेम्परेचर्स, नो मॉडरेटिंग इफेक्ट. हियर इट विल हैव हायर टेम्परेचर्स. So continentality can increase temperature also, can decrease temperature also, depending on where that particular location is. If it is in lower latitudes, that means if the location is in the tropics, continentality will play an impact that it will increase the temperature. If a particular place is at a higher latitude, आप कनाडा चले गए, आप रशिया चले गए, तो कॉन्टिनेंटलिटी विल प्ले एन इम्पैक्ट ऑफ डिक्रीजिंग द टेम्परेचर देयर. ठीक है. विंड्स, क्लियरली लू जब आती है आपको पता है क्या होता है. साइबेरियन विंड्स, very cold, they'll decrease the temperature. Land and sea breeze, they'll moderate the temperature. So winds also modify the temperatures. Ocean currents, almost same impact as winds. So depending on cold ocean or warm ocean currents, you will have their moderating effects as well. Next comes land and water distribution. So if northern hemisphere is having more land, now can I say land can be heated much faster compared to water. Water has a higher specific heat. Water has a specific heat of 4.2, air has a specific heat of 1. I'm not going much deep, but आप ये समझो कि in order to raise the temperature of water by 1 degree, you need 4.2 times more energy compared to what you are giving to air. तो air का temperature जिससे आप 4.2 डिग्री बढ़ा सकते हो, पानी का 1 ही डिग्री बढ़ेगा उतने में. So water will be heated at a slower pace compared to what air will be heated, या land will be heated. So if more land is there, can I say more heat will be there? Same way, if it can be heated faster, it will be cooled faster. So land can be heated faster also, land can be cooled faster also. So we will see greater variations in northern hemisphere. Summers will be very hot, winters will be very cold. It can be heated faster also, it can be cooled down faster also. Done? Vegetation cover. Now vegetation, it all depends on albedo of that. So if it is desert, it will have relatively higher albedo compared to rainforest. Rainforest में you will have great canopy cover, sunlight escape नहीं कर पाएगी, almost everything is absorbed there. So it all depends on albedo as well. Done? Factors: latitude, altitude, distance from the sea, winds, ocean currents, how land and water is distributed, vegetation cover. हो गया? मन में एक बार 7 पॉइंट बोलो, मन में बोलो. सीधा वेजिटेशन पे आ गए दूसरे के बाद. जब यस यस बोलते हैं तब बस हम यस बोल रहे होते हैं, हमारे दिमाग में रहती नहीं है चीजें. तो ट्राई टू बी अटेंटिव ऑन स्पेसिफिक पॉइंट्स, क्या क्या है वो चीज. latitude, altitude, distance from the sea or continentality, winds and oceans, they can go hand in hand, ocean currents, land and water distribution, vegetation cover or albedo also you can say. Now isotherms. What is isotherm? अब सबको पता होगा, पिछले 2 साल से सेम क्वेश्चन पूछा है यूपीएससी ने. So isotherm is a line joining all the points of same temperature. So if we choose any isotherm, this line will indicate all those regions which will have 20 degree temperature. So isotherm is a line that has same temperature. अब this isothermal lines, they can, depending on, चलो खुद से सोचेंगे इस पे, जनवरी है, let's say time is July. अब what we are about to learn is how will isotherms move on oceans and on land depending on what position sun is in. Let's say it is July. Where will sun be? Northern hemisphere, can I say? Let's say this is equator. This is where you will have India. This is where you will have tropics. Approximately sun will be somewhere here. Okay? That means land will be heated. It can be heated much faster. Now I am drawing isotherms here. Up tell me, if I check at a particular location at this and on the same latitude at this, temperature of which 2 points will be higher? Out of these, which 2 points? Land will be higher. For higher point, let's say I am saying it is 30 degree. For this, let's say it is 25 degree. Example के लिए ले लिया है. It will be at a higher temperature. It is at a lower temperature. Now I want to draw a 30 degree isotherm here. I want to draw a 30 degree isotherm. Up tell me, if let's say all these points are lying on 30 degree, if I want to look in the ocean, if I am looking in the ocean, where will I have 30 degree? हाँ, नीचे या ऊपर? नीचे, can I say? So somewhere here you will have 30 degree. Somewhere here you will have 30 degrees. And as I go to the land, 30 degree points are here. So can I say I'll have an isotherm something like this? And then if I'm coming back to the ocean, it will again come down like this. समझ में आया कैसे बनाया है? I'm just seeing कि which 2 points on the same latitudes will have a higher temperature, or they are at a lower temperature, depending on they are on land or they are on water. Land will have relatively higher temperature because it is summer time. Had it been winter, यहाँ का टेम्परेचर ज़्यादा होता. So same चीज को if I draw for winter, I am drawing in this color with for winter. In winter, let's say if this is 25, where will I have 25? At this point, is it greater or less than 25? It will be less than 25. Now if I want to go to 25 degree on land, because it is winter, land will be cooled faster, या land will be relatively cooler. So I'll have to go towards the equator. Let's say at this point I am experiencing 25 degree in winters. So I'll draw an isotherm something like this. If I go back to the ocean, I'll go here. So depending on the time that is given to you, whether it is summer time or it is winter time, that means either it will be January, this is for January, and this is for July. Your isotherms will either dip towards the equator or they'll go towards the poles when they are crossing the land, या they are crossing the continents. समझ में आया कैसे बना रहे हैं हम? Just take 2 points on the same latitude, compare whether they are having higher temperature or lower temperature depending on whether it is summer or it is winter. Basic funda is land will be heated faster and land will be cooled faster compared to water. Depending on that, you are supposed to draw isotherms. Uske accordingly you will have to solve question. 24 and 25, दोनों साल it was almost the same question that UPSC has asked from isotherms. Almost the repeat. We'll see the question as well. इसको बनाना है तो बना सकते हैं. Then we'll move forward. Online people, don't worry, I'll provide the PPTs as well. नहीं, विंटर टाइम है ना, नहीं आप हम्म 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 नहीं, आप नॉर्मली देखो कि जैसे हम टुवर्ड्स द इक्वेटर जाएंगे तो ये इक्वेटर के पास जाते जाते टेम्परेचर बढ़ेगा। ये तो मैंने बस इंडिया ले लिया, आप इन जनरल देखोगे लैंड मास। अरे ये भी तो लैंड मास ही है ना। हम्म डन। So these are the variations that you will see, but हम ये बना चुके हैं। In January, isotherms bend north over the oceans. We have seen in January it is bending north over the oceans and south over the continents. So in January it will bend south over the continents. अभी ऐसे बनाया था ऐसे in January. In July it will bend south over the oceans and north over the continents. जुलाई में ऐसे बनाया था, याद आ रहा है? So this was continent. It bends north over the continent, south over the oceans. Cold ocean currents will bend isotherms northwards in the northern hemisphere and southwards in the southern hemisphere. Now understand this. You have cold ocean currents will bend the isotherms northward in the northern hemisphere. Sorry, southward in the northern hemisphere. How we'll experience? We'll see this. You have a cold ocean currents. Huh. So you have which current flowing here? This is northern hemisphere. This is Africa. We'll come to ocean currents, but जिसको याद है बताओ, which current is flowing here? It is Canry's current. So Canry's current is it is a cold current. It is bringing cold waters to relatively lower latitudes. If it is bringing cold water, can I say कि अगर मैं यहाँ 20 डिग्री देख रहा हूँ, if this is 20 degree isotherm, at this point and this point will be relatively cooler. In order to reach to 20 degree, I'll have to move towards नीचे. So cold currents will bend isotherms southward. It is bending isotherms southwards in the northern hemisphere. But at the same point, if you see here, it is southern hemisphere. This is which current? Peruvian current. This is Peruvian current, again a cold current. If I am drawing again 20 degree isotherm here, at this point and at this point, can I say if this is cold current flowing, this point will be much cooler? In order to go to a relatively higher temperature, I'll have to go towards the equator. If I'm going towards the equator, that means I'll have to bend towards north. So it will lead to bending towards north. ये टेक्निकल क्वेश्चन है, रटना मत कि कहाँ नॉर्थ कहाँ साउथ, एक बार में घूम जाओगे. It is better to always do it with some example and just see whether it is bending towards north or it is bending towards south. In exam also, don't memorize these things. It hardly takes 20-30 seconds. Memorize करोगे, गलत याद रह गया, भूल जाओगे, it will be negative marks. It is always better to spend 20-30 seconds and get to the right answer. Just understand the concept here, how we are reaching to that particular thing. Done? लिख लो, ये लिखना है तो. Are we going too slow? Are we going too fast? There are both sides. I'll go at the same pace then. Chalo, try solving this. We are already solving questions as well, so I may not have that question session at the end. हाँ जी, answer A, everyone. ठीक है. What about this? Again C, 24 and 25. Almost same question. Equator word means for northern hemisphere it will be southward. For southern hemisphere it would be northwards. इसीलिए बोल रहा हूँ रटो मत नॉर्थ साउथ एंड ऑल. डन. क्या आ रहा है सबका? व्हाट अबाउट दिस? Done. So maximum of the infrared waves are somewhere absorbed in the lower atmosphere by water and also on the sea. We are coming to temperature inversion. So another thing that is relating to, sorry, this is 25 previous year question. Temperature inversion. What does temperature inversion mean? See, normal temperature profile is we have relatively higher temperatures at the bottom. As you go above, temperature keeps on decreasing. But if somehow because of some event or some phenomena this normal condition has been reversed, by this I mean instead of having the warmer layer here, warmer layer is stuck somewhere in the higher atmospheres. So normal would have been if we are going above, temperature keeps on decreasing. But if somehow it happens that as you go above, temperature increases, or it might happen that temperature decreases to an extent and then it keeps on increasing, then it decreases. So this is the layer where you will experience inversion of temperature. It can happen directly on the land, so we'll have surface inversion, or it might happen at a certain height in the atmosphere. This is what we call temperature aloft. ये diagrams ऐसे बनाए जा सकते हैं मेंस में, but it can happen on the land itself directly or in the aloft conditions as well it can happen. So normal temperature profile is reversed. Temperature keeps on increasing if we go higher in the height. Why does this happen? There are 4 cases in which we will experience temperature inversion. One is if you have long winter nights, yeah, long colder nights. If nights are longer, you will have more time for your terrestrial radiations to escape out. Terrestrial radiations will escape out from the surface of the earth. That means more and more radiations from earth surface is going out. Can I say earth surface will be cooled faster? If somehow surface of the earth is cooled faster, if somehow this layer is cooled faster compared to this top layer, we will have cooler layer here in the bottom, and in the top layer we will have warmer layer. So colder nights will give you temperature inversion, but colder nights is not enough. Along with that, you need clear sky and calm air. Long night is needed so that there is more time for the radiations to escape out. Clear sky is needed so that there is no blockage of these escaping radiations by the clouds that are there, so that they can easily escape out. Calmer airs so that conditions in that particular area is maintained. अगर एयर तेज होगी तो हर जगह से हवा आके it will just moderate the temperature there. So you need calmer air as well. So you will see localized, let's say in this particular area air is very calm, we might see localized inversion of temperature here. Next, we can see inversions in mountains and valleys. यहाँ देखते हैं, नहीं है, ठीक है. In mountains and valleys what happen is, let's say these are the mountains. Radiations from the mountainous tops, they can easily escape out compared to what we have here. So if they easily escape out, we will have relatively colder winds. Yeah, this surface will become relatively cooler much faster. As it becomes cooler, the air gets dense and it starts flowing downslope. It starts flowing downslope. As it flows downslope, if there is some warmer wind here, it is uplifted and we will have warmer winds, and then we'll have cooler winds here. So here what we'll experience, colder conditions, and then aloft conditions will be warm. So here also we'll experience temperature inversion. Same in the stratosphere. Remember, stratosphere mein temperature was increasing. This is troposphere, tropopause, and then there was an increase in temperature in stratosphere. So in stratosphere also there is a temperature inversion condition. In fronts also we can experience temperature inversion. Fronts में क्या होगा? Let's say you have warmer wind coming from here, a warm front coming from here. Later on we'll see front as well. But if warmer front is coming from here you have colder या cooler front. This warmer being will be relatively lighter. So it will be lifted up as it encounters this. So it will be lifted. So what we'll experience is this region having cooler conditions, air aloft will have warmer conditions. So here also we'll experience temperature inversion. So it can be there in the fronts as well. Is this clear? वही लिखा है, radiation inversion, winter conditions, plain areas, continental interiors में you will experience radiation inversion. Air drainage inversion in mountains and valley regions. Frontal, where you have cold and warm air mass mixing together. There can be another type of inversion, that is advection inversion. Advection happens near your oceans. So let's say you have relatively cooler landmass during night time. I'm saying this landmass will be relatively colder compared to ocean. This is relatively warmer. If along with the ocean waters we have wind here, that particular wind will be relatively warmer compared to this. If this relatively warmer wind is coming to the shore, if this is coming to the shore, then this particular wind will be uplifted compared to this. If this is uplifted, you will have warmer winds on the top, cooler winds on the bottom. Again, this type of inversion can be possible. This we call as advection inversion. So we have different kinds of inversions that are possible. Basic funda is air below will be cooler, air above will be warmer. If anything that can lead to this type of condition, we can have inversion in that case. Done? करें आगे? एक बार बस implication पढ़ लेते हैं. These are self-explanatory. What happens is, you have warmer winds, you have cooler winds, relatively. This warm and cold are relative. Which is lighter? Warm is light, so it is already above. If warm is lighter, it is already above here. If it is cooler, it is already dense. That means now denser wind will not rise. It will stay here in this region only. It will not rise. So this temperature inversion leads to stagnant air. No vertical convection is observed. This is what happens in Delhi also. No vertical convection, no rainfall. If there is no rainfall, calm conditions will prevail. Because there is no vertical convection, you will not have rainfall in such. Also pollution dispersion will not happen because winds are stagnant, kahin nahi ja rahi hai. They are stagnant here in this area. If they are stagnant, your pollution will remain here, your air quality degrades. This is what happens in winters in Delhi. Fog and smoggy conditions, because of this pollutants will be there. Sunlight reaching the ground, again see, if more and more fog and smog is being created, your sunlight will not reach to the ground. Sunlight is not reaching to the ground, this layer is not getting heated. If this is not getting heated, this particular condition will prevail. So this condition prevails. If sunlight is not reaching to the ground, temperature inversion is maintained. It determines settlement, agriculture patterns, ये सारा कुछ है, ठीक है. But main funda is upper layer is warmer, lower layer is cooler, because of which air is stagnant and it keeps on sustaining itself because it is creating conditions such that this particular layer is not getting heated. ये disperse कैसे होगा? Somehow we are getting some kind of horizontal winds that are leading to dispersion of this particular conditions. Then only it will disperse. Coming to the next thing, water and moisture. See, when we talk about water and moisture, there is a term that we study, that is humidity. Any kind of water vapor that is present in the atmosphere, that we call as moisture. Ab humidity, with humidity we see two terms. One is absolute, second is relative. What does absolute humidity means? Let's say we are taking some air parcels. What is the amount of water vapor that is present in that particular parcel? That is absolute humidity. For example, let's say there are 10 molecules of water. Example के लिए, there are 10 molecules of water present in that particular air parcel. Now relative humidity is what amount of water vapor is present in that parcel compared to how much maximum it can hold. So it is relative to the maximum capacity of that air parcel. For example, let's say I'm talking about this air parcel. It is holding 10 amounts of water and right now the temperature is 30 degree. Its capacity here is, let's say, 20. At this point capacity is 20. So relative humidity, if I want to calculate at this temperature, relative humidity is, it is holding 10 amounts of moisture at a capacity of 20. That means for here humidity is 50%. और मैंने percentage directly लिख दिया, into 100 नहीं करा, चल जाएगा, ठीक है. Now this holding capacity of water depends on temperature. So as we keep on decreasing the temperature, see what happens is, कोई भी air है, आप temperature बढ़ाओगे तो it will expand. If the air parcel is expanding, it will have more pores in it. more and more spaces will be there. That means its holding capacity will be increasing. As it cools down, it will contract as well. So if I am, let's say, यहाँ पर decreasing temperature from 30 to 20 degree, from 20 to let's say 10 degree, I am keep on decreasing the temperature. Here the capacity is 20. Here let's say the capacity is 15. Here let's say the capacity is 10. I again decreased it to 5 degree. Here the capacity is let's say 8. So as I am decreasing the temperature, air is getting contracted. As it is getting contracted, now it has less space available for the water to be holded there. So right now, how much water is there in this air parcel? It is 10 units only. I am not changing the absolute amount of water that is there in this air parcel. It is holding 10 units. It is also holding 10 units. It is also holding 10 units. I am not changing the amount. But what happens to relative humidity here? Here capacity was 20, relative humidity is 50%. Here capacity is 15 only. So out of 15 capacity, 10 units are filled. That means 66.67% relative humidity is there. Calculate कर लेना, into 100 कर देना यहाँ पे. Here again amount of water vapor is 10 only. Capacity is also 10. That means, can I say it is using 100% of its capacity? So as you keep on decreasing the temperature, capacity keeps on decreasing, relative humidity for the same amount of water keeps on increasing. Now what will happen? Can anyone tell me if the capacity is 8? आप ऐसे समझो ये बाल्टी है, जैसे टेम्परेचर घट रहा है, as the temperature is decreasing, size of the bucket keeps on decreasing. Size of the bucket keeps on decreasing, but the amount of water in it is same. So as I am decreasing the size of the bucket, can I say water level in that will rise? That water level here is relative humidity. At this point, when the capacity is 10 and the water it is holding is 10, can I say it will be 100% filled? Now tell me what will happen if I decrease the capacity further to 8? Excessive water will precipitate. Again here the humidity will be 100% only, but the water that it will hold will be only 8, because it cannot hold more moisture. Its capacity is 8 only. So what will happen to remaining? Total it was 10, it can hold only 8, so remaining 2 units of moisture will precipitate. This is actually what happens in your atmosphere. This is how, as the air parcel goes up, let's say the air parcel was at 30 degree right now, as it goes up its capacity keeps on decreasing. As its capacity keeps on decreasing, whatever is the extra moisture that is there, agar capacity और कम हो गई, that moisture will be precipitated out. This is what actually happens. ठीक है, done. हाँ. Why? क्यों? This is the amount of water vapor that is there. आप बाल्टी समझो, you have the bucket. I'm not changing the amount of water that is there. I'm just changing the size of the bucket. I'm keep on decreasing the size of bucket because of the capacity that is decreasing. This is not decreasing. This capacity keeps on decreasing. Absolute कम नहीं हो रहा है ना. Absolute कहाँ कम हो रहा है? Absolute कैसे कम होगा? I'm not taking out water from it, so absolute remains same. Absolute humidity is whatever is the amount of water that is present in air parcel, that is absolute humidity. बस उतना ही है कि एक पर्टिकुलर यूनिट ऑफ एयर पार्सल में व्हाट इज द अमाउंट ऑफ वाटर वेपर दैट इज प्रेजेंट. हाँ, उतना स्पेसिफिक में मत जाओ. You will normally have two terms that are there, absolute and relative humidity. बस इन्हीं पे खेलेंगे वो. So water holding capacity depends entirely on its temperature. entirely on the temperature. If the temperature is increasing, water holding capacity also increases. इससे we'll relate a lot of things that is there. Now what is saturation? Saturation point is point at which the relative humidity became 100%. So this is when air parcel is completely saturated. You can saturate an air parcel by adding more water in it or decreasing the capacity of the existing. For example, it had this much amount of water. I kept on decreasing the temperature. As I kept on decreasing the temperature, at this point at 10 degree, its relative humidity came to be 100. This 10 degree becomes the saturation point of this particular air parcel. Now saturation point is also called as dew point. And if the same dew point lies below 0 degree, your water will not be in the liquid state. We'll call it as frost point. वो जम जाएगा. So there is just a minute difference. Saturation is when your relative humidity becomes 100%. The point at which saturation occurs is your dew point, and if that dew point is below 0 degree, that is your frost point. थोड़ा थोड़ा सा difference है. They might directly give the definitions of it, and they might interchange. You might not realize this, but उनको लगता है क्लाइमेटोलॉजी में विंड बेल्ट्स पढ़ लो सबसे ज़्यादा इंपॉर्टेंट है, साइक्लोन्स पढ़ लो सबसे ज़्यादा इंपॉर्टेंट है. जस्ट सी द नंबर ऑफ क्वेश्चंस दैट दे आर आस्किंग. साइक्लोन से व्हेन वाज द लास्ट टाइम दे आस्क्ड अ क्वेश्चन इन प्रीलिम्स? कोई याद भी नहीं होगा कब पूछा था साइक्लोन से क्वेश्चन प्रीलिम्स में. सो ट्राई टू फोकस ऑन दोज टॉपिक्स जहाँ से यूपीएससी इज आस्किंग. इट इज दिस कोर एरियाज जहाँ पे यूपीएससी आपको घुमा के क्वेश्चन पूछ लेगा. दीज आर देयर इन एनसीईआरटीज आल्सो, and we normally overlook such topics. We normally focus more on temperate पढ़ लो, tropical cyclone पढ़ लो, ये पढ़ लो, वो पढ़ लो. उनसे नहीं आ रहा है सवाल वैसे जितना आप उसमें जा रहे हो. दे फोकस ऑन वेरी बेसिक्स ऑफ इट. अभी हमने ट्रोपोस्फियर पे क्वेश्चन देखा, पिछले 1-2 साल का ही था. आइसोथर्म्स पे देखा. दीज आर वेरी बेसिक थिंग्स. तो ट्राई टू फोकस ऑन छोटी छोटी एस्पेक्ट्स ऑफ द थिंग्स एज वेल. डोंट बी लाइक कि जो बड़ा नाम सुन लिया, जो कॉम्प्लेक्स चीज है उसको पढ़ ले. कॉम्प्लेक्स चीज भी पढ़ेंगे, but these things are even more important. Now your type of rainfall depends on how the air is being uplifted. Ultimate thing is we want to cool down the water parcel that we have. We want to cool down the water parcel in order to get to the saturation point. Then only we'll experience precipitation. So this cooling down happens when the water parcel is uplifted. Depending on how it is uplifted, we can experience different kinds of rain. For example, convectional rainfall, when you have high heating of this surface, high heating will create low pressure conditions. This particular heat that is here will make this air parcel warmer. Warmer air parcel will be less dense. It will start rising. So we will have convectional rainfall. Normally it will be experienced in ट्रॉपिकल रीजन्स. नॉर्मली इक्वेटर के पास हर दिन यही हो रहा है. ओरोग्राफिक रेनफॉल, an air parcel was coming, somehow there was a barrier, normally mountains. It is forcing this wind to rise up. As it is rising up, its temperature is decreasing, leading to the formation of clouds and consequent rainfall. Orographic rain. Last comes cyclonic rainfall, also known as frontal rainfall. What happens in frontal rainfall? You have two different kinds of fronts. This is, let's say, warm, this is cold front, this is warm front. As they encounter each other, warm front being lighter, it will move up. So it is forced to move up because it is denser. It has to move up. अगर ये दोनों इधर आ रहे हैं, if it is denser, it is lighter, it is forced to move up. As it is moving up, it will experience condensation and precipitation. So frontal या cyclonic rainfall all depends on how the air is being uplifted. Talking about types of precipitation, इसमें भी बहुत ज़्यादा घुसना मत, बस समझ लो चीज़ों को कि क्या होता है. Normally, let's say clouds are formed. When it is falling, यहाँ पर temperature is very less. When it is falling in the atmosphere, it will experience relatively warmer temperatures. Up depending on what is the length of this warmer air parcel that it is interacting with, we can have different kinds of rain, yeah, different kinds of precipitation that we'll get. Let's say this warm air parcel was completely there. This ice droplets will become water again and we'll experience rain. This is what happens here. ऊपर चाहे कितना भी ठंडा हो, नीचे आते आते वो इतना गर्म हो जाते हैं that we experience rain here. Next, freezing rain. In this, it experienced यहाँ पर slight air parcel, a smaller length of air parcel, so it became liquid, but on touching the ground, it again freezed. Freezing rain. So it fell down as the liquid, but on touching the ground, it became ice again. It became solid again. So freezing rain, rain that froze, rain जो जम गई, freezing rain. It might happen that this length of air parcel is relatively lesser. If this length of air parcel is lesser, the ice that was coming from here will be melted, but again because of colder conditions here, it will be again recrystallized. So here you will have sleet formation. This is what we call as sleet, and snow is complete snow is falling. Difference थोड़ा सा समझ में आया? You have complete rain. Freezing rain is it fell down as water, but on contact with the surface it froze. यहाँ पर it became water, but it refreezed in the atmosphere itself. It fell down as sleet, and here it fell completely like snow. Freezing rain is यहाँ पर it froze on touching this. Hail would be almost same as snow, but the particle size is bigger. Freezing rain is it is liquid still. When it touched the ground, it froze. I think something like this, if you can see here, it is rain, it is freezing rain, it is still liquid. यहाँ पर it became liquid, then again solidified, it was complete solid here. Hail is very bigger particles. जो आप ओले बोलते हो ना, ओले गिर रहे हैं, वैसे समझ लो. Done? Now forms of condensation. If the condensation is occurring near the ground, there can be some different forms that we will study. One is dew. Dew क्या होता है? So whatever, हाँ, ओस, समझ गए? बस, that is what is dew. Frost, if that dew point is less than 0 degree. So dew is whatever water was there in the air. Air is consisting of some water parcel है. Air is consisting of some water in it. As the temperature cooled down during the night, the capacity of air decreased. As the capacity of air decreased, if there are some extra water that is there, it will condense then and there on the surface. This is what happens in dew formation. But if the temperature is below 0 degree, then instead of dew, we'll see frost formation as well. This is dew, this is frost. You might have seen in the winters as well. Sometimes frost is also seen. Huh? पाला पड़ गया. Harmful for crops. Fog. Delhi people को पता होगा what is fog. Huh? Low level clouds, you can say. Fog is like a low level cloud. But fog, mist and haze almost same hai, but it all depends on how much water content is there and how much dense it is. Fog is relatively denser to these two. A little lighter version is mist, and haze is mixing of even the pollutants also along with all this. So smoke and pollutants is also mixed along with the water droplets. This is where you will have haze formed. Fog is lower level clouds that are being formed. Abhi we have seen inversions. Radiation inversion mein you can have radiation fog. Advection, remember oceans ke wahan par you will see advection, temperature inversion. There we can have advection fog. During fronts, frontal fog can be formed. Fronts may, when the air warm parcel is uplifted, again it will form clouds. That low level cloud is nothing but fog can be formed. Air drainage is, it happens in valley, it can lead to valley fog being formed. Done. Now cloud formation. Sorry, last slide देख लो. करें. Now cloud formation requires three basic things. One, the air should be uplifted, but just upliftment is not sufficient. It should be cooled below the dew point so that water droplets can be formed. How will they form? They'll form around a hygroscopic nuclei. So you need all the three conditions, that it should be uplifted, it should be cooled, and it should form near a hygroscopic nuclei that is there. All the three conditions should be there. There can be different types of clouds. बहुत डिटेल में नहीं जाएंगे, बट यू नीड टू अंडरस्टैंड फ्यू बेसिक टर्मिनोलॉजीज दैट आर बीइंग यूज्ड. Nomenclature. First, understand relative heights. This is around 2000 meters, this is around 6000 meters, this is, let's say, 12,000 meters. 2 किलोमीटर 6 किलोमीटर 2 into 6 12 तो 12 किलोमीटर. Around this is the height of this. There are various terms that are used. One is stratus. Stratus is state, समझ लो, it is almost layered clouds that are being formed. Cumulus, they are cotton like, cotton balls type, ऐसे cotton like clouds are being formed. Stratus is straight layers relatively. Cirro is, सर कहाँ होता है? ऊपर, सबसे ऊपर है. Cirrus, at the top you will see light feathery clouds, very high clouds are there, cirrus clouds. Alto is the word that we use for middle clouds, alto. And nimbus for rain bearing clouds. For example, you have cumulonimbus, nimbostratus. So this nimbus is used for rain bearing clouds. Not all clouds will have rain. Okay, will rain normally. Depending on, see, I told you how the air is uplifted, you will have different kinds of rainfall. But at the same time, how the air is uplifted will lead to different types of cloud formation as well. If, let's say, you have a warm front coming from here and a cold front coming from here, warm front will be uplifted, warm front is uplifted. अब ये धीरे धीरे uplift हो रहा है. If it is getting uplifted, some clouds might be formed here, some might be formed here, some might be formed here, some clouds here. So we will see formation of relatively stratus clouds that are being formed. So depending on how it is uplifted, we will see different types of clouds being formed. Is somehow I suddenly uplift the air, as it happens in cyclones, we'll see formation of great lengths of the cloud, cumulonimbus clouds. एकदम से बहुत ऊपर तक का cloud बन जाएगा. Cumulonimbus clouds, rain bearing होता है, heavy rainfall along with thunderstorms and all. So depending on how we are uplifting the air, we will have different types of clouds. एक क्वेश्चन आया था क्लाउड सीडिंग पे लास्ट ईयर, बिकॉज इट वाज इन न्यूज़, बट we need not go into much detail. अब पूछ लिया है तो probably they'll not ask again the same type of question from here. But what is cloud seeding? See, we are injecting some kind of nuclei. Basically, we need these conditions. We need to uplift the air in order to form clouds. We need to cool it below the dew point, and we need to provide some kind of hygroscopic nuclei. In cloud seeding, we try to tackle these two. How? Either silver iodide and potassium iodide are sprinkled. This is what the question was. They provides nuclei. So hygroscopic nuclei is being provided. There can be other mechanisms of cloud seeding also, where we are spraying dry ice. Dry ice cools the surroundings जहाँ जहाँ भी spread करा है. So it will lead to decrease in the temperature below dew point. जो second condition was there for cloud formation. So dry ice can be used. Sodium chloride is used because it is hygroscopic. Namak, sodium chloride is your salt only. So it is sprayed because it is hygroscopic. आप नमक छोड़ दोगे थोड़ी देर बाहर तो it might attract some of the water droplets. So it attracts water droplets. As it attracts water droplets, the droplets keep on getting bigger and bigger. So increases the size of water droplets. Last is calcium chloride. It enhances coalescence. Coalescence is again the combination, the joining of water droplets that is there. So all of these things can be used. Different seeding agents are there. आपसे केवल पहला वाला पूछा था, but there are others also. थोड़ा सा ध्यान रख लेना. It is not just silver and potassium iodide. Done. Thunderstorm. What is a thunderstorm? Now see thunderstorms. बिजली गिरना, हाँ, बिजली चमकना, but that is lightning. Then what is thunder? Thunder is the sound that is produced, and that sound is because of rushing of air. What happens is, as the clouds are interacting with each other, because of continuous friction, some kind of poles are being developed. Some positive and negative ions are being developed within the clouds. As this positive and negative ions are developed, we might see interaction between these ions and a sudden release of this energy. So let's say this positive and negative might interact, and एक इलेक्ट्रिसिटी फ्लो कर जाएगी यहाँ से यहाँ तक, जो आपको लाइटनिंग के फॉर्म में दिखती है. यू एक्सपीरियंस दिस एज लाइटनिंग. Now as it flows, it is at a very high temperature. It is at such a high temperature that it creates almost vacuum. It creates vacuum on this path at which it is going. As it creates vacuum, अब vacuum हो गया, वो तो चली गई. It was for a second only. Surrounding particles rush in to fill that vacuum. So that rushing in sound of the surrounding particles is what we hear as thunder. So thunderstorm is not lightning. Thunder word is for this. It has lightning and rain and everything associated with it, but thunder word is for this. It is not for lightning. ठीक है, बस ऐसे ही नॉर्मल ध्यान में रखने के लिए. चलो, what we have done, then we'll move on to the next section. कॉपी वो खोल के क्यों देख रहे हो? बंद करो, रिकॉल करो क्या पढ़ा था, वो तो बाद में पढ़ा. सबसे पहले we started with, after atmosphere we have seen temperature inversion. क्या पढ़ा था? Insolation. There are certain factors on which insolation depend. Name some factors. एक एक. पहला एंगल ऑफ सनरेज, दूसरा ड्यूरेशन ऑफ डे एंड नाइट, तीसरा डिस्टेंस फ्रॉम द सन, एपेलियन पेरिहेलियन, चौथा सन पॉट्स, पांचवा सॉरी atmospheric effects depending on the albedo of the atmosphere. Next, we moved on to horizontal and vertical heat budgets. The thing that was you are supposed to remember is how much percentage is absorbed by Earth out of 100 percentage coming. It was 47%. Next, horizontal heat budget. You have different layers. If you want to redistribute heat between that layers, this is what is giving rise to your planetary and oceanic currents system. Next, we moved on to temperature. Now, there are certain factors on which temperature depends. Start. Factors on which temperature depends. Latitude, altitude, continentality, या distance from sea, winds, ocean currents, land and sea contrast, vegetation, albedo वगैरह. याद आ रहा है, रिकॉल कर पा रहे हो? ठीक है. अब horizontal distribution के बाद we have also seen isotherms that are there. Isotherms कैसे dip करेंगे? That we'll see कि which month it is, where is the position of sun, and if sun is in that position, will land will be cooler or will water will be cooler. Depending on that, one basic funda is land will be heated faster, land will be cooled faster. Based on that, we'll have to see relative temperatures on the same latitude in water also and on land also. Accordingly, we can make isotherms. याद आ रहा है ये सब किया था? After that, temperature inversion. So we have seen 4 kinds of temperature inversion. Basic funda is air aloft is warmer compared to the air below it. What are 4 kinds? Radiative. In radiative, what is the basic condition that we need? Clear sky, long winter nights, calm and stable conditions. Next type of inversion, air drainage that we experience in mountains and valleys. Next type, advection inversion. Advection inversion is oceans के वहां पर we have seen. Next, frontal near the fronts. Next we moved on to which topic? Water and moisture and precipitation. So water moisture में one basic thing is relative humidity. It is a function of, yeah, water holding capacity is a function of temperature. As you increase the temperature, water holding capacity increases. Decrease करोगे तो it will decrease. अभी इससे I'll relate so many things, desert and all, सब कुछ अभी relative humidity से we will relate. Next, we have seen precipitation. There are 3 different ways in which air can be uplifted. Depending on that, we'll receive different kinds of rainfall. What are different kinds of precipitation that we receive? ठीक है. Then we'll have rain or freezing rain. Freezing rain is it fell down as water, but then it froze on the bottom. Next, sleet, it solidified, re-solidified in the air again. Next, snow. Hail भी होता है. Hail is relatively bigger size, बहुत तेजी से गिरेगा. Hailstorm. Next, we have seen some forms of condensation that was happening near the ground. क्या क्या है? Dew, water droplets on leaves that you see normally. What is frost? When dew point is less than 0 degree, that becomes your frost. Then what is fog? Low level clouds. Simple meaning में low level clouds you can say. They are not raining, but they are still low level clouds. Next, mist. Mist is almost same as fog. It is a type of fog only, but it is relatively lighter. And then haze, everything mixed with smoke and pollutants. Done. Then cloud formation. There are 3 basic things. Air should be uplifted, it should be cooled below the dew point, and it should be you need a hygroscopic nuclei surrounding which you will have water droplets. For this we have before that we have different types of clouds being formed. क्या क्या nomenclature था? Stratus is relatively straighter clouds. Cumulus is cotton ball type. Then cirrus is higher layer clouds, feathery in nature. Next, alto is for middle latitudes, nimbus is for rain bearing clouds. याद आ रही है चीजें? यस. डिपेंडिंग ऑन हाउ द एयर इज अपलिफ्टेड यू विल हैव डिफरेंट टाइप्स ऑफ क्लाउड फॉर्म. एक एक का कैरेक्टरिस्टिक नहीं पढ़ना है कि ऑल्टो क्यूमुलस में क्या है, निम्बो स्ट्रेटस में क्या है, इतना डीप में नहीं पूछा यूपीएससी ने कभी भी. जस्ट बेसिक नोमेनक्लेचर इज इंपॉर्टेंट. नेक्स्ट, we have three conditions of clouds. In order to satisfy or in order to have cloud formation, we also go for cloud seeding. For that we use certain type of seeding agents. One basic being sodium and potassium iodide. Next, dry ice. It is used for cooling down, bringing the temperature below dew point. Next, NaCl, used for, it is hygroscopic, it attracts water molecules. Next is calcium chloride. Calcium chloride, what it does? कोलेसेंस. कोलेसेंस मीन्स वाटर ड्रॉपलेट बन गया है लेकिन जोड़ नहीं पा रहा है, तो जोड़ेगा कैल्शियम क्लोराइड. आर यू एबल टू रिकॉल एटलीस्ट 70% ऑफ इट? पक्का? जस्ट गिविंग यू 30 सेकेंड्स. जो याद नहीं आया था बस एक दो पॉइंट लिख लो कि ये भूल गया था मैं, बाद में रिवाइज करने के काम आएगा. लास्ट पेज पे लिख लो, देख लो, पलटा लो क्या भूल गए थे. आपका रिवीजन यही हो जाएगा, घर जाके नहीं करना पड़ेगा. डन. ट्राई सॉल्विंग दिस क्वेश्चन, जल्दी जल्दी करो. आंसर डी. Why are dewdrops not formed? Why will they not form? If the temperature is higher, they will not form. They will form only when temperature is relatively less. Which of these conditions will give you higher temperature? B. Cloud absorb the radiation released from the Earth's surface. Clouds reflect back the Earth's radiation. It will reflect back the Earth's radiation. We want radiation back on Earth. We want it here. It should be heated, not on the clouds. Clouds ne absorb kara, that is different aspect. We want it here back. So they reflect back the Earth's radiation. But ground level पे हम dew point की बात कर रहे हैं ना, तो ground level पे देखेंगे. Try this one. Answer. Clouds having nimbo attached produce precipitation. Stratus, nimbostratus, cumulus are types of high clouds. No, it has to be cirrus. According to the altitude, clouds are classified as high, middle, low. Two major types are stratus and cumulus. ये वही है. So you might have different words being used for it. थोड़ा ध्यान रखना. So you will have 1, 2, 4. B. चलो, we'll move to air and its movement. अब your pressure and everything will come in. Then we'll move on to pressure belts. फिर monsoon and all. Now see, air can move either horizontally or vertically. Horizontal movement of air is what we call as winds, and it is caused by pressure gradients. Pressure gradient is, for example, let's say you have higher pressure here. यहाँ पे सब खचाखच भरा है and suddenly दो तीन extra seats लगा दी यहाँ पर. Few particles will rush down from there to this. From higher pressure to lower pressure, air will start blowing. Particles will start blowing. So from higher to lower pressure, you will see movement of winds, या movement of air from higher to lower pressure. This I am talking in horizontal terms right now. From higher to lower pressure. This is called as advection of air. In vertical movements, what we say is convection, या convectional currents go. Now this convection currents move up and down because of density differences. So you will have some kind of density difference being involved there, that is causing movement of air up or movement of air down. So if you have a lighter air parcel, it will go, lighter air parcel will be ऊपर जाएगा, हल्का है less dense, it will go up, denser air parcel will sink down. Normally if I heat the air parcel, it will become less dense, it will become lighter. So as the temperature of the air parcel increases, it moves up. As the temperature decreases, it moves down. So this is what we call as convection. Two types of movement, advection and convection, both are there. Up here we'll study winds, and winds will be classified as, you will have surface winds and high level winds. Surface winds may we'll study planetary wind system, we'll study local या regional wind system, that is secondary, especially monsoons and cyclones we'll study, and then local wind system, cold, warm, mountain breeze, valley breeze, we'll study all of this here. High altitude winds में we'll study, most importantly it will be the jet streams that we'll study there. Done. Before starting, let's look at pressure. What is pressure? पहले भी हमने बात करी थी pressure of any place. Let's say if I am calculating pressure here is just the weight of air parcel that is lying above this. So what is the weight of this air parcel that is felt here? This is what we call as pressure here in very layman terms. Ab if I go higher up, if I go here, the pressure will decrease because now the weight that is lying above will decreasing. So pressure mein you will not see ki any variation is there as you go above. As you go above, the pressure will always decrease. Pressure keeps on decreasing. Whenever we say anything at a lower pressure or anything at a higher pressure, these are never absolute. These are always relative terms. This is low compared to this. This is high compared to this region. Compared to any other region, both of them can be high, both of them can be low, depending on what is the pressure of the third region. So these low and high pressures that we will be using every now and then now, these are relative terms that are there, low and high pressure. A difference of air pressure, it will cause movement from high to low pressure. Like isotherms, you have isobars as well. Now isobars are the areas of same pressure, so it joins areas of same pressure. Let's say this is a 1000 millibar pressure line, you might have, let's say 990 millibar pressure line, so joining all the points of same pressure. Ab can you tell me air will flow from here to here or here to here? From 1000 to 920, from higher pressure to lower pressure, air will flow like this from higher pressure region to lower pressure region. So air is going always towards the lower pressure area. Isileye when we'll discuss cyclones, cyclone is a low pressure zone, air will be attracted towards the cyclonic areas. Is this clear? Ab depending on how closely isobars are packed, for example, this is 1000, this is 900, in between you have all other isobars. यहाँ पे 975, 950, 925, all the air parcels, all the isobars are there. In the second case, this is 1000 and this is 900, and all the isobars are relatively closely packed. One case is isobars are relatively far, isobars are relatively closely packed. Ab, what does this mean is, if we are going from this distance to this distance, pressure is dropping by 100 units. But here in this case, in this smaller distance only, pressure is dropping by 100 units. Up, tell me, if I'm looking at wind speeds, where will wind speeds be greater? First or second? Second. So as you have closely packed isobars, you will have higher wind speeds. If the isobars are relatively farther away, you will have lesser wind speeds. So depending on कितना close है, उतनी ज़्यादा wind speed होगी. You can understand it like this. It is this distance, almost same मान लेना. यहाँ पर you are rolling a ball down from here. Example के लिए बता रहा हूँ, this is this distance, relatively shorter. This height is same. From 1000 to 900, you are bringing this ball down. If you check at any instant, here also you are bringing the ball down from 1000 meters to 900 meters, let's say. I am taking the exact values. You are decreasing the height here. I am relating pressure with height here. You are decreasing the pressure here. Here ball will pick up speed because of decrease in the height and the effect of gravity. It will roll down at certain speed. It will also roll down at certain speed. Let's say if I am checking at this point, which will have a greater speed? Second one, क्योंकि जल्दी drop हो रहा है. The height is decreasing suddenly. If the height is sudden, if the decrease is sudden, you will have greater speeds. Same happens in the air. If the decrease in the pressure is sudden, you will have greater wind speeds. Is this clear? You will have more wind speeds when isobars are closely packed. So in cyclones, you will see terms like closely packed isobars. जितना ज़्यादा close होगा, उतनी ज़्यादा wind speeds होगी when isobars are closely packed. Is this clear? Done. Now, what happens when you have some kind of pressure system in place? Let's say this particular pressure system is having low pressure at the center. अब we are talking about vertical movements यहाँ पर. If here it is somehow heated relatively more, if it is heated relatively more, the air here will be warm air will be relatively less dense. If it is less dense, it will keep on rising. Also, if the air is rising, we'll have a low pressure which will attract winds, because low pressure area will attract winds from relatively nearby high pressure areas. So in low pressure regions, we'll see that wind is getting attracted from all sides and then it is getting uplifted. When the air is uplifted, we will see clouds formation. हवा ऊपर जा रही है, we'll see cloud formation here. So low pressure conditions are related with rain also. They are related with cyclonic conditions also. Cyclone is a low pressure area and we see updraft of air. So if the air is uplifted, rain can be there. We also call it as instability in the atmosphere. But on the other hand, if it is a high pressure condition that is prevailing, it will be there when we have downdraft of air that is there. If we have a downdraft of air, sky will be relatively clearer, it will be relatively drier and stable atmosphere will prevail. एक basic चीज ध्यान रखना, low pressure से it will uplift, at a high pressure it will come down. If it is uplifting, it will create clouds and successive rains. If it is coming down, it will create clearer conditions. अब there are various pressure belts on the earth. कितने pressure belts हैं? 3, 4, 7. There are 7 pressure belts. ऊपर और नीचे दोनों के काउंट करना है. Total there will be 7 pressure belts. Now these pressure belts are formed because of two different factors, one being thermal factor, other being dynamic factor. Thermal factor is we have high insolation near the equator. If in this equatorial zone we have higher insolation, that means temperature of air near this will be high. High temperature means density is relatively less, it will start rising. As it rises, we will experience low pressure condition here. Same way, insolation here in this place is relatively less insolation, we will have relatively higher pressure here, opposite, just opposite of this. So we have these two pressure belts, or I should say these three pressure belts created, two polar and one equatorial pressure belt. This is low pressure and these two are high pressure belts. These are created because of thermal factors that are there. They are thermally induced pressure belts. So we'll see thermally induced pressure belts that are there. Originally this was the first model that was there ki one cell model tha, because of thermal induction of this pressure belts, low pressure here, high pressure in these two cells. इसमें वही सब लिखा है जो हम पढ़ रहे हैं, ठीक है. Next comes your dynamic factor. Now dynamic factor is because of Earth's rotation. So as Earth is rotating here, first thing that any particle will experience is the Coriolis force. So it will experience a Coriolis force and a bending moment is there. अब इसको कैसे समझेंगे? In the starting I made you calculate the speed of this particular particle that was on equator and that is moving around. If I take a similar particle here that is also moving, pole से थोड़ा सा पास में, somewhere here, it will also move like this. Can you tell me which particle will move a greater distance? Pole, equator. But these two particles are moving the same, moving these distances in same time. Can I say this particle and this particle, they are moving this distance, their respective distances in 24 hours only. ऐसा थोड़ी है कि ये एक दिन में यहाँ पर आया और ये तब तक 4 बार घूम गया. It will not be like this. They both will move one complete circle only. So for example, let's say this is 100 units of movement and this is only 20 units of movement that it is doing. So speed of this particular particle will be relatively more compared to this. कितना समझ में आया? This particular particle will be moving at a higher speed. Now what is happening is, let's say somehow I am throwing this particle to some other latitude. From here to here I am throwing. Can I say again this particle and this particle will be having a higher speed compared to this particular particle? So at a particular instant of time, after let's say 10 hours, if after 10 hours I am seeing this particle has moved this much, so ye particle, one thing, it will have a velocity here, it will also have a velocity here with which it was initially rotating. अब 10 घंटे में ये पार्टिकल कितना ट्रेवल करेगा? हाउ मच डिस्टेंस दिस पर्टिकुलर पार्टिकल विल ट्रेवल? विल इट बी लेस देन दिस और मोर देन दिस? Can I say more than this? Because it had an initial speed relatively greater than compared to this. तो अगर इस पार्टिकल ने, ऊपर वाले ने इतना डिस्टेंस ट्रेवल कराया तो नीचे वाला इतना कर लेगा. So if this particle came here, the particular particle that I am throwing will come to this distance. That means particle was supposed to reach a point, but that particle is not reaching at this point. It reached this particular point. It appears us to be deflected, and you will always see that this deflection is towards right in the northern hemisphere. And same way, if I'm going towards south, yeah, if I'm going in southern hemisphere, again it will appear deflected. This deflection will be towards left in the southern hemisphere. This deflection, यहाँ पे बताता हूँ. I'm considering two particles. This is on Tropic of Cancer, this is on equator. Tell me which will have a greater speed. Equator one. This will have relatively lesser speed. I am throwing this particle from this position. Now this particular particle will have two velocities. One is it is supposed to move in this direction also, and because of its initial speed in this direction, it will also keep moving in this direction. Let's say this particle is supposed to reach this particular latitude in 10 hours. Example के लिए 10 hours. Within this 10 hours, this will also move in this direction because of this speed. This will also move in this direction because of this speed. So after 10 hours, this particle was supposed to reach here, and this particle having the greater speed, reaches slightly more. So instead of reaching to the particle at which it is thrown, it appears deflected from that particle. This is what is, you have Coriolis deflection that is there. Same way in southern you will have opposite deflection. अब थोड़ा सा ध्यान से सुनना. How this Coriolis is causing your pressure belts, we'll understand that. यहीं पे करते हैं चलो. अभी we have seen on the equator your winds will have convection currents here. This is equator, this is poles. After a point it keeps on rising from low pressure. Here you will have high pressure and it deflects away. Now understand what happens to this deflecting wind. This deflecting wind, it is in the upper atmospheres. पहली चीज, it is in the upper atmospheres. In the upper atmospheres, friction will be less. I am drawing this particular wind here. This is coming from equator and it is going towards tropics. Understand this. यहीं से पूरा jet stream भी आपका clear हो जाएगा. It is going above the equator. Now I am drawing the high level या upper circulation winds here. From equator it is moving towards, I would say, poles. For now, अभी tropics की बात नहीं कर रहे. It will go towards poles. So it will move this side. It is moving this side. But since we are on Earth, this particular wind parcel will experience Coriolis effect. Coriolis effect में this particular parcel will be deflected towards right. It is deflected towards right. Now this deflection, this is just the direction. What happens is in Coriolis, formula पे जाने की जरूरत नहीं है. I just wrote it to notify that magnitude of Coriolis force depends on the velocity of the particle that is in consideration. So if a particular particle has a higher velocity, it will experience higher Coriolis impact. In the upper atmosphere, velocities of wind that is blowing here will be low or high. This velocity will be high, I would say very high compared to the surface winds. It is that higher. ये upper atmosphere की बात हो रही है. If it is very high, can I say Coriolis impact is very high? Now what happens is, as it moves, it experiences a very high Coriolis impact. This Coriolis turns this almost parallel to tropics. The wind is almost deflected by 90 degree. So it is not crossing over there. It is completely deflected. अब just see, it is in higher reaches. ऊपर है, बहुत ठंडा भी होगा. As the temperature is decreased, density will be increased. So after a point, what happens is it travels here, but it starts sinking down because temperature बहुत कम है. We are in the higher reaches. So it is traveling like this, but after a point and somewhere near to the tropics, it again starts sinking down. So this sinking is what leads to a relative high pressure zone here, because wind is sinking. This sinking of wind is caused by your Coriolis impact, या Coriolis force. That Coriolis is generated because of rotation of Earth. That is why we call this pressure belt that is created. Along with this pressure belt will also be created with almost similar impact. So these two belts are created dynamically. अब तक आप लोग रट रहे होगे, बट जस्ट अंडरस्टैंड द कंसेप्ट. These two pressure belts are created dynamically because of rotation of Earth. Rotation of Earth say the air parcel that was going away from here was deflected almost by 90 degrees because of Coriolis. It was deflected to this greater extent because of high wind velocities in the upper atmosphere. After a point, as it becomes denser, because temperature is very low, it sinks down. As it sinks down, it creates high pressure conditions in this region. This is what you have higher pressure belt in the subtropical areas. Is this clear? अब यही जो जोन बनेगा ना, यही विंड्स जो सारी चल रही है, ये आपका जेट स्ट्रीम बना देगी. विल कम टू दैट पार्ट लेटर इन जेट स्ट्रीम्स, बट दिस इज व्हाट विल क्रिएट जेट स्ट्रीम्स. एंड जेट स्ट्रीम्स के नीचे कैसा है? हाई प्रेशर. तो अब जेट स्ट्रीम्स को वी विल रिलेट विथ इंडियन मानसून लेटर ऑन, कि टिल द टाइम वी हैव जेट स्ट्रीम established over India, we will have हाई प्रेशर. मानसून में पढ़ेंगे अभी थोड़ी देर बाद. जब तक ये हाई प्रेशर रहेगा तब तक मानसून नहीं आ सकता. तो जब तक वी हैव जेट स्ट्रीम ओवर इंडिया, वी कैन नॉट हैव ऑनसेट ऑफ मानसून. सो वी विल लिंक ऑल ऑफ दिस विथ मानसून एज वेल. इन सबको देखेंगे मानसून में अभी. बट फॉर नाउ इज दिस क्लियर दैट हाउ इज दीज टू क्रिएटेड? These are dynamically created. These two are thermally created. Is this clear? Done. बाकी everything is same here. अब just see this. We have seen that in Coriolis, yeah, because of Coriolis, we experience apparent deflection of wind in right in the northern hemisphere, left in the southern hemisphere. But I have written that in the northern hemisphere, wind motion in cyclones is anti-clockwise because of Coriolis. Anti-clockwise तो ऐसे होगा, but right movement मतलब clockwise होना चाहिए. So how is this? हाँ, अब understand. There are two things that happen in cyclone. Cyclone, one is movement of complete cyclone. Second is movement of wind within the cyclones. How winds are blowing within the cyclone. Cyclone is a low pressure area. पढ़ेंगे अच्छे से cyclone को भी. Cyclone is a low pressure region. Low pressure region will attract winds from all sides. Let's say right now I'm talking about northern hemisphere. So in northern hemisphere, if any wind is blowing, it will be deflected towards its right side. So if a wind is coming, it will be deflected towards its right. So all these winds that are blowing, they will be deflected toward their respective right. ये होगा right. They will be deflected towards their right. If they are deflected towards the right, they will cause a motion. यहाँ पर देखो कैसा motion हो गया. Can I say they will cause a motion like this? They will cause a motion something like this. Are you able to imagine this? This is an anti-clockwise motion. यूपीएससी यहीं फंसाएगा आपको. यहाँ एंटी क्लॉकवाइज दे देगा एंड यू वुड बी लाइक कि एंटी क्लॉकवाइज तो लेफ्ट हो गया. हियर वी आर टॉकिंग अबाउट विंड्स दैट आर ब्लोइंग विद इन अ साइक्लोन. साइक्लोन एज अ होल विल मूव इन द राइट डायरेक्शन ओनली, बट विंड्स दैट आर ब्लोइंग विद इन द साइक्लोन विल बी एंटी क्लॉकवाइज. रिलेट करना यहाँ यूपीएससी खेलेगा पक्का से. if not this year, maybe next year, maybe some other year, but this is a potential question that is there, that how winds blow within a cyclone. It will be anti-clockwise in the northern hemisphere. ठीक है. Pressure belts and wind system. We'll finish this, then we'll have a break. ज़्यादा नहीं है. अब समझ लिया आपने concept. It will hardly take 5 to 7 minutes. So we have seen different kinds of wind belts, yeah, pressure belts being formed. Equatorial belt, this is thermally induced. Polar belts, thermally induced. These two belts are dynamically induced. You know their locations as well. लगभग ठीक है. अब this region will have low pressure zone, wind will, yeah, convection currents will rise here, it will go like this and will come like this. कुछ ऐसा motion will be there near this. Near the equator, what we experience is a zone of calmness that we call as doldrums. Doldrums में क्या होता है? Calm winds होती है, almost zero. So what happens is exactly equator पे winds नहीं है normally. This rise happens somewhere near 5 degree. Somewhere near to 5 degree this rise happens. तो ये जो zone बन जाता है from plus minus 5 degree, that means 5 degree north to 5 degree south, it is your doldrum zones. We experience relative absence of winds here, so ship used to get stuck यहाँ पर. But since rising wind is there, if rising wind is there, you can get rains and all. उतना ज़्यादा harmful, this is not that much harmful compared to your horse latitudes. What are horse latitudes? If I am moving to subtropical high pressure belt, here winds will be descending. Now descending winds will have clear sky, dry conditions, and this winds will diverge here. So again you will have a belt created where you will have very less winds, and in this particular belt again ships used to get stuck. But at the same time, this particular area, because of descending winds, there is a clear sky, high insolation, and there are no rains. So this region used to become very dangerous. So in order to move out of it, they used to throw down horses there just to make ships lighter, so that even with very small winds, ship can go, yeah, out of this particular zone. This is why this particular latitude is called as horse latitude. अब यहाँ पर because of descending winds, we'll see major deserts, major hot deserts of the world lying in this particular zone, in this subtropical high pressure belts. We'll see desert separately. हाँ जी, sorry, हाँ, this high pressure zone will be there. Wind movement. Now understand how wind will move. It is coming down from here. From here we will see two different planetary winds emerging. One is when this wind comes down, it diverges towards the equator, also towards the poles also. So winds that are coming towards the equator, from this point a wind is coming towards this point, towards the equator it is coming. It is in northern hemisphere, it will deflect towards its right. So right for this will be this side. So we'll see all the winds coming from Tropic of Cancer towards the equator will be deflected like this. So they appear to be coming from east. So they are called as easterly winds, or else trade winds, because major trade in the ancient times used to happen between these tropical regions only. So trade winds. Same way another set of wind will emerge that will deflect towards polar regions. So from this, if the wind is going towards polar regions, it will be deflected towards its right. It will go something like this. They appear to be coming from western side. They are called as westerlies. So westerlies, these are easterlies. Same way circumpolar belt. अब almost similar things will happen. यहाँ पर it is high pressure, wind will from high pressure belt, मैं अगले वाले का भी बता रहा हूँ. From high pressure belt, wind will come from here, and since they are moving from pole towards the equator, they will be deflected towards their right in the northern hemisphere. They will be easterly in nature, polar easterlies. They appear to be coming from the eastern side. Now this wind and this wind, they both will converge here, and because this is a low pressure condition, we will see rise of air column here. So these two winds will converge and we will see a rise of air column in this particular zone. Also this will be a zone where, see, these winds are coming from poles, they will be cold. This are coming from tropics, they will be hot. So cold and warm winds, they lead to the formation of fronts. So this zone will be associated with fronts. यहाँ पे होगा fronts, यहाँ पे था deserts, यहाँ पे है रेन फॉरेस्ट या ह्यूज रेनफॉल, और ये तो पोल्स है. ठीक है, polar is also done. This is the 3 cell model that we were studying. We will have equatorial low pressure belt that was being formed. It will give rise to the winds here. As winds rises, somewhere here they will start diverging somewhere in the upper latitudes. As it is cooled down, it will move towards the polar regions. As it moves towards the polar regions, because of Coriolis impact, this particular wind parcel will be deflected. It will be deflected by almost 90 degrees. It will start blowing parallel here. यहाँ पर इस जोन में it will start blowing, याद आ रहा है वो डायग्राम बनाया था. Because of very low temperature, it will become very dense, and after a point it starts sinking. As it sinks down, we will have a high pressure condition created. Similar kind of things will happen here. We will have a high pressure here. जैसे इक्वेटोरियल लो था, यहाँ पे हाई हो गया. Because of this, we will experience jet streams flowing यहाँ पर also and यहाँ पर also. We'll come to jet streams later on, but we will have jet streams flowing in these two regions. जो हमने देखा था ना, it deflected towards its right. It was nothing but the jet stream that started flowing in this region. We'll see that as well. Below the jet stream, you will have high pressure. These cells are named as polar, Ferrel and Hadley cells. Polar and Hadley cells, normally we say them as they are created thermally induced cells. For Ferrel cell, we say that Ferrel cell is dynamically induced. तो ये thermally induced, dynamically induced पूछा जा सकता है कि which of this is thermally and dynamically induced. These two belts are dynamically induced because of rotation of Earth. Had rotation not been there, you will not experience these two pressure belts. This and this is created thermally because of differential insolation that we are receiving. Why do all deserts lie in these regions? In and around 30 degree. वैसे आंसर लिख दिया है मैंने. But this is a zone of high pressure. You will have Tropic of Cancer passing from India. Now this tropic will have higher pressure. Same way you will have Tropic of Cancer passing, Tropic of Capricorn passing somewhere from here. This is a zone of descending winds. Descending winds will bring dryness. They will bring clearer conditions. They will not rain. Clearer conditions hai, that means high insolation. So no rain plus high insolation. अब आप समझो, evaporation rates will be very high because insolation is higher. So evaporation is very high and there is no precipitation. It will create aridity, yeah, arid conditions. So deserts are created in this location. Can you name this desert? Kalahari or Namib? This is Namib, this is Kalahari. This desert? Mojave and Sonoran Desert. This Sahara Desert. This Arabian Desert. You will have Nubian and all छोटे मोटे deserts हैं यहाँ पे. This Thar Desert. This desert Gobi. This Taklamakan. This Great Australian, Gibson Desert, Sandy Desert सब है यहाँ पे. So you will have all the deserts located here. Now these are not located on tropics. Why? They are cold deserts. They have different reason for their aridity. Their reason is continentality effect. Continentality means they are lying interiors. They are lying this interiors that water is not reaching there. If water is not reaching, there is no precipitation, very dry conditions. Desert mein normally rainfall is less than 25. This type of climate, we say that desert type of climate. So this is a desert because of continentality. Same way you will have a desert here, Patagonia Desert. This is because of rain shadow zone of Andes here. So rain is not falling here because of rain shadow zone. Ab, this is just one point that wind is descending. There are other aspects to it. Why desert is being formed here? एक बार देखते हैं. This is where you have equator. This is where you have tropic. Between equator to tropic, how is the wind flowing? Wind pattern is you will have trade winds flowing like this. It is an easterly wind. It is going away from the shore. If it is going away from the shore, it is not bringing any precipitation. Had it been coming to the shore, it could have brought some precipitation. So because of offshore trade winds also, you will have dryness in this particular region. Same way you will have cold ocean currents. Cold ocean currents क्या करेगा? Capture the cold ocean currents, capture the moisture. चलो, रेन नहीं हो पाएगी. So we will see relative desiccation effect of cold ocean currents in this. यहाँ पर it will have very dry air mass, or I should say air parcel. You have a cold ocean currents. Relatively cooler climate is there near to cold ocean currents. So air parcel that is lying above this will have very less moisture in it, because ठंडा है वहां पर अगर, तो evaporation will be very less. If evaporation is very less near to the colder ocean currents, can I say moisture in the air parcel will be very less. If you have very less moisture in the air parcel, when it comes to the shore, it will not be able to precipitate because it is not having high moisture content जितना precipitation के लिए चाहिए. So because of very less moisture content, it is not able to bring rain to the shore, but it causes desiccating effect. Understand? गर्मी नहीं लगेगी लेकिन ड्राइनेस बहुत ज्यादा होगी, because wind is already cold. It will not lead to very high temperatures here in this region. Here in this region बहुत ज्यादा high temperatures नहीं होंगे, but coolness बहुत ज्यादा होगी and dryness भी बहुत ज्यादा होगी, and because of dryness you will experience desert like conditions. Dryness because of लेस मॉइस्चर कंटेंट, इसीलिए डेसिकेटिंग. आप ठंड में मॉइस्चराइजर क्यों लगाते हो? ड्राइनेस होती है. कैसे होती है ड्राइनेस? द विंड दैट इज देयर, बिकॉज इन विंटर्स इवोपरेशन इज वेरी लेस. द विंड इज कंसिस्टिंग ऑफ वेरी लेस मॉइस्चर. एंड समझो बाहर से ठंडी हवा आपके रूम में आ गई. रूम में यू हैव रिलेटिवली हायर टेम्परेचर. बाहर थी ठंडी हवा में लेट से 5 यूनिट पानी था. It was able to hold, let's say 50, it was able to hold, let's say 10 units. Again going back to relative humidity, the water content in the colder air outside during winters was 5. It is able to hold 10 units. Relative humidity was 50%. Now you bought this air, आपने दरवाजा खोला बालकनी का, ठंडी हवा अंदर आ गई. Now the temperature in your room, आपने blower on कर दिया, heater on कर दिया, you have increased the temperature. If you increased the temperature, this holding capacity increased to, let's say, 20, but the air in it is still 5. What happened to relative humidity? It was 50%, now it became 25% only. और कम हो गई relative humidity, और ज़्यादा dry लगने लगेगा आपको. So to lock in the moisture that is there, अगर ये आपके रूम में इतना ड्राइनेस वाला विंड है, तो it will start sucking out moisture from your skin as well. That is why you start feeling dry. That desiccating effect happens here as well. So in order to lock in moisture, you apply moisturizers there at this point. इसीलिए बोला जाता है during winters, if you are using heater or blower or some other thing, you need to place a water bowl there so that water keeps on evaporating and this relative humidity is maintained. Now one last thing because of which this particular desert like condition is prevailing is dry continental air mass. अब understand what is air mass we'll see later on, but abhi ke liye for now it is a very huge body of air which is having some temperature and pressure, and that is almost consistent. And if it is continental air mass, it will have a higher temperature. If temperature is high, if temperature is high, tell me its water holding capacity will be high or low? It will be very high. So what happens is, even if you add some water to it, even if you add some moisture to it, it is able to hold that moisture. मतलब बाल्टी बहुत बड़ी है, अगर आपने उसमें 2-4 लीटर पानी डाल भी दिया तो इट इज एबल टू होल्ड दैट मॉइस्चर. इन ऑर्डर फॉर us to get rain in this, we need to saturate that first, but it is having a very high capacity. We are not able to saturate this dry continental air mass because it is having a very high capacity already. That is why it is not raining in this regions. Is this clear? So one of the reason of Thar desert is it is having this dry continental air mass nearby that is not letting moisture precipitations even in Thar desert. So prolong of Thar desert is one of the reason for that is we have a dry continental air mass surrounding this as well, जहाँ से continuous drier winds are coming. So even if somehow moisture, somehow monsoon winds add some moisture to the atmosphere also, we are not able to see precipitation here in this region because the capacity of drier winds is very high. They are coming from relatively higher temperature regions. Done. 4 basic things. High pressure belt normally इतना ही सोच के खत्म हो जाते हो आप, but you have offshore trade winds also. They are not bringing rain on the shore, they are offshore. Next, cold currents bringing desiccating effect and formation of dry continental air mass. All of this leading to deserts near this region. So we'll start with Walker circulation and local winds after the break. उसके बाद we'll move on to monsoons. Local winds and then monsoon cyclone. Climatology will be done. So probably by 5 p.m. या evening break we'll be done with climatology. Break till 45 minutes. हेलो हेलो, बुला लो अपने दोस्तों को जो गए हुए हैं. विल स्टार्ट इन 5 minutes. और अब स्टार्ट करता हूँ मैं. हेलो हेलो. हेलो हेलो. चलो, विल स्टार्ट नाउ. सेटल डाउन फास्ट. अच्छा, बिफोर रीस्टार्टिंग, टेल मी, एम आई गोइंग टू फास्ट? यस. अच्छा. एम आई गोइंग टू स्लो? नो. So I am not going too slow, but I am going slightly faster. So I'll just pace it down. अरे लिखने के लिए आप बोल दिया करो. I'll stop there. You can write from the board. If you want to write, just I'll just pause it there itself. I'll share the PPT. Don't worry about PPT. Whatever is on it, I'll share it. So we'll start now. Now see, we were looking at air circulation, wind circulation and all. Abhi tak right now what we have seen is circulation in north-south directions. But there can be some circulation, horizontal air circulation within the east-west directions as well. This what we'll call as Walker cell circulations or Walker circulations that we can experience. Normally we see this circulation in southern hemisphere. Later on we'll relate this to El Nino, La Nina and all of it. But just a brief of it, what happens in this circulation. Let's say, Abhi I'm not going into El Nino, La Nina, but because of certain conditions, what happen is, let's say trade wind is reinforced. Normally, your wind pattern blows like this. If we see this particular view, यहाँ से देखते हैं. चलो यहीं पे. This is Australia. This is South America या Peru coast. What we'll see is, along with the trade winds, we will have upper layer waters which is usually warmer. All of this upper layer waters coming along with the trade winds will exert a drag on the water. This drag exerted on the water will bring all of this water piling up near the Australian coast. इसको detail में we'll see in when we'll study El Nino and La Nina. Right now just see how the circulation goes. So somehow because of trade winds strengthening, we are getting a warmer pool of water created here. If we are getting a warmer pool of water created here, can I say I will also experience a low pressure condition? Because warmer water will have relatively warmer air here. Relatively warmer air will be lighter. Lighter air will rise. Rising air will give you clouds here and a low pressure condition here. Comparatively here, if I am completing this cell, I will get a higher pressure condition being created here, from which water is moving away. So here in the atmosphere we will have a circulation created that we name it as Walker circulation. यहाँ से lower pressure, wind is rising, from here wind is diverging. One limb will come towards Mascarene High, one limb will go towards again towards South America. From here, आवाज नहीं आ रही, आवाज सही से नहीं आ रही है, पीछे वाले थोड़ा सा आगे आगे आ जाओ. मतलब दैट इज वन वे कि एकदम पीछे वालों को अगर नहीं आ रही तो आगे आ सकते हो. बाकी आई विल ट्राई टू स्पीक थोड़ा सा रिलेटिवली लाउडर. हेलो. So in this way your Walker circulation is complete, but at the same time we have a Walker cell. Yeah, we have another cell created in the oceans as well. This we'll see in oceanography. Again same, आवाज नहीं आ रही है ठीक है. We'll also see in oceanography that because of this we have an upwelling and downwelling regions also created. But ये हम उनको respective areas में ही पढ़ेंगे. What is El Nino, what is La Nina, what is upwelling, what is downwelling. This we'll study in their respective areas only. यहाँ पर because of this various conditions are created. हम यहाँ El Nino, La Nina पढ़ेंगे, ये सब उसी के बारे में लिखा हुआ है. But I'll take it separately in their respective topics. So we were looking at various winds that we have, within which we have seen surface winds. Within surface winds we have seen primary winds, yeah, planetary winds that are there. So we have seen these three types of winds. Next we'll first see local winds that are there. So there are various local winds depending on the region. It can be either sea breeze, mountain breeze and all, and it can be cold and warm winds. So pehle we'll see some of the important winds like this, then we'll move to monsoons and cyclones, then we'll study jet streams. Ab local winds, they prevail only in local conditions. For example, let's say land and sea breeze are there, they will be there only on the coastal regions, very localized. Mountain and valley breeze is there, they will prevail only in mountainous and valley areas, again very localized winds. But these are permanent winds. Permanent winds, they will be there throughout the year irrespective of the season. They will be there throughout the year. So these are permanent local winds. At the same time there can be some temporary local winds, like we'll study some warm and some cold local winds. So within permanent, first we have land and sea breezes. What happens, let's say this is the daytime, which will be heated faster? Land heated faster. If land is heated faster, relatively air here will be warmer. Warmer air will rise, creating a low pressure condition. If it is rising, creating a low pressure condition, here the air is relatively cooler. Can I say relatively higher pressure condition will be there? We'll start seeing movement of wind from higher to lower pressure, and subsequent rise of wind is here. We start seeing completing this cell like this. This is what we call as sea breeze coming from the sea. During daytime you will experience sea breeze. In the night time, which of these two will have a higher temperature relatively? Land will be cooled much faster compared to water. If land is cooled much faster, it will have higher temperature, sorry, higher pressure, relatively low temperature, because it is cooled faster. If it is cooled faster, air near this will also be cooled faster. That means air near to the surface of the land will be heavier comparatively. Comparatively heavier है, ऊपर नहीं जाएगी, यहाँ पर उल्टा sink करेगी. Comparative to this, this will be relatively at a higher temperature. If it is at a higher temperature, can I say relatively air here will be at a higher temperature, it will rise, creating relative low pressure condition here. From high to low, wind will blow. So wind at night time will blow from land towards sea. We will experience land breeze blowing during night time. During daytime, it will be sea breeze. So daytime में wind will come from the sea. Night time में it will go towards the sea. Now why we normally Kolkata, Mumbai, Chennai do not experience pollution levels as it is experienced in Delhi? It is primarily because of this. Because there is continuous dispersion of pollution towards the sea. Every day, every night, in fact, I should say that land breeze blows, and along with this breeze, your pollutants that are here, they also go towards the sea. इसीलिए pollution near the coastal areas is very less. Same way, what happens in mountains and valley? In mountains, this is daytime, this is night time. So during daytime, relatively here, faster warming is there. If warming is faster, can I say here it will be relative high temperature? If the temperature here is higher, air will tend to rise here. Air will rise, creating a low pressure condition. Temperature here is relatively higher, creating a relative, see these two are relative. This is relative low pressure condition created, this is relative high pressure. We start seeing wind blowing from high pressure to low pressure. We start seeing wind blowing like this. In a way, ये पूरा cell complete होता था because of this wind motion. Wind is blowing like this. This wind sinks again to the bottom. क्योंकि यहाँ vacuum नहीं बन सकता ना. Somewhere wind will come and will fill this place. It comes like this. At the night time, what happens? We see outward radiations, terrestrial radiations going out from here. If high number of terrestrial radiations going out, this area will be cooled much faster. This region is cooled much faster, so air here will become denser. If it is becoming denser, it will come down slope. It will roll down the slope. So denser air comes down and uplifts the relatively warmer or less dense air. So here this is what we see, wind blowing down slope during the night time. This type of wind is called as anabatic winds. This is called as catabatic. So you might see these terms in the question paper as well. याद नहीं रहे तो Katrina is rolling down. Catabatic winds are rolling down slope. हाँ, यहाँ पर you will see inversion of temperature because air coming down slope will be cooler. You will see cool conditions या colder conditions here. Air that is lifted will be relatively warmer. So you will have relative warmer conditions here, relative cooler conditions here, leading to temperature inversion type of condition. देखा था temperature inversion में इसको? Same. Done? Now we'll move to temporary winds. These winds are temporary. They vary depending on season to season. They are not permanent. For example, Loo. Loo is not permanent wind. They blow during summer months. So same way you will have various warm and cold local winds that are blowing in that particular region only in few months of the year. अब क्या सारी याद रखनी है? I have listed down a few important ones. क्यों important है बस उसको देखेंगे. You keep jotting down some of those winds. बस उनको ध्यान रख लेना. These are most prominently asked. First we'll move on to warm local winds. Most important one being Chinook winds. Multiple test, multiple times exam में you might have seen Chinook winds there. Now Chinook blows from the Chinook blows in the areas of Rockies. So they will blow from, let's say this is Rockies, they will blow from this side of Rockies, they will rise and then they will come down. Rockies ऐसे है ना, so they will blow like this, they will rise and then they will come down slope. So this downslope wind that is coming down, this is what we call as Chinook winds. The Chinook winds blow on the eastern side of Rockies. This is Rockies, and on the eastern side of Rockies we have Chinook winds. Now see what happens when this air parcel is rising. What usually happens? Cloud formation happens. If anything is rising, can I say temperature decreases? If on rising temperature is decreasing, what will happen when the air is coming down? This is Rockies. This air parcel is rising. If it is rising, you say sir temperature decrease, and we also have clouds. Some precipitation can also be there. What will happen when this air parcel crosses this mountain range and comes down? Can I say this will be heated? First thing, this will be heated. Secondly, whatever moisture it was having, बहुत सारा तो इसने गिरा दिया, so it is now having less moisture here. If it is having less moisture, can I say it will be relatively drier winds? So it will be adiabatically heated. ऐसी term देखने को मिल सकती है, adiabatically heated, and it will be relatively dry winds. What do you mean by adiabatic heating? See, adiabatic heating means there is no energy that is coming and heating it. There is no energy transfer that is taking place. It is just because of change of pressure conditions, change of height conditions, we are seeing increase in temperature, and that increase in temperature feels like heating of that. So here, as it is coming down, it gets adiabatically heated. It is getting adiabatically heated. At the same time, if it is heated, its moisture holding capacity also increases. It is getting heated now, so moisture holding capacity is also increasing. Now it is able to hold more moisture. So अब जो भी wind होगी वो dry feel होगी. It is able to hold more moisture. अगर इसके पास 10 यूनिट था पहले, it contained 10 units of water, it shedded down 5 units of water. Example के लिए, so initially let's say temperature, let's say holding capacity of this would be, initially it was having 10 units and the holding capacity was 20. So it consisted of 50% water. As it was rising, it shedded down 5 units of water. When it comes down here, it consists of only 5 units water now, because it has shedded down 5 units of water. But let's say its holding capacity again increased to 20. Now it is consisting of only 25% of its capacity. So can I say it has become more dry now? Even drier wind is there. So this Chinook winds are drier winds, and when they come down they are heated adiabatically, so they raise the temperature of the region. In this region we also experience snowy conditions. So this Chinook winds are helping melting this snow, because 5 degree बहुत होता है, 5 degree temperature difference than the surrounding, good enough to melt the snow. So they are also called as snow eaters. Helpful for crops in this region, especially wheat. So here you will also see prairies. Later on we will see. So it helps in the crops growing in this area. So these are helpful winds, Chinook winds. Chinook, eastern side of Rockies. Adiabatically heated and dry, also known as snow eaters. It's any kind of downslope wind that is coming na. In general, a term phone is used for this. So Chinook is also a type of phone winds. कई बार किसी न किसी उसमें आपको देखने को मिल सकता है. Chinook is a type of phone winds. Phone is just a classification given here. A similar kind of wind is blown in the European region also, near the Swiss Alps. So this again blows from Mediterranean region in the Swiss Alps. What happens is, इसको हटा दूं. So again you have Alps here. This is, let's say, south. This is north. You have Swiss Alps here. Same thing will happen here. from south to north you are going. Same funda as we have seen in Chinook, same thing will happen here as well. As it comes down slope, it will be adiabatically heated. As it was rising here, you might experience rain in this part. So in the southern part of Alps, you might see rain because of this wind. In the northern parts, you might see relatively warmer condition because of this wind. So carries water from the Mediterranean Sea. It helps in the early ripening of mangoes here in this region. थोड़ी सी बस लोकेशंस का ध्यान रखना है. चिनूक इज इन यूएसए, रॉकीज. फोन इज इन Alps. Next comes another important wind from Alps region, that is Sirocco. See what happens in Sirocco wind. Sirocco wind starts blowing from your Sahara desert in Africa. As it starts moving, this part will be relatively hotter, Sahara desert hai, and dry. So as it blows towards Europe, it encounters Mediterranean Sea. From Mediterranean Sea, this wind will pick up moisture. It is hot also, so it has a greater capacity to hold moisture. Already it was dry, so its capacity was also not fulfilled. Now it will hold a lot of moisture. As it encounters here, as it comes to Italy or Italian Alps, we see all of this moisture being dropped down. But along with the moisture, what happens is when it starts blowing, it brings down, yeah, it also carries with it some of the sand particles from the Saharan desert. And these sand particles are usually red in color. This red colored sand particles mixed with all the water, when it falls down as precipitation, it looks like blood, also known as blood rain. So Sirocco is linked with blood rain in the Italian Alps wala region. Is this clear how this is happening? कोई बना रहा है क्या? Draw it quickly if someone is drawing. Done? Now you have another important wind called Harmattan. Now Harmattan winds blow from this region. They blow in this region. थोड़ा सा इधर उधर बना हुआ है यहाँ पर, ध्यान रखना. Again they start from Africa only, from the Sahara desert only, but they blow towards Grain Coast, Slave Coast, Ivory Coast, and all of these nations. These are all these nations here. Usually slave nations were here. So they blow from drier conditions towards the coastal conditions. Now what happens is, normally in the coastal region, if the humidity is higher, it leads to various skin diseases. So normally in rainy season, you might experience some or the other skin diseases because of moisture. खुजली आएगी, कुछ भी हो सकता है. When these dry winds come, since they are drier, they suck up some of the moisture of the already prevailing wind system there, because ये dry है. तो एक wet winds थी, एक dry winds थी, दोनों mix हो गई अगर, तो relative moisture अब जो बचा वो थोड़ा सा कम हो जाएगा. So already what happens is, what was the moisture condition prevailing, because of this wind, the moisture in the winds relatively decreases. Because of this skin problem all automatically cures there. So just because of coming of the winds, there is decrease in the skin diseases prevalent there. It reduces skin diseases. That is why it is called as doctor winds also. So Harmattan, also known as doctor winds. Chinook, snow eater, Sirocco, blood rain, Harmattan, doctor winds. They might directly give you this to match the column type of questions. Done? कहाँ कहाँ blow करती है? Chinook in USA, Fohn winds in Alps, Sirocco, from Sahara to Italy. Next, Dr. winds सहारा टू नीचे गिनी कोस्ट या गाना वगैरह में हरमैटन. Next you have Zonda, a similar type of wind to Chinook, but here it blows in South America, almost similar in nature. It starts from here, we say it is dry wind, and then it picks up moisture. So Zonda is in South America, almost a similar kind of thing. It goes up on the Andes and then comes down. So it is also a type of fohn wind. Lu, North India, self-explanatory. Then you have two more winds. इनका बस नाम ध्यान रख लो. Where it is located and what is the name. So Khamsin wind in Egypt. Khamsin wind here in Egypt, and then you have Santa Ana winds in California. It is responsible for wildfire conditions. So again, downslope wind, if it is downslope, it leads to relatively higher temperatures. तो wildfire और aggravate कर देती है. Hot and dry winds. मेन वो पहली चार वाली बस याद रख लो. इनके बस नाम और लोकेशन, नाम और लोकेशन. Zonda, South Africa, South America. Lu is in India. Then you have Khamsin in Egypt. One last, Santa Ana in California. Done? Can you recall all 8 winds? Hot wali. Let's move to cold winds. Now one major cold wind that we will study is Mistral from France, and it blows, it passes through Rhone Valley. I'm writing Rhone. Rhone is another river. Rhine Valley alag hai, Rhone Valley alag hai. This is Rhone Valley. And when it passes through Rhone Valley, let's say this is the valley, there is some kind of funneling effect that happens. Funneling effect is, let's say it was coming from a huge area and now it is being channeled to a very narrow valley. If wind coming from a larger area is channeled to a narrow valley, can I say its speed will become very high? So it will have a high speed because of this funneling effect. And just because of this high speed, this blows from north to south. Hai na? In France, usually homes are not constructed facing northwards because of the effect of this Mistral winds, क्योंकि बहुत तेज और बहुत ठंडी winds होती है ये. See, approximately 100 kilometers per hour. So in France, homes are usually not constructed facing northwards just because of this Mistral winds. Again, Bora winds slightly इधर आएगी, थोड़ा ऊपर बनी हुई है diagram में. Again, a type of cold winds near Alps. It picks up moisture from the Adriatic Sea and brings rain in Italy. Italy, Mediterranean region, winter rainfall is a feature of Mediterranean type of climate. This also contributes there. Bora winds. Then you have blizzards and burans, almost similar impact, very cold coming from the polar areas. So blizzard here in this region, in Canada wala region, you will have high speed icy and dusty winds. So you have very thanda and very high speed winds. They are fatal winds because see, they have dust particles along with the wind itself. Imagine wind is blowing at a very high speed and it also has dust particles with you. When it comes in contact with your skin, it will just tear off the upper layers of your skin. अगर बहुत ज़्यादा स्पीड में wind आ रही है and it also has dust particles, it will just tear off the skin. So that is why it becomes fatal. Same way, Burans you will have in Siberian region. Buran winds. Pampero in South America. Here you will have in Argentina and Uruguay, you will have Pampero. One last, Busters in Australia. There are 4 major winds starting with B. तो अगर याद नहीं आए तो 4 तो B से थी. Then you have Mistral and Pampero. Done? Let's recall what we have studied. पहले winds पढ़ लेते हैं. Local winds में in warm and cold winds, tell me क्या क्या याद आ रहा है. Chinook, सेंटा एना सबसे आखिरी में थी. सिरोको, फोन, जोंडा. यहाँ पे कौन सी थी चौथे पे? हरमैटन, जोंडा, लू, खामसिन एंड देन सेंटा एना. याद आ रहा है? डॉक्टर विंड्स कौन सी है? हरमैटन. स्नो ईटर, चिनूक. और सिरोको, ब्लड रेन. ठीक है. हियर you have Mistral and Pampero. Next you have 4 from B's. Bora is in Alps region. You have blizzards in Canada. Then Buran is in Siberia. Then Busters in Australia. Location याद आ रही है कैसे सब कुछ? Tell me where was Zonda? South America. Pampero, South America. याद हो रही है चीजें? ठीक है. So this done. Next, one of the most important thing that we'll see is monsoons and cyclone. Now monsoon ko when we are studying, it is some kind of periodic wind or a regional or a seasonal wind that is there. So if I am saying some kind of periodic wind, there has to be some periodicity associated to it. Normally what we'll see, for first 6 months they will blow in southwest direction, then their direction is reversed, they will blow in northeast direction. So southwest and northeast, there is a reversal of wind pattern. हर दिन नहीं बदल रहा है. It is 6 months like this, 6 months like this. Periodic reversal of wind is a feature of which type of climate? Question पूछा जा चुका है. Monsoon type of climate. Normally it occurs in the tropical regions only. ये say reversal of wind system you might not encounter in higher latitudes. It is in the tropical regions where we encounter this. अभी हम समझेंगे कैसे हो रहा है पूरा मॉनसून का मैकेनिज्म. One major thing that leads to onset of monsoon, this factors that we are leading is what all factors leads to onset of monsoon. Onset is starting. Onset is starting of the monsoon. So one major thing is differential heating and cooling of land mass. What does this mean? You have Indian landmass here. It is heated at a much faster pace compared to this. If it is heated at a much faster pace, it will have relatively low pressure. Sea will have relatively higher pressure. It can attract air from sea to land. Differential heating. Next comes position of ITCZ. What is ITCZ? ITCZ is an intertropical, पहले नाम समझो, intertropical, between the tropics, intertropical convergence zone where trade winds are converging. So normally if we draw, we will say that trade winds are converging near the equator, so ITCZ should be at the equator. But now understand, this was a low pressure belt. It was created because of thermal conditions. Thermally induced means it depends on the position of sun. So can I say, depending on what position sun is in, this low pressure can shift as well. So this whole wind system that we have just studied can shift depending on the position of sun. Now what will happen when sun lies in the northern hemisphere? When sun is in the northern hemisphere, let's say sun is at the tropic. When sun is at the tropic, what we see is this complete low pressure area starts shifting towards the northern hemisphere, as it is seen here. So it starts shifting slightly over the northern hemisphere. India may, it comes almost over India. It comes almost to the Tropic of Cancer. Here what we see is convergence of wind. अभी शायद आपको डायग्राम में नहीं दिख रहा होगा, but we are seeing this winds and this winds converging here on this intertropical convergence zone. आपको शायद दिख नहीं रहा होगा दूर से, but यहाँ पर these are small wind lines that are being drawn and they are converging on this ITCZ. So one major factor that leads to onset of Indian monsoon is shifting of ITCZ above the Indian subcontinent, yeah, over India. So as this shifts over India, this position of ITCZ, it shifts on Indian subcontinent. As it shifts, it brings the low pressure area along with it over India. So imagine you have more low pressure created on Indian subcontinent. It will again attract more and more winds. Now if you have low pressure, low pressure can have winds coming from any direction. You have low pressure, why should I say that wind is coming from this direction only? यहाँ से भी तो आ सकती है, यहाँ से भी तो आ सकती है, कहीं से भी आ सकती है winds तो. So why particularly southwest monsoon? Why is it southwest only? Coriolis will understand. Let's say this is equator, this is Tropic of Cancer or Tropic of Capricorn, this is Tropic of Cancer. India is situated somewhere here. Ab I am saying that your ITCZ has shifted, let's say, to the Indian subcontinent. So this ITCZ, and because of the apparent position of sun, normally it would have been that your wind should be like this. Originally your wind should be like this, but because of this shift, what will happen? All the winds coming from the southern hemisphere will come up to ITCZ. On the winds lying here will come up to ITCZ and they will converge near the ITCZ. So now what will happen for any wind that is coming from the southern hemisphere? This is equator. Wind was coming like this. As it crosses the equator, now it is northern hemisphere. How will wind deflect in northern hemisphere? Towards their right. So as it comes here, it starts deflecting towards the right. So even though these winds are coming from the northern hemisphere, once they cross the equator, they start deflecting towards their right. Now this appears to us as if it is coming from southwest direction. So this is why we call it as southwesterly monsoonal winds. They are southwest monsoon. They appear to come from southwest direction. Is this clear? So shifting of ITCZ leads to a low pressure created here and it attracts all the winds from here, from the southwest direction. These are first two major things that you need to keep in mind. Is this clear? Now third factor is subtropical westerly jet stream. So before this, let's once again go back to understanding the jet streams. So jet streams are upper level circulations. Jet streams are not in the lower levels, they are in the upper troposphere relatively. Their heights can vary depending on the location. They can be anywhere between 7 to 14 kilometers. Relatively higher troposphere, relatively lesser friction is there at this particular height. What happens is, यहाँ पर as we have understood, jet streams, where will it blow? यहाँ पर as it comes, this is equator, this is tropic. I have drawn this cell, याद आ रहा है? This wind is coming from equator towards the tropic. From equator towards the tropic, as it is going, it will deflect towards the right. As it deflects towards the right, because of high velocity, it will experience high Coriolis force. Itna high hoga that it becomes almost parallel. So what we'll see is there is a continuous wind, and here we start seeing a circulation that keeps on blowing along with this wind. This is what we call as jet stream that keeps blowing. कुछ देर बाद ये डिप भी करेगा यहाँ पर, but there is enough wind to sustain this particular jet stream. It looks like a river of air that is flowing above this. At this particular height, it looks like a fast moving river in the atmosphere. एक wind blow कर रही है. So here exactly at this position, this particular jet stream is blowing. And observe what pressure condition will be here. On the bottom, it will be high pressure. So wherever we are having jet streams, यहाँ पर subtropical westerly jet stream, on the surface you will experience high pressure conditions. Now coming back to India, तो बाद में देखते हैं, अभी पहले ये समझो. Coming back to India, subtropical westerly jet stream. If subtropical westerly jet stream is lying over India, or if it is flowing above India, the condition on the surface will be high pressure conditions. So till the time subtropical westerly jet stream is over India, you will experience higher pressure. If higher pressure is there, it will not attract monsoon. So for monsoon to come here, you need this jet stream to shift, yeah, move out of India. So till the time this jet stream is there over India, you will not experience monsoon. This jet stream is supposed to move out. देखते हैं कैसे होगा. So we have two jet streams. One is this mid-latitudinal or polar jet stream or circumpolar jet stream. All of this इसी jet stream का नाम है. This is subtropical jet stream that we have. We'll see impact of jet streams later on. Now see what is happening. You have in winter season, this is winter. In winter, all of the pressure belts are shifting towards, they will shift towards south. Winter mein, sun is in the southern hemisphere. During winter, sun is in the southern hemisphere. All the pressure belts will shift south. Consequently, your subtropical westerly jet stream will also come slightly towards south. It will establish over India. As we are approaching early summers, what will happen is this jet stream will bifurcate into two. There will be two branches, one going above India, one still over India. Wherever we have this jet stream, we will have a higher pressure condition. Achha, why will it bifurcate? We have Himalayas. What is the height of jet stream that we have seen? 7 to 14 kilometers. What is the height of Himalayas? 8,890, approximately 9 kilometers. तो बीच में अड़ गए, हिमालयस बीच में आ जाएगा ना. It is blowing at 7 kilometers. Himalayas is 9 kilometers. So it will bifurcate this jet stream here. One branch is still over India, one branch is established above this. As we'll go to summers, we will see this branch completely moving out of India, establishing over Himalayas. As this branch moves here, we will see lower pressure conditions prevailing here. Once this branch moves above Himalayas, then only we will see onset of monsoon. Till the time this jet stream stays over India, or a branch of jet stream stays over India, will not see onset of monsoon. Monsoon onset will only be when this jet stream moves above Himalayas. This is where we will see onset of monsoon. This will help in creating low pressure conditions now. if somehow it happens that this jet stream has re-established its branch, it might happen because of climatic some reason. If it re-establishes its branch below Himalayas, again we will have higher pressure conditions. It may lead to break in monsoon. So it might happen that for 10-15 days it was raining, then again next for 1 or 2 weeks it is not raining. So we might experience breaks in monsoon if this jet stream is establishing another branch below India, because it leads to higher pressure condition. आप बस इस डायग्राम से समझ लेना, इससे याद रख लेना, here jet stream was blowing and here we have high pressure. अब जो भी क्वेश्चन आएगा इमेजिन करना इसके नीचे हाई प्रेशर है तो क्या होगा. इज दिस क्लियर? अच्छा ये समझ लेते हैं, 2-3 बार दिख गया है. See what happens is, normally we have a polar jet stream that is confined here. If somehow this jet stream weakens, what is here near to this jet stream, this polar jet stream, we have winds coming from polar regions coming towards the temperate areas. This will be cold winds and here this will be relatively warmer winds. If somehow something happens to this jet stream, if it weakens, whenever jet stream weakens, jet stream are like rivers. So whenever river weakens, imagine river in the youthful phase river is in Himalayas early stage, you will never see meandering. As it comes down, as the velocity decreases, it starts meandering in the plains. Same way jet stream starts meandering as it weakens. If somehow the jet stream is weakened, it will start meandering. As it starts meandering, you will see colder conditions. या यहाँ से क्या आ रहा है, cold winds आ रही है. You will start seeing these colder winds coming far south. At the same time, you might see some warmer patches being formed in the higher reaches as well. So because of this jet stream weakening, you might start seeing colder conditions coming here and hotter conditions in some of the regions. तो हम और थोड़ा सा देखेंगे आगे, but right now is this clear how this is happening? This jet stream not only just plays a role in onset of monsoon. The jet stream blows from, direction is constant, it blows from west to east. As it blows from west to east and as it meanders, it also picks up some moisture from Mediterranean Sea, Black Sea, Caspian Sea and all of it. It will pick up these moisture and it will shed the moisture after hitting Himalayas in this region. It leads to winter rainfall and snowfall over the Indian northern continent, yeah, northern part of Indian subcontinent. So this is what we experience, western disturbances during winters, and it is helpful for rabi crops, especially wheat in Punjab and Haryana. Done? हाँ नहीं, यहाँ पर देखो हाई प्रेशर, इट इज स्टिल हाई प्रेशर. ये और ऊपर जब चले जाएगी, this is early summers only. As you will have summer conditions prevailing, this jet stream will completely go above Himalayas. This jet stream will completely shift above Himalayas. So पूरी ऊपर शिफ्ट हो जाएगी और Himalayas नहीं है और ऊपर शिफ्ट हो जाएगी. Eventually you will also see low pressure condition in Tibet region also, क्योंकि ये jet stream और ऊपर शिफ्ट हो चुकी होगी. So this jet stream will shift even higher. This is just early summer conditions, maybe month of March. This condition, this is winter condition completely over India. Early summers slightly above Himalayas, slightly below Himalayas. Summer completely over Himalayas. ठीक है. So these three conditions for monsoon clear: differential heating of land, position of ITCZ and subtropical westerly jet stream. लिखना है लिखवा दूं, बोर्ड से छापोगे? अरे लिख लिया, ठीक है। Now these three things go hand in hand. You will have subtropical easterly jet stream, so another jet stream will come into picture here. You will have heating of Tibetan plateau and Mascarene high. Now what happens is, what is the height of Tibetan plateau? Approximately 4.5 kilometers. Can you imagine 4.5 kilometers ऊपर है? How much high insolation would have been there? तो relatively ज़्यादा insolation होता है वहाँ पर. अब higher pressure conditions are there because it is summer time. For southern hemisphere it will be winter. Here in southern hemisphere we have a place called Mascarene. यहाँ पर इस जगह मेडागास्कर के पास में you have Mascarene here. So here you have a high pressure created. Here on the Indian subcontinent you have relatively low pressure created. We start seeing winds from here to here, they are blowing. From high pressure to low pressure winds are blowing. अभी मैं पूरा कोरियोलिस लगा के ऐसे ऐसे नहीं दिखा रहा हूँ. Just imagine that it is blowing from here to here. At the same time you have a Tibetan plateau that is being heated because it is summer, peak summers. Let's say monsoon कब आ रहा होता है? 1st June. That means May is peak summers. So at that time your Tibetan plateau is also heated. If Tibetan plateau is heated, we see rising of winds from this. Low pressure condition is created on Tibetan plateau. We start seeing rising of winds over the Tibetan plateau. अब यहाँ पर ऐसे जा रही है, it is rising also. If it is high pressures from somewhere, wind might be dipping as well. We start seeing a jet stream that completes this particular cell. This particular cell is completed because of the jet stream that is there. So from high pressure we start seeing this flow of wind towards the Tibetan low. From Tibetan low it is rising. From here something is dipping. ये dipping कहाँ से हो रही है? It is because of this jet stream that is being set. It is called as tropical easterly jet stream. These three things go hand in hand, that you have tropical easterly jet stream setting in, you have high heating of Tibetan plateau, and you have high pressure at Mascarene high. All the three things together leads to the onset of Indian monsoon. All the three things combined. Tibetan plateau, winds are rising, low pressure condition created. Here you have high pressure in Mascarene, winds are getting attracted, high pressures from somewhere winds might be dipping. This dipping winds come from the tropical easterly jet stream that is set in. Is this clear? जो बोला है वही सब यहाँ पे लिखा हुआ है. हाँ, ऐसी ही है सोमाली जेट स्ट्रीम. वो यहाँ से भी आती है, लो लेवल जेट है सोमाली, और लो लेवल जेट है सोमाली जेट स्ट्रीम. अगेन दिस इज अ टेम्पररी जेट स्ट्रीम. ये हर टाइम नहीं होगी, इट इज टेम्पररी. those two jet streams that we saw, subtropical westerly jet and tropical wala and polar wala, circumpolar jet stream, these two are permanent. This is a temporary jet stream that we have. लिख रहे हो क्या? लिख लो. These three things go hand in hand. Done. See, all of these are onset factors. They lead to onset of monsoon. Indian Ocean dipole, and along with it we will see El Nino, La Nina, MJO. These are not onset factors. They will just impact the intensity of monsoon. We'll see them one by one. So Indian Ocean dipole. Dipole is, there are two contrasting things being created. We call them as dipole here. अब what happens? Normally we have masculine high जो अभी हम देख रहे थे. This is my masculine high that is there. Here over Australia we have relatively low pressure. This is relative, है ना? Relatively low pressure created there. Over masculine high we have relative high pressure created. In normal conditions we will see wind blowing from on the ground level, wind blowing from high pressure to low pressure. From low pressure wind is rising and it is sinking over high pressure. This happens in normal condition. If somehow this is reinforced, can I say more and more wind descending over masculine will reinforce this high pressure conditions over masculine. So if more and more wind is descending over masculine high, it will reinforce the high pressure. If higher the high pressure created here, can I say more strong monsoonal winds will be created, it will be better for India. So in positive IOD what happens is this is reinforced. This descending limb over masculine high is reinforced. This happens in positive IOD. You also call it as Western Pacific pool. ये जो चीज है. So Western Pacific pool is reinforced. A strong Western Pacific pool, strong masculine high. If masculine high is strong, we will have strong winds being attracted towards India. But somehow, let's say in El Nino years or because of certain other conditions, let's say this masculine high is not able to get the support that it was getting from here. If it is not getting this support that it used to get from here, can I say this masculine high will be slightly weakened compared to this. If this high pressure is slightly weakened, your monsoon will be relatively weak. Now this is relatively weaker conditions where you will have monsoon. It may happen that some kind of interaction started happening in this region. If the interaction started happening in this region, we might not have higher and lower pressures comparatively here jitna yahan tha. If higher and lower pressures are not created here in this region, we will not have good Indian Ocean dipole being created. If it is not created, we will not have high masculine high. Masculine high is relatively weaker, your monsoon is weaker. So in negative IOD, your masculine high is weak. In negative IOD, your masculine high is weak. If your masculine high is weak, lesser winds are attracted towards India. Okay. Now what happens in El Nino, La Nina conditions? See, abhi normal conditions mein we have seen that we have lower pressure created here. Same way here in normal conditions, what we will see, because of trade winds blowing like this is equator. If this is equator, trade winds normally blow like this in this direction and like this. So what we see is effective movement of water along with this winds from eastern side to western side. Here we will see effective movement of water. Because of this movement of water, the movement of water means पूरा पानी नहीं आएगा. It is just the upper layers that are moving. So upper layer water is moving. Upper layer water will be relatively warmer. So what we'll experience is a warmer pool of water being formed here and relatively cooler waters being formed here. Warmer pool of water will have warm air mass. It will rise. It is less dense. It will rise. If it is rising, it will create relatively lower pressure conditions here. This happens in normal condition. Here also it is happening in normal condition also, that we are creating, we are having relatively lower pressure being created here. Ab, it may happen that somehow this is reinforced. If this is reinforced, we will have La Nina condition, that this trade winds became strong If this trade winds became strong, we will see larger pool of warmer water being formed. We will see reinforced conditions. This we call as La Nina conditions being formed. But somehow, if this trade winds are weakened, we might not see movement of water coming here. It might happen that water starts flowing in opposite direction, or it might not move. हो सकता है उल्टी डायरेक्शन में जाए, हो सकता है मूव ही ना करे. So if it is happening, can I say all of these conditions will be weakened? If these conditions are getting weakened, earlier we used to get low pressure formed here. Here you will have high pressure formed, and here you will start seeing low pressure being formed here. If you are having low pressure here, you will see relative rise of winds in this region, and accompanied with it you will have clouds being formed. Winds rise hogi, so you will get clouds. Clouds will lead to rain in this. So here you will experience rain in South America. Here you will experience dry conditions. So during El Nino years, you will experience rain in South America and drier conditions in Australia. Here you will have Australian bushfires. Recent bushfires in Australia coincided with El Nino year. So drier conditions. Here you will have wetter conditions. Is this clear what will happen? Now all of this will impact Indian monsoon, because it will impact what conditions are being formed over Australia. It will reinforce conditions over mascarene high. What impact El Nino has? Australia और इस पे देख लिया. See, one more thing that happens is, as water moves from here, we see upwelling of water from the downward ocean bottoms. We see upwelling of the water. This upwelling brings nutrients. So if good upwelling is there, more and more nutrients will come above. If more nutrients are coming ashore, you will have fishing zones being created, or you will have good plankton growth, in a way good zooplanktons and good fishing. So fishing industry and fertilizer industries start flourishing here in this region. But when it is opposite, they will not. Fishing will cease because of this upwelling will cease, consequently leading to lesser fishing, lesser fish catches. So it is disastrous for fishing industry here as well, and it will lead to droughts in Australia, droughts and wildfires. Done. Impact of La Nina. Opposite of it, whatever we have seen in El Nino, almost opposite of it will be in the impact of La Nina. What is MJO? Madden-Julian oscillation तो full form हो गया. What happens is, it is a Walker cell. It is a cell that moves eastward. Good. It moves eastward in southern hemisphere. It starts moving eastwards, and it encircles the globe in about 30 to 90. Normally it is 30 to 60 days, but can extend up to 90 days. Up depending on when monsoon was about to come, when all the conditions became favorable for the onset of monsoon, where is this circle, where is this MJO at that particular instant? If it is creating some kind of favorable conditions for all those conditions, it will lead to good monsoon. Else, if it is having some other opposite effect, for example, this limb will lead to high pressure condition here. If it coincides with mascarene high, it will reinforce mascarene high. This limb will lead to lower pressure conditions. If this limb coincides with mascarene high, it will lessen the impact of mascarene high. So it can have both the effects, depending on whether this limb is coinciding with mascarene high or whether this limb is coinciding, because it is continuously moving. Also, let's say it encircles the globe in 30 days. 30 days is just 1 month. Monsoon season is about 3 to 4 months. So within this one monsoon season, it can come and encircle it 2 to 3 times. अगर 60 दिन भी हो गया तो 2 बार आ जाएगा. So what will it cause? Depending on which limb is coinciding, it will have breaks at that time. या it will impact monsoon at that time. और ये हर साल करेगा, ये हर बार करेगा, because it will keep on moving. क्यों चल रहा है? Scientists are still trying to find out what is happening with the MJUs. Done? Active phase can initiate onset of monsoon, brings frequent cyclonic activity. It can bring frequent cyclonic activity as well. Shorter cycle, normally it is experienced that when cycle is shorter, relatively lesser number of days it is taking, it leads to good monsoon. But if it is having longer cycles, it is having dry monsoon that is there. तो जितना shorter cycle है MJO का, उतना it is good for Indian monsoon. Normally this is the relation, but still it is under experimental stages. Done? लिख लो, कुछ points लिखना है इसमें तो. See, this complete cell is continuously moving. It is not there at particular instant. This is continuously moving in southern hemisphere. So somehow this limb is coinciding with, let's say, masculine high. If this comes, it will create low pressure condition wherever it is. वहां पर high होना चाहिए, इसने low create करा है थोड़ा सा, so it will lessen the impact of that high pressure. But if this limb is coinciding, because it is continuously moving across the globe, if this is coinciding, it will reinforce that high pressure condition. It is because of some kind of planetary interaction still under. एक बार इसको बस जस्ट रीड आउट, एक बार खुद से पढ़ो, जो हमने सीखा है अभी सारा कुछ इसमें लिख दिया है. देन वील सी एडवांसमेंट ऑफ इंडियन मॉनसून. If you want to finally note down the mechanism of monsoon, you can just note it down. डन? सारा समझ में आ रहा है? जो जो हमने पढ़ा है इससे रिलेट हो रहा है? ट्रॉपिकल स्टिली जेट स्ट्रीम वाला, it sets after STWJ is withdrawn. The STWJ, here you have Himalayas, let's say. Here you have Himalayas. STWJ यहाँ कहीं चली गई है अब. We are having a Tibetan low pressure region being formed here, and a mascarene high is reinforced here. This mascarene high will have some descending winds, and this Tibetan low pressure will have rising winds. Also, this low pressure region will attract winds from the high pressure region. Now this winds from here, we have seen that it starts blowing towards the high pressure region over my screen high. This is what is that your direction of tropical easterly jet stream. ये ऐसे set in होती है. It sets in only after your subtropical westerly jet stream has moved much above Himalayas. Now Indian monsoon, we have two phases. One is advancing phase, यहाँ पे होगा. One is advancing phase of Indian monsoon, other is the retreating phase of Indian monsoon. We have advancing phase of Indian monsoon and then the retreating phase. Monsoon does not come in one go. यहाँ पर you might experience it on 1st of June. Till the time it reaches Delhi, it will be almost 20-25 June. So it takes almost about a month to advance and almost about a month to retreat. Let's say it started retreating somewhere from here from 17th of September till 15th of October. It has reached to this stage only. So almost in a month it has retreated only this much. So it advances slowly, it retreats slowly. Now as it advances, first thing, let's say it is coming from this side. It breaks into two branches. One is your Arabian Sea branch, other will be your Bay of Bengal branch. Arabian Sea branch, as it comes here, it will encounter Western Ghats first. A lot of rain will be shedded here because Western Ghats, they are relatively continuous. Very less passes are there. So most of the clouds will precipitate here. Next, some of the winds from this branch will also enter this region. It will blow almost parallel to Aravallis, where we will not experience any rain because they are parallel here. Somehow we can also see some gaps, and from here it will enter this regions as well. There can be some rains in this part. Let's say near Pune and all, we'll see some rains here as well. Here, because of a rift valley between Vindhyas and Satpuras, we also see monsoon entering in this regions also. But most of the region here, they lie in the rain shadow zone of this particular Western Ghats. So we will see very less rain in this particular region because of your Arabian Sea branch of monsoon. What happens to the Bay of Bengal branch? अभी इधर से कैसे आ गई? नहीं, नीचे से तो ऐसे जाना चाहिए ना. It is coming from southwest, so it has to be southwest. It has to be in the southwest direction only. So if these winds are growing like this, it has to be southwest winds. How are they entering like this? So we have Arakan Yoma यहाँ पर, and because of which these winds are deflected. Because of Arakan Yoma, it extends here, because of which these winds are deflected and appears to be coming from this side. As it enters, it encounters Eastern Ghats. Eastern Ghats are not continuous. It has lots of gaps in between. Because of these gaps, wind can easily enter the peninsular India. And we'll see lot of rains here, and this rain is maximum because of this maximum rain in this part is because of Bay of Bengal branch, not the Arabian Sea branch. So here we have good forest, Naxal areas, Chhattisgarh and all heavily forested because of good rains coming from the Bay of Bengal branch. Also we will see this branch entering in the northeastern India as well. One of the highest rainfalls in India happen here. इसमें डिटेल में हम इंडियन ज्योग्राफी जब पढ़ेंगे तब जाएंगे यहाँ पर, ठीक है. बट दिस इज हाउ टू ब्रांचेस एडवांस देयर. Retreating monsoon. Now just see what conditions will prevail during retreating monsoon. Retreating monsoon कब होगा? September end या October. At that time where will your sun will be? Sun will come relatively near to equator. In September it will be over equator only. So sun is somewhere here. That means can I say ITCZ will be lying here somewhere below India. If ITCZ is here, all the winds coming from here will try to converge near ITCZ only. If it is coming like this, if it is coming from here, it will move towards its right. The winds will move towards right. It will appear as if they are coming from northeast. So we will have northeastern winds during the retreating monsoon. So these are the northeastern winds that are blowing over India. Now see, will it rain in any of these parts? No, they are coming from relatively drier areas only. It might happen that because it is October time, let's say October is, just tell me here, you will have high pressure or low pressure condition. Now you will have higher pressure conditions. High pressure condition is clear sky. Clear sky means higher insolation. We start seeing heating conditions in October. इसीलिए अक्टूबर में वापस से गर्मी लगने लगती है. We start seeing heating conditions. Now what can happen is, during October, this area is under higher pressure, high pressure, clear sky, more insolation. It might happen that all the winds coming from here may pick up moisture and may rain locally. So in October we may see some local rains, but it is just because of convection that we are seeing rains here. During the month of October, it is convectional rainfall that we'll see. It is not the monsoonal rainfall that we are seeing. At the same time, all the winds coming from here can pick up moisture from this part of Bay of Bengal, and when they encounter in the Tamil Nadu coast, they will rain here. So इसीलिए during retreating monsoon, this particular coastline experiences rain. Major part of India is still dry, but there can be localized rain because of convection, because it is higher pressure, higher pressure, dry conditions. कोई clouds नहीं है, more insolation. More insolation means high heat, high evaporation. High evaporation क्यों होगा? Because after rainy season, land has water. सारे reservoirs are almost full. Your soil moisture content is relatively higher. So when these conditions are prevailing and you suddenly increase the temperature, you will start seeing higher evaporation. इसीलिए we start seeing local rainfall during October. Is this clear? But this is not monsoonal. This is just a convective rainfall that we'll see, localized at the places. So बताया, it is just that written how everything happens. Lately this year we have seen a lot of rain in some of the northern states in India. Punjab, Jammu Kashmir, it was very devastating. Himachal वगैरह सब कुछ. Why? Western disturbances. What happens with western disturbances? Now see, what is happening is, it again has something to do with jet streams. As the global temperatures are rising, it leads to decreased contrast in temperatures between equator and poles. What happens is, there is a term called Arctic amplification. What does this mean? Amplifier क्या करता है? It increases something. Amplifier amplifies something. So if Earth is heated by 1 degree, Arctic region will experience that particular heat as 4 degree. So we will see amplification of this heating. So in Arctic region it will be 4 degree rise when Earth has been heated by 1 degree. Ab in general, let's say this is pole and this is equator. This particular region, these two regions are having some kind of temperature contrast. Temperature contrast is, let's say, temperature difference. But if it is rising at a slower rate and it is rising at a very fast rate, can I say this temperature contrast will weaken now? It will decrease this temperature contrast. अगर ये पहले 30 था, ये 0 था. For example, this 30 became, let's say, 32, but at the same time this 0 became 8. This difference which was 30 now, it is now reduced to 24 only. Example के लिए बड़े numbers लिए. So this temperature contrast is reduced. This temperature contrast weakens your jet streams, and this jet streams when weakened it leads to waving of your western disturbances in the jet stream here. तो ये और ज्यादा यहाँ पे हरकत करने लगते हैं जो western disturbance here. So this western disturbance along with this Arabian Sea branch and Bay of Bengal branch formed this particular zone here, and it lead to huge rainfall in this particular area. तो यहाँ पर इस particular zone में बहुत ज़्यादा बारिश हुई because of combination of western disturbances, your Arabian Sea and Bay of Bengal branch. Now you will say sir ये तो कभी भी हो सकता है, but normally western disturbances occur in winters and these two are there in rainy season. But this time we have experiences western disturbances during rainy seasons as well, and this has amplified the conditions here leading to high rainfalls in this particular zone. इसलिए बहुत ज़्यादा बारिश हुई थी. पंजाब में तो ऐसा था 20-25 दिन तक शायद बारिश हो ही रही थी continuously. It happened because of this particular phenomena that all the three played a role here. Is this clear? So western disturbances, ध्यान रखना, some question can be expected. They are not limited only to winters. They can occur in any time of the year. They can occur. Last year we have seen them in October. Not in October, in August as well. Let's recall what we have studied. After your local winds, क्या क्या सीखा? हाँ, अब तो कॉपी में भी कुछ नहीं लिखा सर, अब क्या बताएं? डोंट वरी, आई विल गिव ऑल द स्लाइड्स. अगर आप इफ यू आर नॉट जॉटिंग डाउन, मैं सारी स्लाइड्स दे दूंगा एज इट इज. हाँ, क्या देखा था सबसे पहले? मॉनसून में व्हाट आर द फैक्टर्स दैट वी हैव सीन? डिफरेंशियल हीटिंग ऑफ लैंड एंड वाटर, देन ठीक है, पोजीशन ऑफ ITCZ, देन subtropical westerly jet stream. If westerly jet stream is over India, what will be the condition prevailing? High pressure condition. So if we want to attract monsoonal winds, we need to move this jet stream out of India. So when it will shift out of India, then only we'll have onset of monsoon. As it shifts out of India, there are other factors that also come into play. That is, tropical easterly jet stream starts setting in, heating of Tibetan Plateau and Mascarene High. तीनों का रिलेशन याद आ रहा है कैसे वो सर्कल बनता था, पूरा डायग्राम. देन देर आर सम फैक्टर्स दैट इम्पैक्ट IOD. Positive IOD will have positive impact, negative will have negative impact. El Nino, La Nina, their impacts. Is this clear? उनके impacts भी done. इसके बाद MJO, then advancing and retreating of monsoon. Now we'll come to cyclones. First we'll see tropical, then we'll move on to temperate ones. Normally whenever you see a news about cyclone, एक लेमैन की टर्म्स में बताना, what do you see in news? Whenever a cyclone occurs, न्यूज वाले क्या बोलते हैं, क्या क्या हो रहा है? एक. What happens? High speed wind or rainfall and thunderstorm. वो रेनफॉल के साथ रिलेट हो गया थंडर. देन devastation, destruction, it is because of high speed wind. And सुनामी आ गई, फंडे हिले हुए तुम्हारे. फ्लड्स वगैरह, ठीक है. ऐसे ऐसे सुनते हो, हवा कैसे दिख रही है? गोल गोल घूम रही है. तो स्पाइरलिंग एंड बवंडर आ रहा है, स्पाइरलिंग विंड एंड रेनफॉल है तो क्लाउड्स, हाई स्पीड विंड. See, इसी से just we'll try to see what all conditions will prevail when you have cyclone that is coming. For cloud formation, what do you need? Low pressure rising wind. Cyclone is a low pressure circulation. If it is spiraling, it is a circulating vortex that we have, low pressure. High speed winds, that means isobars are closely spaced. ये जो सुना है इसको बस relate करो what we can tell about this in geographical terms. You will have high speed wind when isobars are closely packed. Isobars close. और क्या देखा है? रेनफॉल क्लाउड्स हो गया. चलो we'll see what happens during a cyclone. See, tropical cyclones normally originate over sea. They normally originate over sea, and for this we need relatively higher sea surface temperature. What happens actually in a tropical cyclone, we'll understand that. That this is a sea surface that is there. We are in the tropical region, insolation will be relatively higher. A cyclone is formed by some kind of pre-existing low pressure region that is there. Low pressure region will lead to upliftment of wind that is there. होगा क्या? ये low pressure भी कैसे बना है? You have high insolation that is coming. If high insolation is there, can I say temperature will increase? As the temperature increases, air here becomes lighter. As it becomes lighter, it keeps on rising. But along with it, can I say moisture will also rise? अब ये moisture बना कैसे? It evaporated. How will it evaporate? Because of solar insolation, it will gain energy. So you have water, it has gained some energy and it has become vapor. So this is liquid water, it has gained some energy and it has become vapor. This transition from water to becoming a vapor, let's say temperature is same, temperature nahi badha hai, it is just that it has been converted to vapor. This is where we say that it has gained some kind of latent heat. There are two kinds of heat that is there. One is latent, other is sensible heat. Latent heat is, let's say मैंने यहाँ पे पानी गिरा दिया अभी, that water will be converted into vapors. उस पानी का टेम्परेचर पहले मैं 100 डिग्री नहीं ले गया. I didn't boil that water. It eventually converted into vapors because it has gained the energy required for conversion from one state to another state. It has gained that energy. There is no temperature change is involved when it is just a change of state here. So it has changed at that particular temperature itself. It is latent, we cannot feel it. But when we talk about sensible heat is you can sense it. It will have temperature change involved there. So let's say you have something at 5 degree, now you have given some heat to it, its temperature increased to 10 degree. There is some kind of temperature change involved which can be sensed. But let's say there was water, you gave equal amount of heat, that water converted to vapor, you cannot sense it. It has changed its state there, it has not raised its temperature. So what happens here is, this water which was lying on the sea is converted to vapor and it starts rising. Now this conversion uses some energy from insolation, and that we call as, it has absorbed latent heat. This water has absorbed latent heat. Now what happens, as it rises, this air parcel will, जैसे ऊपर जाएगा ठंडा होगा, it starts cooling down. As this air parcel starts cooling down, what will happen for this water vapor that was there? this water vapor will lose latent heat. This water vapor which was cooling down will lose latent heat. But where will this latent heat go? हाँ, तो this latent heat will be absorbed by the surrounding air only. अब यहाँ से जितना भी इसने latent heat lose करा है, it will be absorbed by surrounding air that is surrounding this water parcel. तो वहां पर वापस से उनको heat मिल गई. That air parcel will again rise. As that air parcel rises, again some water droplets will condense, and that condensed droplet will keep on losing heat. So this keeps on going and going for very high length. अब जब ये continuously होता जाता है तो we keep on getting very high clouds that are being formed. These high clouds are called cumulonimbus clouds. This happens because there is continuous updraft of water that is happening here. Continuous water section यहाँ से हो रहा है in this particular cyclonic system, and this continuous water section is absorbing all the latent heat, and then as it moves up it releases all the latent heat. This released latent heat is absorbed by the surroundings, and this this absorbed latent heat again moves all the surrounding air upward. हो रहा है, यहाँ से हीट अब्जॉर्ब करी, ऊपर गया, रिलीज करी, जिसने अब्जॉर्ब करा वो और ऊपर चली गया, जिसने अब्जॉर्ब करा वो और ऊपर चली गया. तो दिस कीप्स ऑन ग्रोइंग एंड दिस लीड्स टू द फॉर्मेशन ऑफ ह्यूज क्यूमुलोनिम्बस क्लाउड्स एसोसिएटेड विद साइक्लोन. और ये बहुत बड़ा स्ट्रक्चर बन जाता है. So basic requirement here for cyclone system to form is this continuation of latent heat. इसीलिए as soon as this cyclone makes a landfall, this supply breaks. As this supply breaks, this structure breaks. इसीलिए as soon as we see a landfall, cyclone is gone. Tropical cyclone की बात कर रहा है, because ये latent heat का supply रुक गया. Till the time it is continuously being supplied, this keeps on growing and this keeps on sustaining itself. So very important thing, I don't know आपने कभी latent heat का पढ़ा है या नहीं cyclone में, but this is a very important thing that needs to be there. So what are the favorable conditions for development of cyclone? We'll see that you need a high sea surface temperature. By high I mean it needs to be over around 26 to 27 degrees. We need a continuous supply of latent heat and moisture. Next, cyclone is a low pressure area. For this, it is not formed over the equator because Coriolis force is absent there. For cyclonic vortex to form, एक vortex of air होता है. This air goes spiraling like this. For this vortex of air to form, you need Coriolis force. So for cyclonic vortex to form, you need presence of Coriolis force. That is why cyclone is not formed at the equators. Cyclone is formed थोड़ा ऊपर या नीचे on the equators. Now as we go higher up in the atmosphere, this structure will go to very long heights in the atmosphere. As we go above, tell me what happens to wind speeds. They ऊपर जाओगे तो wind speeds increase. If there is a very high wind speed going here, can I say they will break this vortex? अगर बहुत high wind speed is blowing in the upper atmosphere, they will not let this structure to sustain. ये भी wind से तो है. If very high wind are blowing in the upper atmospheres or in the relatively higher layers, they will not let this structure to form. So for this structure to form, we need only small variations so that this structure can sustain. If there is a very high wind speed या very high wind shear is the difference between wind speeds at the bottom and at the top. If this is very high, this difference is very high, they will not let this vortex to form. So we need देखो होगा तो सही, you cannot have zero wind shear. There will be some wind shear in the atmosphere. We need that wind shear should be small. If that is very high, it will not let this structure to sustain. So for this particular structure, we need small variations only. There should not be large variations. A pre-existing low pressure area, it just act as the seed for development of cyclone. Cyclone is ultimately low pressure. So if somehow there was already a low pressure, it is easy for the cyclone to be formed around this low pressure area. Upper divergence of above the sea level system. So upper divergence, what happens? Upper divergence, if there is an upper level divergence, इस wind को रास्ता मिल जाता है कहीं और जाने का. So whatever is the wind that is rising, if an upper level divergence is created, it leads to more and more suction of winds from here. So it promotes rising of air. If an upper level divergence is there, it leads to, it promotes more rising of air. So this helps in the bigger development of the cyclone. So for a cyclone, favorable condition or the most important condition is you need higher sea surface temperature, which provides for good supply of latent heat. Second, you need Coriolis force so as to form that cyclonic vortex that is there. Third is there should be smaller variation. If there are larger variations, that structure cannot be intact. So for that structure to be intact, you need only smaller variations. ज़्यादा variation होगा तो ये tilt ही हो जाएगा, ये टूट जाएगा यहाँ से. A pre-existing low pressure area, it acts as a seed for development. If some low pressure is already present, it will act as a seed for development there. And upper level divergence leads to more and more suction of air from below. Is this conditions clear? What is this creates instability? What does instability mean? Rising of air. This is what is instability. Rising of air column. So upper level divergence leads to rising of air column. Rising of air column is what is instability, unstable conditions. Done. Now structure of a cyclone की बात करें तो you will have an eye here that is formed. This is the eye of the cyclone that we have. This eye, so amongst this cyclone we will have a area of relatively calmer zones that is being formed. What happens is cyclone is a low pressure area. As the wind starts converging, as the winds converge in the northern hemisphere, I am saying all of the winds will deflect towards the right. All the winds that are converging will deflect towards the right. As they deflect towards the right, there comes an imaginary wall that we see कि सारी wind इसके along घूमने लग जाती है. So a vortex is formed around this imaginary wall that is there. This wall is what we call as eye wall, and this particular area is what we call as eye of the cyclone. So all of this wind start revolving around this particular eye wall, eye, and they revolve like this. They revolve in anti-clockwise direction. इसका ध्यान रखना है. In northern hemisphere, winds that are revolving around a cyclone will be in anti-clockwise direction. In southern, it will be reversed. Cyclone as a whole will This cyclone as a whole will move under the influence of winds that are there. If it is trade winds, it will move along the trade winds. If somehow, we'll discuss later on, extratropical, they will move along the westerlies. So cyclone as a system will move under the influence of prevailing winds. But the winds under this will move like this. Winds inside the cyclone. This complete cyclone will move along with the trade winds only. So if let's say you have equator here and tropics here, cyclone formed here will move under the influence of winds. It will move from east to west direction. इसीलिए we see maximum cyclones being coming from this side towards the Bay of Bengal, because tropics में है ना, we'll experience it moving from east to west side. इसीलिए maximum cyclones coming on this side. यहाँ पर जो साइक्लोन बनेगा, इन द साइक्लोन्स फॉर्म्ड इन अरेबियन सी विल बी डिफ्लेक्टेड टुवर्ड्स ओमान कोस्ट या पाकिस्तान कोस्ट एंड ऑल, they will be deflected this side. These cyclones will be deflected towards India. This doesn't mean कि इधर नहीं आ सकता है, mainly it will be deflected. Done. So eye is formed and this eye is a center, ये दिख रहा है यहाँ पर. Relatively calmer conditions prevail and what we have seen is an descending air parcel is also seen here. So a descending air parcel is also seen in this eye. It is the warmest part of the cyclone. So सबसे ज़्यादा temperature is within the eye, but this eye is having clear sky. So let's say a cyclone is passing from this area. When this particular region is passing, we'll experience storms and winds and huge rains. But suddenly when eye comes, it will be calmer conditions all of a sudden. There will not be any rain, there will not be any wind for a few minutes till the time the other part of the cyclone comes in. Now properties of the tropical cyclone, इसको हम बाद में compare करेंगे with temperate cyclones as well. It moves swiftly, ऐसा नहीं है बहुत तेजी से डेवलप होके बन जाएगा. It develops also. This development जो अभी हमने पढ़ा है, this development takes 7 to 10 days. The longer it is taking to develop, the bigger cyclone it can become. So it takes time to develop. It is fueled by moisture, so as soon as it is cut off, as soon as it moves on land, it weakens because moisture supply is cut off. If moisture is cut off, latent heat supply is cut off. It is more, it forms only over water bodies because it is fueled by the latent heat. More devastating than temperate cyclones because winds move at a higher speeds here. Done. नहीं, ज़्यादा एरिया को इफेक्ट करता है. टेम्परेट साइक्लोन्स इज फॉर्म्ड ओवर अ वेरी हाई एरिया. They are not that destructive compared to this. In cyclones, you might hear this term closed isobars. We'll see that as well, closed isobars. So let's say you have a low pressure area, low pressure है let's say 900. Up near this low pressure area, somewhere here you will have let's say an area of 950, an area of 950. Here also somewhere an area of 950 will be there, from where winds will be attracted towards this cyclone. Same way beyond this you might have an area of 1000 because high pressure से wind आ रही है towards low pressure. If we join all of these points of similar pressure, this is how you get a closed isobar that is being formed, joining areas of all the same pressure points, joining areas of all the similar same pressure. This is let's say 1000. So winds will be attracted from this towards the low pressure area, and more closely these isotherms are placed, greater will be the wind speeds. There are two things. One is closed isobar, second is close packing of isobars. You need to be clear with this. Closed isobars is this. Close packing is how closely they are packed. Let's say 950 और 1000 यहाँ था या 950 और 1000 यहाँ है, कितना पास पास है, that is close packing of isobar. More is the close packing of isobar, you will have higher wind speed. This closed isobars lead to formation of cyclone type of structures. Wind from all the directions are converging to a point. ठीक है, ये दोनों चीज का ध्यान रखना, closed packing and closed isobars. Tropical cyclones, where do you find them? Normally in the tropics. अलग अलग नाम होते हैं. What is the name given here? Huh? Here what is the name? Willy Willy. ऑस्ट्रेलिया में it is विली विलीज. Here typhoon, hurricanes, USA. So here you will have hurricanes, here you will have typhoons, here you will have willy willies. Normally you will see that this region is under the influence of trade winds. Trade winds blow from east to west. So all of these cyclones normally will move from east towards the west direction. When we go to temperate regions, temperate region is under the influence of westerlies. There we will see all the temperate cyclones moving in westerly direction only. During retreating monsoon as well, यहाँ पर let's say ITCZ is still here, we will see cyclones coming from way below from the equator towards the upper regions here in this. But जब फोटो नहीं डाली शायद, you will have retreating phase as well, जहाँ पर ITCZ came here. There also we might see some development of low pressure conditions here, which along with northeastern winds, they might strike this coast. I forgot to put that image, but because this ITCZ has shifted here, इसीलिए we see cyclones in October, November. Because this ITCZ has shifted here, and we might see some low pressure being developed here in this region, and winds are blowing like this. So this low pressure region can also cause some kind of cyclonic disturbances here in this region. Between Arabian Sea and Bay of Bengal, where do we experience more cyclones? Bay of Bengal. Almost 75% we see in Bay of Bengal. Bay of Bengal में क्यों? It is relatively warmer, so favorable conditions for cyclone formation. You will have more sea surface temperature, favorable conditions for cyclone. Wind shear. Now understand, wind shear will be less in Arabian Sea or in Bay of Bengal. Arabian Sea will experience your southwest monsoonal winds that are coming. So because of those monsoonal winds, shear will be relatively more. If relatively more shear is there, it will not let cyclones to develop. Cyclones will develop relatively easily when shear is low. So with relatively low shear, cyclone will develop better in Bay of Bengal regions. Moisture availability, ये सब almost है same. But देख लेते हैं moisture availability. Here in this particular Arabian Sea region, near to Arabian Sea, you have desert conditions there. Near to Arabian Sea, you have Arabian desert, you have various deserts in those areas. Now that area will not lead to more moisture in that wind parcel that is there. So that dry air that is coming from there, it hampers cyclone growth. हमने देखा था dry air mass जब हम when we were discussing deserts formed in the hot latitude region. One of the reason was dry continental air mass in desert region. This dry continental air mass also hampers formation of your cyclones in and around the Arabian Sea region. This such conditions is not here. In fact, what we have near Bay of Bengal is your rainforest that is there. In rainforest, you have high evapotranspiration, high moisture availability is there near to this equatorial regions where we have rainforest. बे ऑफ बंगाल के पास में क्या है, इंडोनेशिया, मलेशिया, ये सब है ना. हाई इवापोट्रांसपिरेशन बिकॉज ऑफ फॉरेस्ट इन दैट एरिया. इसके पास में क्या है, यू हैव डेजर्ट. डेजर्ट इज रिलेटिवली ड्रायर कंडीशन, ड्रायर एयर इज देयर, सो इट इज सप्रेसिंग your cyclone development, it is fueling your cyclone development. This is also leading to more frequent cyclones in Bay of Bengal. ये सब पॉइंट्स अलग अलग आ सकते हैं कि these days why we are experiencing more cyclones in this region, या why cyclones in Bay of Bengal is relatively more compared to Arabian Sea. and they can give you some separate pointers regarding this. They all can play a role in frequent cyclones in Bay of Bengal. Fujiwara effect, sometimes it is in news. Now what happens in this effect is, just see, it happens when you have two cyclones at play together. So there are two cyclonic conditions there. Just see the interaction, what is happening here. Either these two cyclones can, they can simply rotate. First thing is, they will start rotating about a common center. They can simply rotate. Second thing is, they can rotate and merge at a common point. So they will come and they will merge at a common point. And third type of interaction is, they will just pass. So they will not have at all interaction with each other, they will just pass. So whenever we have two cyclones at play, these two cyclones can either merge together, or they can orbit around a common point, or they can repulse. Repulse is, they will just fall apart there. So these three things can happen. And lately अलग अलग cyclones देखे हैं which starts having Fujiwara interactions. So you just need to remember this term, that this term is related to cyclones. जैसे उन्होंने मियावाकी पूछ लिया था कि मियावाकी is related to. So just remember this term, that Fujiwara interaction is related to cyclones. बस इतना याद रखना है. Exact mechanism they won't be asking in prelims, but this particular interaction is related to cyclones. There are various conditions when they will interact, when they will merge and all. We need not go into that detail कि कब होगा, 1000 के किलोमीटर से कम है, ज़्यादा है. Just remember that this particular term Fujiwara interaction is related to cyclone development. Done? Now one last thing in cyclone, that is temperate cyclones. Before understanding that, we'll also cover air masses. Now air mass is an extensive body of air with two conditions: relatively uniform moisture and uniform temperature. लिख रहे हो कुछ? So we have an extensive body of air with relative consistency of temperature and moisture conditions. एक बहुत बड़ा air mass है जिसमें temperature and moisture almost constant है. Now it can be this big कि यहाँ पूरा एक common air mass बना हुआ है. The temperature and moisture condition here are same. यहाँ एक बहुत बड़ा common air mass बड़ा है. So temperature and moisture conditions can be same here in overall this air mass that is being formed. अब there can be various kinds of air masses depending on their location. We give them different nomenclature. वैसे इसका nomenclature याद करने की जरूरत नहीं है, but एक बार बस समझ लेते हैं होता क्या है. So when we write M, it is for any air mass that is formed in maritime region. When we write C, small c, it is for continental. So either maritime, that means formed over water, continental formed over land. Now understand, either it will be formed in the tropical areas, so it will be written as maritime tropical. So it is a maritime air mass formed in the tropical waters, maritime tropical. Now this particular air mass will have what qualities? इससे समझो what will happen. It is in tropics. Will it be cold or warm? It will be relatively warm. It is maritime. So will it have more moisture or less moisture? More moisture. So it will be having high moisture. Yeah, relatively wetter air mass is there and relatively warmer. Same way, if let's say CP is written, P is for polar. So polar area, that means cold. Continental, continental, that means dry. So dry and cold air mass. So depending on their location, we can directly guess the property of that particular air mass. Either it will be dry or it will be cold, depending on dry है या wet है, depending on whether it is on continent or whether it is on water. Whether it is located in tropical areas or in the higher latitudes. Tropical areas will be relatively warmer, higher latitudes will be relatively cooler air mass, that is. Now this air masses are not stationary, they continuously keep on moving. So all of these air masses are not stationary, they continuously keep on moving. As they keep on moving, they keep on interacting with each other. अब interactions होगा तब क्या होगा? Let's say you have this maritime tropical air mass interacting with this maritime polar air mass. Just example के लिए, this both are containing moisture, both of them are containing moisture. It is at a relatively lower, it is tropical, so it will be relatively warmer, this is relatively cooler. So this will be warm, this will be cold. As warmer air is interacting with colder air, what will happen? A front will be formed. Normally see fronts कहाँ बनेंगे? यहाँ पर you will have everything warm, यहाँ पर you will have everything cold. So normally you will see formation of front in this latitude only. जो हमने देखा था temperate latitudes में, this is where you will have fronts being formed, because above this you will have cooler air mass, below this you will have warmer air mass. So if a warmer air mass is interacting with a cooler air mass, this air mass will lift. As this air mass lift, we will get a front being formed here, and it will have different kinds of conditions. Let's say rain and all, clouds and all will be formed in this particular area. Basic thing is, as this starts interacting with each other, as this air mass starts interacting, we start getting various fronts being formed. Ab, depending on what all air masses are interacting, we start seeing formation of temperate cyclones as well. पहले देखते हैं fronts कैसे बनते हैं. There are 4 different types of fronts that are there. You might get a match the column based on this कि इस टाइम पे क्या हो रहा है, whether warm is lifted, cold is lifted, क्या हो रहा है. यहाँ जो लिखा है ये आप बाद में पढ़ना. Basic thing यहाँ पे समझ लो, what happens when a front is being formed. Let's say you have a colder air mass here, you have a warmer air mass here. It is moving like this, it is moving like this. They are interacting at this boundary. Will anything happen here? There will one thing happen, that you might experience rain just in this region. It is a stationary front because they are moving in opposite directions. अलग अलग बस जा रहे हैं. They are not directly interacting. So you might get a stationary front. Stationary front में it is on the edge that you might get some rainfall. Let's say this is warm front, this is cold front that is there, or let's say cold front is like this, warm front is like this, but this warm front is moving faster. This warm front is moving faster, this warm air mass is moving faster than the cold air mass. It will start rising above this particular cooler air mass or colder air mass. So we start seeing clouds being formed, and this clouds will be at a very extensive strength. एक्सटेंसिव इतना हो सकता है कि ये यहाँ से यहाँ तक हो सकता है 50-100 किलोमीटर के क्लाउड्स बन गए. This will be that extensive. So wherever such fronts are being formed, you might experience rainfall over a very high area. Very large area में you might experience rainfall when such warm fronts are formed. In cold fronts, what might happen is you have a warm air mass going like this, and from here you have a cold air mass coming, and now cold air mass is moving faster. Cold air mass is moving faster than warm air mass. Suddenly what will happen is, आप धीरे धीरे चाह रहे हो, पीछे से गाड़ी ने जोर से आके ठोका, क्या होगा? उछल जाओगे. So this warm air mass will suddenly, sorry, उछल गया. This warm air mass will suddenly rise. So you will see development of a huge cloud, but this will be very extensive in height, but not that in length. So when you have colder front being formed, you will see a very high clouds close to cumulonimbus clouds being formed. CN cumulonimbus है, ठीक है. So we will see very high clouds. Rainfall will be very localized. Here rainfall will be over an extensive area. Here rainfall is very localized. इट इज नॉट ओवर एन वेरी एक्सटेंसिव एरिया. ये बस जहां जहां बना है वहीं होगी. यहाँ पर ये 50-100 किलोमीटर तक बना है. तो इट विल बी वेरी एक्सटेंसिव रेनफॉल. नाउ देयर इज वन लास्ट फ्रंट दैट कैन बी फॉर्म्ड इज ऑक्लूडेड फ्रंट. उसको भी समझते हैं. दिस वाज कोल्ड एयर मास, this was warm air mass, let's say this was cooler air mass. What we'll experience here is a formation of warm front. This is moving this side, this is moving this side, this is also moving this side. All three air masses are moving. We will start seeing formation of a warm front here, prolonged rainfall over a very extensive area. Here we'll start seeing formation of a cold front, rainfall over this localized area, but rainfall will be very heavy. But let's say this colder front is moving at a faster pace compared to this warmer front. There may come a situation when you will have this colder front and this cooler front, and warmer front is completely uplifted. ये इतना तेज चल रही है गाड़ी कि ये गाड़ी को पूरा उड़ा दिया और इस गाड़ी से भी टकरा गई. इमेजिन कर लो बस ऐसी. सो दिस कार या दिस वार्मर air mass is completely uplifted. This now starts interacting with this cooler air mass, and the warmer front is completely uplifted. This particular interaction is what we call as occluded zone front. Occluded front. Here now, यहाँ पर temperature contrast was much higher. Temperature contrast was much higher, but comparatively temperature contrast is relatively weaker here, because this was also relatively cold, this was also relatively cold. So this leads to, जब ये हम cyclones में पढ़ेंगे तो this leads to dissipation of the cyclone. This would be the last stage of cyclone that we will see. But यहाँ पर this is how this front starts interacting. We get 4 different kinds of fronts being formed. First being stationary front, where they are directly just passing by each other, they are not directly colliding and interacting with each other. So a stationary front is formed. Second was warm front, where warm air was moving faster than the colder air. Warm air is uplifted, prolonged clouds are formed over an extensive area. Third was cold front. Cold front was moving faster than the warm front. Warm air mass is suddenly uplifted because of the cold front. This sudden upliftment causes development of huge clouds and very localized but heavy rains. And then because of certain interactions, it may happen that this warm front is completely uplifted. When this warm front is completely uplifted, we call this as occluded front. यह है occluded front that is being formed here. Can I say this is kind of a temperature inversion? So it is a temperature inversion also that is occurring here. इसके बाद काम हो जाएगी. Once occluded front is there ना, अब conditions will be calmer. अभी यहाँ जब तक warm air uplift होकर clouds बनाए हैं वो तो rain होगी, उसके बाद it will become calm. Because warm air तो uplift हुई है ना. So as it is uplifted, we will see some rains in this area. क्योंकि upliftment is there. If upliftment is there, we will see rain in this area. But once it has rained, now the conditions will become calmer. तो जो बताया है वही सारा कुछ यहाँ लिखा है. So this is cold front, this is warm front, slow upliftment, sudden upliftment, all of this is written जो हमने डिस्कस किया है. This is how clouds are being formed. Cumulonimbus, nimbostratus, cirrus clouds. बहुत ऊपर तक जो चले गए, you might get cirrus clouds as well. Now temperate cyclones. Temperate cyclones will have again these three things at play. First is kind of a stationary front is being formed. Next, you have this winds starting to have some kind of wavy like pattern. They start interacting with each other, and because of this interaction, motion between different fronts starts. अब यहाँ पर we start getting the development of a warmer front. Imagine this is the cooler air mass, this is the colder air mass that is coming from behind. ये जो photo थी, this is the warmer front that is being formed, this is the colder front that was there, cold front. अब this completely starts moving, तो यहाँ फिर ऐसी चोच बन जाती है, कुछ इस टाइप का डायग्राम बनेगा. It completely starts spiraling and it spirals over a huge area. छोटा मोटा एरिया नहीं है, this is in thousands of kilometers, can be in thousands of kilometers. Now as it starts interacting with each other, there may come a place when this cold front starts completely uplifting this warm front. तो यहाँ पर we start seeing complete upliftment या occlusion stage starts in this particular region. यही occlusion जो हमने यहाँ देखा था, it is completely uplifted. This is starting here. So once it is being done, slowly वापस से ये condition prevail कर जाएगी. With a new setup, we will have this particular condition prevailing. This is where you will have dissipation of temperate cyclones. Temperate cyclones बनेंगे fronts के कारण. Fronts start interacting with each other. As they start interacting with each other, we start seeing more and more upliftment of air. We start seeing this circular pattern being formed because of movement. ये चलते जाएगा. Slowly this will only lead to its occlusion. So there will come a stage where we start seeing formation of occluded front. That is the last stage जहाँ occluded front मिलेगा. ये statement as it is आ सकता है कि temperate cyclone starts with the formation of occluded front, ऐसे करके एक दे दिया. Second, temperate cyclones dissipates with the frontolysis, with the frontogenesis. ऐसे कुछ कुछ terms they might give you. What is genesis? Origin. So if I am saying frontogenesis, origin of fronts, so cyclone, can I say, will start with frontogenesis only? Huh? What is lysis? End. So this cyclone will end with frontolysis when this occluded front is being formed. So they might give you something in technical terms as well. आपको बस इससे रिलेट करना है. What is frontogenesis? What is frontolysis? Lysis is something is ending. ठीक है. Just see over how large area they have drawn this, because actually temperate cyclones occur over a very large area. बहुत छोटे area में नहीं है. It occurs over thousands of kilometers. And wind speeds are not that high. Wind speeds are relatively less only. This is your occluded front stage. That is the last stage. Frontolysis बोलते हैं. Frontolysis has happened. That means no great temperature difference between these two. This is what is called frontolysis. Now your fronts are ending. Now your cyclone is ending. Frontolysis. लिखना है लिख सकते हो. अपनी लैंग्वेज में लिखना है अपनी लैंग्वेज में लिख लो. Then we'll move ahead. हाँ. अरे I'll share this PPT. Don't worry. पूरा PPT as it is I'll share. Now path of temperate cyclones. Temperate cyclones will be under the influence of westerlies. So they will be under the influence of westerlies. They'll move from west to east. This complete region in this, they'll move from west to east like this. Westerlies के influence में. This was tropical cyclones under the influence of easterlies. दिस इज टेम्परेट साइक्लोन्स, ऊपर नीचे दोनों जगह होंगे, ठीक है। ना कंपैरिजन बिटवीन ट्रॉपिकल एंड टेम्परेट साइक्लोन्स, एक बार अपनी टेबल में खुद से लिखते जाओ इसको। वेयर डू दे अकर? ट्रॉपिकल, in the tropical regions only, and that too in and around 8 to 20 degree latitudes. This occur in the relatively extratropical regions 30 to 40 degree latitude. Origin, this is thermally induced. Again, they might give this term with cyclones as well, thermally induced. This is dynamically induced because of frontal interactions. साथ साथ लिखते जाओ, thermally induced and dynamically induced because of frontal interaction. Area impacted, this is relatively lesser area that is impacted, and this is formed over a very large area. ये कौन सा area impact करेंगे? They will impact only the coastal regions on which they are making a landfall. So only coastal area is impacted, but they will impact the mainland. They are formed over land as well. Temperate cyclones. Direction of motion, one is east to west, other is west to east. लिखो बाकी पॉइंट्स भी। सेल्फ एक्सप्लेनेटरी है बाकी पॉइंट्स। नहीं, वेस्टवर्ड मूवमेंट करने की टेंडेंसी रखते हैं, बट लेट से दे ओरिजिनेटेड इन सच अ मैनर दैट कि उतना ज़्यादा कोरियोलिस इम्पैक्ट नहीं पड़ पाया, वो इंडिया तक आ गए। इसीलिए वी एक्सपीरियंस मोस्टली अरेबियन सी साइक्लोन्स, वी एक्सपीरियंस इन गुजरात कोस्ट। यहाँ से साइक्लोन आ रहा है, इट विल स्टार्ट रिकर्विंग, ईदर इट विल गो टुवर्ड्स ओमान कोस्ट, और इट माइट हैपन दैट इट विल स्ट्राइक दिस कोस्ट एज वेल। तो वो यहाँ पर भी स्ट्राइक कर जाता है, डिपेंडिंग ऑन किस लोकेशन पे वो बना है। डन, लिखो लिखो जल्दी। अंडरस्टैंड व्हाट इज द नॉर्मल प्रेशर कंडीशन दैट यू हैव। नॉर्मल, हमारा जो नॉर्मल प्रेशर रहता है, अगर अभी आप यहाँ का प्रेशर भी मेजर करोगे, इट विल बी समवेयर अराउंड 1000 मिलीबार्स। दिस इज द नॉर्मल प्रेशर कंडीशन दैट वी हैव। अब these two cyclones are low pressure areas. Low pressure means they have relatively lesser pressure than the normal condition. Normal condition is 1000. It is having relatively lesser pressure than this, but pressure difference is not that great. In tropical cyclones, pressure difference is very high compared to normal conditions. So we are supposed to see this difference. In tropical, it is more. This difference matters here कि कितना drop हुआ है, from high to low कितना drop है। यहाँ पे there is a very high drop, इसीलिए we experience very high wind speed. यहाँ पे drop in pressure is not that much, इसीलिए wind speed is also relatively lesser. Normal pressures somewhere around 1000 millibar. This is just the pressure condition in that. What matters is drop in this pressure. कितना drop हुआ है? From 1000 to 880 it is almost 120 का drop, and this is just 20 का drop. Sorry, tropical rain मिलाएगी. Temperate cyclones. See, it all depends on कि कौन सा front का कैसे interaction हो रहा है. Normally your tropical cyclones will bring rain here in this part, but they may not bring rain in the extended part. They may not bring rain here in this part. Somehow conditions can prevail कि यहाँ यहाँ हर जगह rain आ गई. अब यहाँ पर इस एरिया में भी साइक्लोन तो जा रहा है, बट यहाँ कोई रेन नहीं हो रही. तो डिपेंड ऑन कि विच एरिया इज अंडर इंटरेक्शन, यू कैन गेट रेन, यू मे नॉट गेट रेन. एंड इमेजिन ये इंटरेक्शन जो है ये तो एक बाउंड्री है, बट ये पूरा एरिया तो थाउजेंड्स ऑफ किलोमीटर है. तो एक साथ 1000 किलोमीटर के एरिया पे बारिश नहीं हो रही होगी. इट विल बी वेरी लोकलाइज्ड रेन. ये एक्सटेंसिव रेनफॉल हो सकती है 100 200 400 किलोमीटर तक. दिस विल बी वेरी लोकलाइज्ड. डन. बस ये टर्म्स याद रख लो, इनसे बहुत ज़्यादा क्वेश्चंस नहीं पूछे गए हैं कभी. जियोस्ट्रॉफिक विंड्स, व्हाट आर दिस विंड्स? हाँ, these are winds in the upper atmosphere, first thing. So they lie in the upper atmosphere. Secondly, normally what do we say, that winds blow from higher pressure to lower pressure regions. तो हाई प्रेशर से लो प्रेशर की तरफ जाती है winds. But when winds blow at a very high speed, they also get interacted with because of Coriolis force, and this Coriolis force tend to deflect the wind that is blowing. तो ये जो wind की direction है, the Coriolis force tend to deflect the particular direction of the wind that is blowing, and they might deflect it to that instance कि ये लगभग इसके perpendicular हो जाए जो initial direction थी. So initial direction is, let's say you have higher pressure and lower pressure here, so pressure gradient force will be like this. This is your pressure gradient force that is there. Now somehow Coriolis starts impacting, and it will just turn the direction of this particular wind to almost 90 degree. If let's say this is in northern hemisphere, it will try to rotate it, yeah, it will deflect it towards right. It deflects it to that extent that it becomes almost perpendicular to its original direction, and Coriolis force now gets balanced by this pressure gradient force. This is your Coriolis force. So in the upper atmospheres only, when there is very less or almost no friction, we get a condition that pressure gradient force and Coriolis force balance each other, and because of this balancing we start seeing wind flowing parallelly to the isobars. So they flow parallel to the isobars. Normally ये होना चाहिए कि they are flowing towards the direction of pressure gradient force जो हम we experience on the land, that from higher pressure to lower pressure, from high to low, this will be your pressure gradient. Normally winds are supposed to blow like this, but because of very high speeds in the upper troposphere or upper atmosphere, because of this Coriolis interaction, we start seeing that instead of winds blowing like this, they start blowing almost perpendicular to this pressure gradient force, because this PGF is eventually balanced by the Coriolis force. So when this balancing happens, this blows parallel to the isobars that are there. This particular wind that blows parallel to the isobars is called as geostrophic winds. This is what is your geostrophic wind that is there. And jet stream is a type of geostrophic winds. Jet stream में देखा था that in the upper troposphere it was supposed to go like this, but it became almost perpendicular to its initial direction. It was supposed to go from equator towards poles, it was supposed to go like this, but it became almost parallel and it started blowing like this in this direction.
तो आपका प्रेशर ग्रेडियंट फोर्स ये था, बट विंड ऐसे ब्लो करने लग गई. प्रेशर ग्रेडियंट फोर्स ये था, विंड उसके परपेंडिकुलर ब्लो करने लग गई. इट इज परपेंडिकुलर टू प्रेशर ग्रेडियंट फोर्स, इट इज पैरेलल टू आइसोबार्स. यहाँ पर भी आइसोबार्स के पैरेलल फ्लो करने लग गई. This is a jet stream that is there. Jet stream is an example of your geostrophic winds only. These are upper level winds. This is not happening on the ground layer. Ground layer में you will have friction also involved. यहाँ जैसे ground पे देखोगे तो you will also have a component of friction. This friction will not let this balancing happen. अगर ये balancing नहीं होगी तो you will not have this geostrophic winds. But this balancing can happen in the upper atmospheres. So your PGF and your Coriolis are balanced, and this winds blow perpendicular to your pressure gradient force or parallel to your isobars. इतना ध्यान रख लो, it is not in the lower atmosphere. Exact mechanism they are not going to ask exact mechanism in prelims, but you just need to know that upper level atmospheric wind से direction of flowing is parallel to isobars, or you can say perpendicular to pressure gradient force. दोनों चीज. Jet stream is a type of geostrophic winds. So jet stream is a type of geostrophic winds. And because they do not have any more force on them, because whatever force was there, pressure gradient was balanced by this. अब कोई force नहीं लग रहा. So they will keep blowing at almost uniform speed and direction. ना तो कोई direction change कर रहा है, ना कोई speed change कर रहा है. So almost uniformly throughout, yeah, they will keep encircling the earth as jet stream does. So they will keep on doing this at a uniform speed and direction. इसीलिए पूरी जेट स्ट्रीम जो है अर्थ को एनसर्कल करती है यहाँ से यहाँ तक पूरा. इज दिस क्लियर? कहाँ? किसने बोला? हाँ, मैं पीछे देख रहा हूँ कि आवाज कहाँ से आई थी. मॉनसून पे ये जेट स्ट्रीम ही है, ऐसा समझ लो. जियोस्ट्रॉफिक विंड्स का एक टाइप है जेट स्ट्रीम. तो जो जेट स्ट्रीम का इम्पैक्ट है वही है सारा मॉनसून पे. जेट स्ट्रीम वी हैव ऑलरेडी सीन व्हाट आर जेट स्ट्रीम्स, कैसे वो फ्लो कर रही है एंड ऑल. फॉर अस मोस्ट इंपॉर्टेंट इज दिस ट्रॉपिकल सब ट्रॉपिकल जेट स्ट्रीम दैट इज ब्लोइंग हियर क्रिएटिंग हाई प्रेशर. दिस ऑल वी हैव सीन. अब somehow because of difference in heating conditions your jet streams are weakened. अगर अब वीक कैसे होगी जेट स्ट्रीम्स? व्हाट वी नीड इज प्रेशर ग्रेडियंट फोर्स एंड कोरियोलिस फोर्स बीइंग बैलेंस. इसको बस सुन लो कि क्या हो रहा है यहाँ पर. प्रेशर ग्रेडियंट एंड कोरियोलिस फोर्स आर बीइंग बैलेंस्ड. समहाउ इफ दिस पीजीएफ इज ऑल्टर्ड, इसको अगर मैं ऑल्टर कर दूं, ये ऑल्टर कैसे होगा? हाँ, this depends on pressure difference. Pressure difference depends on temperature difference. If somehow temperature difference is changed, वो कैसे होगा? Global warming से. So because of continuous heating या global warming, if somehow temperature is changed या temperature difference is changed, your pressure will be changed. In a way, your pressure gradient force will be changed. So somehow if this is changed, your jet streams start waving, the jet streams start weakening. And because of this weakening of jet streams, we start seeing various impacts on the global climate. One of the impact being on the polar vortex. So someone was asking earlier polar vortex. किसी ने पूछा था पीछे से. बहुत बढ़िया. तो polar vortex. अब polar vortex क्या है? Again, it is not in the lower atmosphere. Everything is happen in the upper atmosphere. अब in polar regions, if I am talking about pole, this area is low or high pressure. It is a high pressure area. Above this high pressure area, you will have another area that will be low pressure. So this polar vortex lies in the upper layers. तो अगर ये high है तो ये होगा एक low pressure vortex that is being created. What this jet stream does is, you have a polar jet stream that is there. What this jet stream does is, it do not let this particular winds that are coming out from this polar areas. यहाँ से polar easterlies आती है. So this jet stream contains all these winds within the polar region itself. But if somehow this jet stream starts weakening, they will start waving. As this jet stream, which was almost straight here, if they start meandering, if they start waving, your colder winds start coming to the southward direction. तो ये जितना meander करेगी, जितना weaken होगी, you will see this polar vortex weakening. If this is weakening, you will see this colder winds coming to the far south area. This is happening. So if the polar vortex is stable, if it is good, it leads to containment of this colder winds in this particular region itself. But if this is weakening, it will lead to flowing down of colder winds towards the upper layers of your North America, और नीचे तक भी आ जाता है. It impacts Europe as well. This is what happens when polar vortex is weakening. बस इतना ध्यान रख लो, स्टेबल रहेगा तो इट विल बी कंटेंड देयर. व्हेन इट इज वीकन, वीकन होगा बिकॉज ऑफ jet stream weakening. Jet stream will weaken because of pressure difference. Pressure difference will be because of temperature difference. ये कुछ भी वो पॉइंट्स लिख के दे सकते हैं कि बिकॉज ऑफ दिस, बिकॉज ऑफ दैट, बिकॉज ऑफ ऑल ऑफ द थिंग्स आर रिलेटेड. बिकॉज ऑफ एनी ऑफ दिस यू विल सी वीकनिंग ऑफ पोलर वॉर्टेक्स एंड फ्लोइंग डाउन ऑफ दिस विंड्स फार साउथ. अरे इफ इवन इफ इट शिफ्ट्स, इफ इट इज शिफ्टिंग, ये जो है ये तो स्ट्रॉन्ग है ना, इट इज नॉट वेविंग. इट माइट शिफ्ट थोड़ा सा ऊपर या थोड़ा सा नीचे, बट इट इज नॉट वेविंग. तो इट जस्ट डिपेंड्स ये कितने एरिया तक कंटेंट है. बट यहाँ पर इफ इट स्टार्ट्स वेविंग इन द सेम latitudes, here you will see warmer conditions, but in the same latitude here you will see very cooler conditions. So this impact will not be there if it is just shifting पूरा ऊपर या पूरा नीचे. वन सिमिलर इम्पैक्ट, बस इसका नाम ध्यान रख लो, ओमेगा ब्लॉक इफेक्ट. जस्ट इन केस दे गिव द टर्म recently seen in news, is omega block effect relates to, again it leads to waving of your jet streams. So like I told you, here you will get colder conditions. Similarly, जो ये वाला लिम जा रहा है यहाँ पर you will start getting warmer conditions. जो ये वाला लिम यहाँ गया है यहाँ पर you might start seeing warmer conditions. So warm air moves north, यहाँ लिखा है. So you might see warmer air moving north. It looks like omega. Omega का साइन ऐसे होता है. So that is why it is called as omega block effect. So here even on the same latitude we start seeing these blocks being found where you will have higher pressure condition being prevailing here, and यहाँ पर बहुत ज़्यादा heat होगी. So very high temperatures in this particular region, low temperatures यहाँ पर. तो दोनों पैरेलली चलते हैं, वो एंड ये almost. In Europe we have seen temperatures even rising to around 50 डिग्री. तो यूरोप में 50 डिग्री, इंडिया आते हैं 25 डिग्री में तो हालत खराब हो जाती है फॉरेनर्स की. तो 50 डिग्री इमेजिन. और ये अपर एटमॉस्फेयर का है. Now one is sudden stratospheric warming. One third, the third impact that weakening of polar jet streams have is sudden stratospheric warming. This also leads to very cold conditions. बस इतना लिख लो. It also leads to very cold conditions in North America and Europe. Sudden stratospheric warming, it again leads to weakening of your polar vortex. So it impacts your polar vortex itself. As stratosphere suddenly warms, it weakens the polar vortex that is there. If polar vortex is weakened, again your wind will have this wavy pattern, and this will reach to the upper layers of, let's say, North America or Europe. So it will again lead to very colder conditions. lead to extreme cold spells in mid latitudes. So every now and then we hear this beast from the east, Great Texas Fridge. मतलब इतना था कि नायग्रा फॉल्स ऑल्सो फ्रोज. नायग्रा फॉल्स पता है ना, it also froze down when this thing happened, sudden stratospheric warming. So it leads to sudden cooling of things there because of colder winds coming. And these are all upper atmospheric interactions. लोअर एटमॉस्फेयर पे नहीं हो रहा है, इनका इम्पैक्ट दिख रहा है लोअर एटमॉस्फेयर पे. जब वार्मिंग हो रही है तब ये वीक कर रहा है जेट स्ट्रीम को. चलो लेट्स रिकॉल व्हाट वी हैव स्टडीड. वी आर डन विद क्लाइमेटोलॉजी. हाँ, पीछे करूं. हाँ, what we have studied from after the last recall. क्या? Monsoon we have already done. Only cyclone and then jet stream. There are two different cyclones that we have seen. First, starting with tropical. Give me conditions. Most important one being high sea surface temperature, need high latent heat. Second, Coriolis force. Third, wind shear याद करो. Low vertical या small vertical wind shear. Then wind shear बोल दिया. A pre-existing low pressure area act as seed for development. And upper level divergence, it leads to more suction of air, more rising of air. A rising air column will be there if upper level divergence is there. ये पांचों पॉइंट एज इट इज लिख के दे देंगे. एंड विच ऑफ द फॉलोइंग आर द फेवरेबल कंडीशंस. वो लो विंड शेयर की जगह हाई विंड शेयर कर देगा, आधे लोग वहीं गलत करोगे. बिकॉज आप लोग, अब तो आप समझ रहे हो, बट जब पढ़ते हो ना बस रट लेते हो. हाँ हाई विंड शेयर होगा, हाँ लो विंड शेयर ही नहीं पता क्या है. सो दिस इज हाउ यू नॉर्मली रटोफाई थिंग्स. जो लिखा है उसको रट लिया कि हाई है लो है, समझा नहीं. बट अभी यहाँ पे जस्ट अंडरस्टैंड व्हाट डू यू मीन बाय दैट. लो विंड शेयर, ऊपर और नीचे में विंड डिफरेंस ज्यादा नहीं होना चाहिए. ज्यादा विंड डिफरेंस हुआ तो स्ट्रक्चर विल ब्रेक. तो लो विंड शेयर शुड बी देयर. नेक्स्ट वी मूव टुवर्ड्स कंडीशंस. के बाद हमने उसका फॉर्मेशन देखा था, सारा कुछ वी अंडरस्टूड एवरीथिंग. द डायरेक्शन आल्सो वी हैव सीन. नेक्स्ट, air masses, how they interact, fronts and all we have seen. There are four types of fronts being formed. Name them. Stationary, occluded. किसमें रेनफॉल कैसे होगी, फ्रंट कैसे बनेगा, इमेजिन कर पा रहे हो? पक्का? डन. देन वी विल हैव टेम्परेट साइक्लोन्स बीइंग फॉर्म्ड, जो स्टार्ट करेगा स्टेशनरी फ्रंट से, खत्म होगा ऑक्लूडेड फ्रंट पे. बीच में आपके कोल्ड और वार्म फ्रंट्स भी बनते जाएंगे. फ्रंटोजेनेसिस एंड फ्रंटोलाइसिस, दीज आर टू टर्म्स दैट यू शुड हैव. एक और टर्म पढ़ी थी फूजीवारा. इट वाज रिलेटेड विद ट्रॉपिकल साइक्लोन्स. साइक्लोन्स नहीं, ट्रॉपिकल साइक्लोन्स. देन वी सॉ डिफरेंस बिटवीन बोथ द साइक्लोन्स. याद आ रहा है? देन geostrophic winds, they blow parallel to and perpendicular to PGF, pressure gradient force. ठीक है, in the upper atmosphere या troposphere बोल दो. Next you have jet winds, weakening of jet winds and the impact of weakening of jet winds. ये देखा था. polar vortex, omega block. Done. हाँ, try this one. इज जियोस्ट्रॉफिक विंड्स। चलो पहले ये बताओ, ओशनोग्राफी करना है या क्लाइमेटिक रीजन्स? क्लाइमेटिक रीजन्स, चलो विल डू क्लाइमेटिक रीजन्स, सारा यही कर लेंगे। ओशनोग्राफी एंड क्लाइमेटिक रीजन्स आर स्मॉल स्मॉल, एक एक घंटे में खत्म हो जाएंगे दोनों। हाँ, आवाज नहीं आ रही, कौन बोल रहा है ये बताओ। 5 मिनट, हाँ 5 मिनट यहीं ब्रेक ले लो। पाँच मिनट का ब्रेक है, शांति से बैठना है बैठो, वॉशरूम जाना है, पानी भरना है, घूम के आना है, या नीचे कुछ और करके आना है, आ सकते हो। आई विल स्टार्ट आफ्टर 5 मिनट्स। चलो 10 मिनट्स, 10 मिनट्स ओनली, बट आई विल स्टार्ट विद इन 10 मिनट्स, आई विल स्टार्ट। नहीं, चलो सेटल डाउन फास्ट, विल स्टार्ट. क्यों छेड़ रहे हो उसको? चलो विल स्टार्ट नाउ, वी हैव वेटेड इनफ, नाउ विल स्टार्ट. Yes. Now here we'll be starting with climatic regions of the world. Ab I have included almost everything here. You're not supposed to go after GC Leong book. Normally this part you will find in the part 2 of GC Leong. इसके बाद पढ़ने की जरूरत नहीं. Almost every major thing I have covered within this itself. You can keep jotting down points as I'll go through all the climatic regions one by one. Important points मैं बताते जाऊंगा which all things is important from what all climatic zones. अब all of this earth here for now we have divided them into 11 different climatic zones. अब these climatic zones are divided based on what rainfall condition prevails in that particular area and what temperature conditions prevail in that area. This rainfall and temperature determines which all species will grow in that particular region. Let's say this is equatorial regions. So near to equatorial regions, what kind of biome prevails here? Yeah, what kind of climatic region prevails? It has to be equatorial rainforest. यहाँ पर normally equator passes through your Amazon, Congo, Indonesia, Malaysia. In all these regions you will find equatorial rainforest that is there. Abhi we are just understanding how all of this is located on earth. We'll take all of them one by one in detail later on. As we move above equator in the tropical regions only, right now I am somewhere near to the tropical regions only. जैसे ऊपर जाएंगे, this side becomes your western margin. This side is the eastern margin. Above equatorial regions, if I'm going above this, what normally conditions we have in this particular western margin? एक बार सोच के देखो, इक्वेटर के ऊपर चले गए आप, अफ्रीका है, अफ्रीका में इधर कॉर्नर में क्या क्या मिलेगा? You will experience desert, hot deserts. In the same latitude, if you come this side, you will have grasslands. इधर होंगे, यहाँ पे क्या होगा? Tropical rainforest is this monsoon type of climate, India type का. And between these two, अभी इसको डिटेल में देखेंगे किसमें क्या होगा, कैसी conditions होगी and all. Between these two you will have grassland type. It will have more rainfall than this, less rainfall than this, lesser temperature than this, more temperature than this. So conditions here will be between deserts and monsoon type. So this will be your grasslands that you will get here. In this condition you will get grasslands. If we go higher up, above this, imagine Africa. Above Africa, what you will get on this margin? Mediterranean type of climate. So here you will get Mediterranean type of climate. Above India, what type of climate you will get on this margin? China type of climate. Abhi just we are understanding what type of climate is formed in what all locations of the earth. Just above grasslands, just above tropical grasslands, what you will have here? It is between Mediterranean and China. You will get Central Asia. Central Asia is famous for tepi या temperate grasslands. This is temperate grasslands that you will get. This is savanna type. This is tepi type. Detail में देखेंगे एक एक को. Above Mediterranean, if you are going here, what type of climate do you get? Imagine करो मेडिटेरेनियन के ऊपर जा रहे हो, क्या दिखेगा वहां पे? क्या आएगा यूरोप में? यूरोप on the western margin. You will get UK, Britain. So British type of climate. This is temperate grassland. Central Asia. If you are going above Central Asia, what type of climate you will get? Siberia, Siberian type of climate. Above this, अब यहाँ पर आपको नहीं दिखेगा Laurentian type. For that, go to same parallel in North America. What you will find this side on eastern margins? Taiga, Laurentian type of climate. You will find in Canada. देखेंगे अभी मैप में एक एक चीज की कौन सी चीज कहाँ मिल रही है. And then if we go higher reaches, you will get polar or tundra type of climate. So majorly we will see this 11 type of climatic regions that we will get over the world. Start from the equator, start going towards the polar areas. You will जैसे जैसे वर्ल्ड में जो जो लोकेशंस आ रही है, just start relating with different climatic conditions that are prevailing there. So you will have equatorial rainforest, then desert conditions. Desert is very dry. Then grasslands, monsoon type, Mediterranean type, again grasslands, China type, then British type, Siberian type, Laurentian type. इमेजिन करते जाओ, ब्रिटेन के पास में साइबेरिया है, एंड ईस्टर्न मार्जिन्स पे जब हम देखेंगे तो ईस्टर्न मार्जिन्स विल हैव लॉरेंशिया, कनाडा वाला जोन, ईस्टर्न मार्जिन्स. हियर यू विल हैव पोलर रीजन्स. So somewhat like this is what we have drawn here. अब अभी we have said कि this is British type, this is China type. In technical terms they might give you different names. So British type is which margin? British type is which type of margin? It is western or eastern? It is western margin. First thing, is it lying in temperate region or tropical region? Temperate. So temperate. Is it warm temperate or cool? Cool temperate. तो ऐसे करके नाम बन जाएगा cool temperate western margin. This is British type of climate. If I am going this side, same thing will become cool temperate eastern margin. So this is how they will give you nomenclature for all this. As we go thoda sa niche, this, if this is cool temperate, this will be warm temperate. Same way this will be warm temperate eastern margin, warm temperate western margin. So वहाँ पर it might happen that they might not give you Mediterranean type of climate. They might give you warm temperate western margin, और China की जगह warm temperate eastern margin they might give you. You need to be aware of these terms as well. Done? Now there are various factors that lead to formation of biomes. उतने काम के नहीं है कि किस फैक्टर से बना है. Majorly it is your temperature and precipitation. Temperature and precipitation, along with that length of growing season, it determines that which all types of plants can be there and all. But majorly all of things depends, yeah, revolve around your temperature and precipitation conditions. Let's start with equatorial type of climate. So hot, wet equatorial climate. As the name says, we'll find this type of climate on the equator. See, all these photos are from GC Leong only. तो हो सकता है कहीं कहीं पर, क्योंकि मैंने क्लिक करी है तो ये दिखे ना शायद ढंग से. Now here on the equator we will get equatorial rainforest. Ab equator is very high insolation but at the same time very high precipitation. And can I say high insolation is there throughout the year? ऐसा नहीं है कि only in summers you have high insolation, in winters low. नहीं, it is there throughout the year. If it is there throughout the year, tell me what happens to the annual range of temperature. Is it very high? Is it low? Is it very low? क्या है? Can I say annual range of temperature is very low? क्योंकि बहुत ज़्यादा वेरी नहीं करेगा टेम्परेचर थ्रू आउट द ईयर. टेम्परेचर रिमेन्स ऑलमोस्ट कॉन्स्टेंट क्योंकि हर दिन सन is giving you lots of insolation in this particular area. So annual range of temperature is very less here. What about diurnal range? What do you mean by diurnal range? Diurnal range is within a day. So within a day, what was the maximum temperature? What is the minimum temperature? That is what is diurnal range of temperature. आपकी जो sheets है उसमें you can keep on writing type of climate that is there, location. So location में you can also mention some of the areas like Congo, you have Amazon basin, you have rainforest in Indonesia, Malaysia. You can keep on jotting down in type and its location. Next, climatic conditions. In climatic conditions, you are supposed to write temperature conditions and rainfall conditions that prevail there. So mainly temperature क्या होगा, climate कैसा होगा, precipitation क्या होगा, this you are supposed to write here. Then we'll also discuss some important features. Important features being वहाँ का vegetation कैसा है, what tribes live there, what kind of occupation they follow. So some of those important features you can keep jotting down here in this column. अब ये साथ साथ बनाते जाना, ठीक है. So location, it lies near maybe 5 to 10 degree north and south of equator. This is where this lies. Climate, hot, high insolation, wet, because almost every day you will experience precipitation. This is where we get 4 o'clock rain. So during the morning time it is very high insolation, very high updraft of air leading to condensation by the evening time. So 4 o'clock rain is related to this type of climate. Mean temperature around 27 degrees. Sorry, 4 o'clock rain. See, normally what happens is during the daytime, in the first half of the day, insolation being very high, it leads to huge evaporation of water. Pani evaporate hoga, suddenly you will see the clouds being forming towards the later half of the day, and by 4 o'clock, around 4 o'clock, it starts raining. So almost every day we experience rain in this particular region. So this everyday rain is what is called as 4 o'clock rain. ये वही लिखा है, डायरेक्ट सनलाइट, हीट सरप्लस, low pressure condition every day, rising moist air, convection rain every evening. So almost every day you can experience rainfall in such a climate. यहाँ पे कभी winters नहीं होगी. Almost the same temperature will prevail throughout the year, so you will have very small range of temperature. ये सब लिख लेना because these things they normally ask. Very high range, very small range of temperature and so on. Precipitation, it will be very high. 150 से 250, it can be even more than that क्योंकि normally रोज rainfall हो रही है. In fact, you can write it to be 200 plus centimeter. Heavy rainfall. regions: Amazon, Congo, Indonesia, Malaysia. What are oxysols? See, what happens is, as there is more and more rain, your soil get easily weathered because continuous रोज बारिश हो रही है, so your soil will be weathered. Such a soil is called oxysols, which is very highly weathered and highly oxidized soil. So soils here in the rainforest, will it be very productive or not? It will be very much degraded. But still we see very lush vegetation in this particular area. देखते हैं क्या होगा. So we see very high vegetation, dense rainforest, because rainforest वाला इलाका है. We see dense rainforest in this area, and rainforest is because of high presence of water and sunlight throughout the year. Sunlight and water is present throughout the year. Because of this, it is year long growing seasons of crops in that area, leading to formation of rainforest. High biodiversity because jungle hai ye literally. It is not a pure strand of forest. You have proper jungle that is there, proper rainforest. So there are hundreds and thousands of species of plants also and animals also living there. So high biodiversity area these. Tall trees. अब यहाँ पर you will have closed canopy of trees. Environment पढ़ लिया है. What do you mean by closed canopy of trees? So nearly it is very hard for the sunlight to reach to the ground. You will get different gradation of species there. Ground पे भी बहुत सारे छोटे छोटे plants होंगे. Then you will have some smaller plants, smaller trees, some mid-sized, फिर उनसे भी बड़े. Then you might get some epiphytes also, climbers also. So there are various types of species that are there. इतना ज़्यादा है कि sunlight might not reach to the ground as well. Now lumbering. What does lumbering means? हाँ, पुष्पा देखिए. That is what is lumbering. Wood cutting and all, that industry is what is lumbering industry. But these woods are hardwoods. Hardwood and softwood, you can just imagine hardwood would be very hard, difficult to cut. Softwood will be relatively easier to cut. So will such an industry flourish here? The wood is hardwood. It is not that easy to cut, first thing. Plus, we do not find it in pure strands. First thing, it is proper jungle. You will have to go deep into the forest to cut trees. Your machinery might not reach, people might not reach. It is not easy to carry the wood back from there. So lumbering is not that productive here. It is not developed in these regions. Very difficult. Amazon rainforest are also called as selvas. इसका नाम याद रख लो, selvas. We'll read this in mapping also. वहाँ में मैं बताऊंगा, but selvas नाम याद रख लेना Amazon forest का. Life and livelihood. It is very moist and hot climate, so it is not good for habitation. आप खुद ही देखो, when बहुत ज़्यादा moisture हो जाता है, बहुत ज़्यादा चिपचिप होने लगता है, you start feeling uncomfortable, because normally we used to thrive in the range of 50 to 60% relative humidity. This is what humans feel comfortable in this range of relative humidity. If here almost every day it is raining, that means almost every day relative humidity will rise and then dip, will rise and then dip. So it is not good for habitation. Very sparse. You might see some tribes living in that areas. Plus high temperature, humidity leads to bacterial growth, pest वगैरह. बहुत ज़्यादा यहाँ पर मच्छर होंगे. You will see malaria prevalent there in this, and because of pest you will also see cattle diseases. So various African nations in and around Congo is still battling with malaria there. So one of the adaptations of that is sickle cell anemia. So you will see various people there with sickle cell anemia because उनको मलेरिया नहीं हो पाता है जल्दी से. क्यों नहीं हो पाता है? हाँ, so RBCs die down before the gestation period of your malaria वाला ऑर्गेनिज्म पढ़ा है ना साइंस टेक में? हो गया या नहीं हुआ अभी साइंस टेक? अरे हाँ नहीं दोनों नहीं बोल रहे हो? अभी नहीं हुआ है, ठीक है। अभी डिजीजेस नहीं कवर हुआ है, ठीक है। तो हाँ नहीं कुछ तो बोलना चाहिए था। या यू वर लाइक कि सो रहा था शायद तब हो गया था, ऐसा था क्या कि मैं सो गया था उस क्लास में? चलो, now here since tribes are living normally we'll see shifting cultivation in this region, so shifting cultivation can be there, बहुत ज़्यादा ग्रोथ नहीं है, प्रिमिटिव एरिया है, ट्राइबल्स विल बी लिविंग, सो यू कैन मतलब एक बार बस नाम पढ़ लो, अमेजोन में अमेजोन ट्राइब्स आर देयर, यू हैव कॉन्गो में पिग्मी ट्राइब्स, एंड मलेशिया में ओरांग असली, ओरांगुटान मलेशिया, ओरांग असली यहीं से याद कर लो, ओरांग असली ओरांगुटान मलेशिया देयर, पिग्मीज इन कॉन्गो। क्या काम करते हैं वो छोड़ दो, कलेक्टिंग नट्स और ये, बस वेयर आर दीज ट्राइब्स लोकेटेड, दो चार इंपॉर्टेंट ट्राइब्स, एंड नॉर्मली दे आस्क यू ट्राइब्स इधर फ्रॉम डेजर्ट और रेन फॉरेस्ट, बहुत हायर रीचेस की ट्राइब्स नहीं पूछी जाएगी। डन? हाँ, अच्छा, सम क्रॉप्स ग्रो वेरी प्रोमिनेंटली इन दिस रीजन्स, all the crops that need higher rainfall and higher temperature like rubber, cocoa, palm oil, all of these crops need relatively higher temperature and higher rainfall, they flourish. So we will see palm oil plantations in Malaysia, Indonesia, cocoa in Africa, याद आ रहा है, अफ्रीका में we have seen, and then rubber plantations Brazil, वहाँ पे भी है, एंड प्लस इंडोनेशिया मलेशिया के वहाँ भी है। इवन वी आर ट्राइंग कि जहाँ पर हाई टेम्परेचर एंड रेनफॉल कंडीशन इज देयर वी कैन हैव पाम ऑयल प्लांटेशन, कहाँ पर, इंडिया में, in northeast and Andaman. In these regions, we are trying to have some kind of palm oil plantations because condition here is higher rainfall in northeast, higher temperatures there. Same for Andaman, it is near to equator. So almost similar condition can prevail in Andaman regions. Is this done? दो तीन के बाद वापस से रिवाइज करेंगे, दिमाग में रख लो क्या क्या पढ़ा है इसमें। दिस टाइम आई वॉन्ट लेट यू लुक इन टू द कॉपीज, खुद से रिकॉल करना है, सारा यही याद करके जाएंगे जितना है। हाँ, वॉइस, चलो नेक्स्ट वी आर मूविंग टू, अभी ठीक है, नेक्स्ट वी आर मूविंग टू हॉट एंड मिड लैटिट्यूड डेजर्ट। तो जस्ट हियर वी सॉ इक्वेटोरियल फॉरेस्ट, अभी थोड़ा ज्यादा ऊपर हम जाते हैं यहाँ पर नियर द डेजर्ट रीजन्स, हियर यू विल हैव सहारा डेजर्ट, हियर यू विल हैव सोनोरन एंड मोहावे डेजर्ट, हियर अटाकामा डेजर्ट, नमीब, कालाहारी डेजर्ट, ग्रेट ऑस्ट्रेलियन डेजर्ट, थार डेजर्ट, Iranian, Arabian, all of these deserts are located here. At what latitudes are they located? In and around 30-degree latitude. So they are located in and around 30 degree because of the high pressure belt that is there. But there are certain other conditions leading to the aridity of these regions we have seen earlier today. याद आ रहा है क्या क्या conditions है? Cold ocean currents, offshore trade winds, one is this high pressure belt, last is dry continental air mass which lets this condition sustain there. Climate, it is desert, so arid and dry climate will prevail in this region. High temperatures will be there because of high pressure condition या descending winds, you will have clear sky which will give you high insolation. So clear sky, high insolation will be there. Diurnal range, diurnal range is within a day what you will experience. So during the daytime temperature will be very high, during the night you will have very less temperatures because उतना ही जल्दी due to clear sky your radiations will move out, so your radiations will also, terrestrial radiations can easily escape out. So at the night time temperature will be very less, at the daytime temperature will be very high. जैसलमेर जोधपुर कभी जाओगे वहां पर इन द थार रीजन एरिया, दिन में बहुत गर्मी, रात में ठंडा उतना लगेगा. So you will have very high diurnal temperature range. Cooling effect, near to the cold ocean currents you will have cooling effect. Peruvian current, Venezuela current, all of this will be there. Precipitation, very scanty rainfall. कभी हो गई तो हो गई, इस तरह से होगा. Offshore trade winds, we have seen all of this. Desiccating effect, we have seen this desiccating effect. It is caused by this cold ocean currents. You can write this: location, climate and temperature. What type of vegetation will prevail? Thorny. Is there a term for it? Xerophytic vegetation will prevail in this. So what are the adaptations of such xerophytic vegetation? Leaf is needle like, okay? And what about roots? Very deep roots, very long roots. What about stem? Fleshy stem, succulent stem. It will have water stored in that. याद आ रही है ये सब चीजें, आपने एनवायरनमेंट में शायद पढ़ी होगी ये सब. So vegetation is, because arid and dry climates, scanty rainfall, water deficit will be there. Because of this we will have xerophytic vegetation, almost no leaves. You can imagine cactus, almost no leaves, yeah, very thorny. Succulent stem, stem will store water in it. Long roots to get water from deeper soils also. So long roots will be there. High salinity of the soil, obviously whatever is left there it will evaporate, whatever moisture is there. So we are left with soil, soil is left with salt there. So hard pans will be formed. Humus deficient, humus deficient मतलब जो ऑर्गेनिक मैटर होगा वो कम होगा. Life and livelihood, again low population because not very livable. प्रिमिटिव ट्राइब्स आर देयर. इनके नाम याद रख लो, ये अलग अलग एग्जाम्स में पूछे हुए हैं. इन चारों का नाम याद रखना है आपको, जिसमें से ये दो ज्यादा इंपॉर्टेंट है बिकॉज दीज आर मोर प्रिमिटिव ट्राइब्स. दीज टू ट्राइब्स आर रिलेटिवली सेटल्ड कल्टिवेटर्स ऑल्सो एंड ट्रेडर्स ऑल्सो. सो बुशमेन्स एंड हॉटेंटॉट्स ऑफ कालाहारी, बुशमेन्स एंड हॉटेंटॉट्स ऑफ कालाहारी. कालाहारी डेजर्ट इज इन साउथ अफ्रीका के पास में, ठीक है. कैसे भी करके याद कर लो कि काला है, हॉट है इसलिए काला हो गया, जल गया. बुशमेन्स एंड हॉटेंटॉट्स ऑफ कालाहारी. बिंदिबू ऑफ ऑस्ट्रेलिया. So in Australia also we will see Bindibu of Australia. Here we have deserts. Then Tuaregs of Sahara Desert. These are settled tribes relatively. Bedouins of Arabia. They are even traders also. Bedouins of Arabia. देखा होगा फोटो में, इमेज में कभी कैमल्स के साथ बहुत सारी ट्राइब्स जा रही है. These are those Bedouin tribes. Done. Tuaregs of कहाँ थी? सहारा. Bedouins of अरेबिया. ठीक है, याद रख लेना. Let's cover mid latitude desert also. Now this mid latitude desert is formed because of the desert regions में in general your precipitation is less than 25 centimeter. So if I am having an area where rainfall is less than this much, we will have desert like conditions. In mid latitudes, even though we are not having very high pressure belt, जैसे यहाँ पर you have high pressure belt creating conditions of aridity, these regions are arid because of their continentality effect. So you have Taklamakan desert, you have Gobi desert, you have Patagonia desert. All of this have their own reasons of aridity. Like this lies in the rain shadow zone of Andes mountains. This lies in the continentality of this. तो यहाँ पर बहुत सारे mountains हैं. These are surrounded by mountain ranges. So they do not let the moisture laden winds to reach this particular regions. इस कारण से वहां पर desert conditions है. So aridity is because of continentality there. So rain bearing clouds cannot reach. Sometimes these deserts are present on leeward side. ये हमने देखा था Patagonia desert. Aridity but no sand dunes. So these are not normal desert type. For example, Ladakh. Ladakh में you will see very picturesque images there. वहाँ desert जैसा नहीं दिखेगा, but still it is a cold desert that we have. Desert is defined by not by sand dunes कि वहाँ sand dunes हैं तो desert हो गया. It is defined by lack of rainfall. Rainfall less than 25 centimeter is leading to desert-like conditions. So why Ladakh is a desert? Why Ladakh is a desert? Your southwest monsoon winds are not able to reach it because of which range? Himalayas तो है. There are various ranges of Himalayas. You have Karakoram range that is stopping all of the winds to reach towards the Ladakh side. देखेंगे मैपिंग में सारा रेंजेस भी पढ़ेंगे. तो कॉन्टिनेंटलिटी लीड्स टू एक्सट्रीम टेम्परेचर्स. तो यहाँ पर भी यू विल गेट एक्सट्रीम एनुअल टेम्परेचर्स एज वेल. For example, during summers when sun is here in the northern hemisphere, they will have higher temperatures during the day. But at the same time, during winters, they will have very less temperatures also here. Again, making these areas relatively less livable. तो यहाँ बहुत ज़्यादा रह नहीं पाएंगे यहाँ पर भी लोग. Some important deserts. You have Ladakh from India. Uzbekistan में भी there are various deserts here connected to China. You will have deserts. Taklamakan in China, Gobi Desert, Central Asia in China, Patagonia Desert, Argentina. Done? Kalahari Desert. अरे Kalahari Desert यहाँ पर you have tropics ना. हाँ. कौन से डेजर्ट को? वो यहीं पे है. वो तो यहीं पे है ना. अच्छा यहाँ पर तो इसको सी देयर आर वेरियस स्मॉलर डेजर्ट्स आल्सो. मैंने टकला मकान का नाम लिया है, दैट डजंट मीन कि यहाँ पे छोटे मोटे जो डेजर्ट्स है वो नहीं है. So there will be various smaller deserts near these deserts also. They are also classified at mid latitude. Next, अब coming near to your desert type of climate. यहाँ पर just see this picture. यहाँ पर we had क्या था इक्वेटर के आसपास? Congo Basin, equatorial rainforest. यहाँ पर what was here? It was Sahara Desert. Now we are reaching here in between these two. So it will have conditions little less than equator but more than desert. इन दोनों के बीच में conditions will lie. So rainfall will be lesser than equator but more than desert. Same way temperature ranges will lie between your desert and your equator. So it will have everywhere, यहाँ हर जगह the conditions that are prevailing there will be between your desert type conditions and your equator type of conditions. So a transition zone of climate between rainforest and desert. Climate distinct wet and dry season. So we experience a distinct wet and dry seasons here. No distinct rainy season that is there. Distinct rainy season नहीं है, distinct wet and dry season है यहाँ पर. Temperatures, हाई डायगोनल रेंज. अगेन दिन में गर्म बहुत ज्यादा हो जाएगा, रात में ठंडा भी हो जाएगा. तो हाई डायगोनल रेंज विल बी देयर. But annual range is not much. See how annual range and diurnal range are calculated. Normally when I'm talking about diurnal range, they will see what is the maximum temperature on that day, maximum, and what was the minimum temperature on that day. This is diurnal range. Annual temperature या annual range when we are seeing, we see at a particular time. Let's say at 12 noon. What was the temperature throughout the year on 12 noon? तो दिन में 12 बजे क्या टेम्परेचर था, या दिन में 10 बजे किसी भी टाइम पे what was the temperature of that particular place throughout the year. And depending on the range of temperatures throughout the year, they are calculating annual range. एनुअल रेंज ऐसे नहीं निकाल रहे हैं कि सबसे मिनिमम क्या टेम्परेचर था और सबसे मैक्सिमम क्या टेम्परेचर है पूरे साल में, एक पर्टिकुलर टाइम पे क्या मिनिमम और मैक्सिमम है, दिस इज हाउ एनुअल रेंज इज कैलकुलेटेड. ठीक है, एक एट अ पर्टिकुलर टाइम, दिस इज, ये कभी भी हो सकता है दिन में, इट इज नॉट एट अ पर्टिकुलर टाइम, दिस इज कैलकुलेटेड एट अ पर्टिकुलर टाइम, कि दिन में 12 बजे मतलब हर दिन दिन में 12 बजे क्या मैक्सिमम है क्या मिनिमम टेम्परेचर है. प्रेसिपिटेशन विल लाई बिटवीन योर डेजर्ट एंड इक्वेटर वाला, so from 80 to 160, this is where you have grasslands there. तो डेजर्ट से थोड़ा ज़्यादा वेजिटेशन, इक्वेटर की जैसा नहीं होगा, बीच में these are ideal locations of grasslands. They are also called as savanna type of climate or Sudan type of climate. Where is Sudan? You have Sudan here. It is very prominently developed in Sudan, hence it is called as Sudan type of climate as well. Done. You can write Llanos and Campos in साउथ अमेरिका. लोकेशन जो लिखोगे ना टाइप के नीचे, लानोस एंड कैंपोस इन साउथ अमेरिका, कानो एंड सैल्सबरी, although most prominently you will get savanna type written there, but कभी ये आ गया कानो सैल्सबरी एंड कैंपोस आर टाइप ऑफ, फिर दे आर यूजुअली फाउंड इन विच टाइप ऑफ क्लाइमेट, और फिर वहाँ सवाना दे दिया, आप कंफ्यूज हो जाओगे. तो जस्ट एक दो बार लिख लिया पढ़ लिया तो इट माइट क्लिक यू डायरेक्टली देयर. अब what is the prominent feature in this? One important feature is fire. In grasslands, one of the most important feature is fire in dry seasons. So जब सूखा पड़ेगा अपने आप आग लग जाएगी. It is not someone will go there and will light the fire there. It is a nature's way of controlling. It is a nature's way of controlling trees. This is because we do not have much trees in savanna type of grasslands. We will have lesser trees because every now and then we this particular region can experience fire, and because of this fire growth of trees is limited there, growth of grasses are there. तो बहुत दूर दूर तक आपको पेड़ नहीं दिखेंगे यहाँ पर, almost grasslands will be there, hence tigers and all of these things there, big game country में. Grasses, normally we will find very high grasses called as elephant grasses here. They are not very nutritious. Nutritious grasses we will find in the temperate grasslands. So even though these are tropical grasslands, they do not play that role that temperate grasslands play. वहाँ पर very nutritious grasses are there. जब हम पढ़ेंगे temperate, there you will see dairy farming very prominently developed. Here grasses are there, but they are not that nutritious, so they are not helping in animal husbandry. This is mostly wild things that are there, but there in temperate regions we will see very prominent development of animal husbandry. Later on अभी देखते हैं उसको भी. So grasses not much nutritious, turn green in wet and dormant in dry. ठीक है. Normally it has longer roots. पानी बहुत ज़्यादा नहीं है तो longer roots of grasses are also there. Acacia trees, so in they are also called as baobab trees in Australia. Huh? So in Australia you usually found this baobab trees. Australia में भी है, नहीं नहीं ऑस्ट्रेलिया वाले रीजन में मिलते हैं, ये वाला रीजन जो है ना यहाँ पर. तो इन ऑस्ट्रेलिया वाला रीजन यू फाइंड दिस बायोबाब ट्रीज एज वेल. अफ्रीका में सवाना है, वो है, हर चीज अफ्रीका में नहीं है, अफ्रीका के बाहर भी है ये टाइप. हियर ऑल्सो इन ऑस्ट्रेलिया ऑल्सो यू विल फाइंड दिस. So it stores water in the trunk for dry season. अगर कहीं आ जाए रिलेट करने के लिए बाओबाब ट्रीज, वैसे भी एनवायरनमेंट में रैंडम स्पीशीज वो दे देते हैं, this might be there. There are three grasses that I'll tell you to remember, just specifically three grasses: Malli, Mulga and Spinifex. These are grasses from Australia. Tribes में Masai Mara या Masai tribes from Kenya. They drink cow blood. जीसी लियोंग में फोटो भी अगर आपने देखा हो तो पढ़ी है जीसी लियोंग, उसमें अलग से फोटो भी है. बट दे विल नॉट kill the cow, they'll just slit it, they'll take out certain blood and they'll again seal that, and according to them it is helping the cow as well. I don't know how, but they used to drink cow blood. Masai tribes of Kenya. Now see, Harmattan पढ़ा था. In which region have we read about Harmattan? Here, this is from where Harmattan winds blow. याद आ रहा है? Doctor winds. So this is from where your Harmattan dusty winds starts blowing. Doctor winds. Done? Let's recall these three, then we'll move ahead. नहीं तो सब mix हो जाएगा. Sorry. We have seen three biomes abhi tak. One is equator. Tell me prominent features there. 5 to 10 degree, that is the location. Annual precipitation more than 200. ठीक है. And temperature variation. Temperature variation low. So diurnal annual temperature range low, almost the same. Winters, there are no winters, or almost closed canopy. Vegetation is very lush vegetation is there. Huge biodiversity is present. Not good for lumbering. बहुत hardwood trees है. What about tribes? हाँ, pygmies in Congo, orang asli in Malaysia. याद आ रही हैं चीजें? It is good. The climate is good for some of the plantations. Palm oil, cocoa, rubber. So it is being cleared as well for such plantations. Next we move to deserts. Desert mein in general you know all the conditions. Give me vegetation and tribes. Xerophytic vegetation is there. Succulent stems, long roots, horny. ठीक है. Tribes, Bushmen and Hottentots of Kalahari. Next, Bedouins of Arabia, Tuaregs of Sahara, and Bindibus of Australia. Done. Next we move towards grasslands, savanna or Sudan type of climate. Give me prominent feature. पहले rainfall बताओ चलो. Around 60 to 80 to 160 kilometers. Temperature range high. ठीक है. And some important feature, fire. Fire is a very important feature here. It limits the growth of trees there. Grasses are not that nutritious. Some prominent grasses: elephant grass, malli, mulga, spinifex. Three more grasses are there. Sorry. Tribes, Masai Mara tribes. Done? Sorted? Next, we'll move to monsoon type of climate. Now this, almost you know all the features we have dealt with in. One thing is, it is not just found in India, in other continents also it is found. So come parallel to India, here you will have in this region, same way here, here, here. You will have monsoonal type of climate. It doesn't mean that all of them will have southwest monsoon winds. This is specific to India. Monsoonal type of climate means there should be seasonal reversal of wind. This is the most important feature of this monsoonal type of climate. यहाँ पर भी there would be some winds that are having seasonal reversal. Here also, here also, here also. So some seasonal reversal of wind system might be there. This is how will you locate monsoonal type? किधर जाएंगे? Towards the eastern margins in the tropical regions. So tropical regions में eastern margins, this is equator. Tropical regions में eastern margins of tropical regions will experience monsoonal type of climate. Is this clear? बाकी ITCZ shifting and all, we all know this. वेजिटेशन इंडिया का सोच के सारा लिख देना. नॉर्मली यू विल हैव deciduous type of vegetation, hardwood trees, sal, teak, all of this are there used prominently in furniture. साल teak ये सब सुना है ना. teak is सागौन. याद आ रहा है? सागौन, सांगवान, जो भी आप लोग बोलते हो अपनी लैंग्वेज में, very prominently used across India. Myanmar teak, we have seen that this is present here in Southeast Asia as well. So Myanmar teak again very famous for furnitures. So such vegetation is prevalent. Crops जो भी इंडिया में उगता है, all of these crops can be found there. Next आते हैं, important one is Mediterranean type of climate. Couple of times question have been there from Mediterranean type. Now how will you locate this? We'll go above desert. Above desert in which margin? Eastern or western? Western margins. Now we are going to temperate regions. So warm, temperate, western margin type of climate is your Mediterranean type. वो Mediterranean नहीं लिख के देगा, हो सकता है they will give you this warm, temperate, western margins. You will have to locate it that yes, this is the Mediterranean type of climate that he is talking about. So Mediterranean type, as the name says, you will find it in and around Mediterranean. Warm, temperate, western margins. So western margins में, temperate regions में western margins you will have here as well. In the western margins and temperate regions, in the western margins and temperate regions, in all of these western margins you can have this type of climate. So here you will have Perth, यहाँ पे Cape Town. Here also Chile में you will have some. यहाँ पर you will have California. So you can write these locations. This is complete Mediterranean region. Here you will have Mediterranean type of climate. Now one prominent feature of this climate, सबसे important feature is winter rainfall. कैसे होगी एक बार देखते हैं अभी. Now see, during summers, this is where your tropics is. During summers, what will happen is sun will shift towards the Tropic of Cancer. Can I say all of the wind belts will also shift? If all of the wind belts are shifting, normally wind belts are supposed to be like this. ये पेन दिख रही है दूर से? This color is visible. This color is visible पीछे. ठीक है. So if the wind belts are shifting, can I say this belt will shift somewhere here? If this belt is shifting, now during summers, I'm saying, during summers you will have an offshore wind. This wind belt is shifted during summers. So during summers, this is an offshore wind that is blowing from here. Here, this will be an offshore wind that is blowing. अगर offshore है मतलब shore से दूर जा रही है, तो during summers such climate will not experience rain. So dry summers will be there. Distinct dry and warm summers will be experienced in such climate. But at the same time, what will happen during winters? During winters, all of these wind belts will shift relatively downwards. If they are shifting downwards in this particular region, which type of winds it will experience during winters? During winters यहाँ पर ऐसे winds होती है, so can I say it will have westerly winds being experienced. Westerlies will be onshore winds. They are coming towards the shore. If they are coming towards the shore, they will bring rainfall. So during winters, this particular type of climatic regions will experience rainfall. So in winters, apparent movement of sun is towards this. This will come under the influence of westerlies. It will leading to winter rainfall. One prominent feature, it has been asked 2 या 3 बार in अलग अलग exams. This is the most prominent feature, winter rainfall. Location 30 to 45 डिग्री नॉर्थ एंड साउथ ऑफ इक्वेटर. ये सब आई एम होपिंग कि आप लिखते जा रहे हो अपने से. टेम्परेचर ऑलमोस्ट यूनिफॉर्म थ्रू आउट द ईयर. इट इज ऑलमोस्ट यूनिफॉर्म. ना बहुत ज्यादा ठंड होगी ना बहुत ज्यादा गर्मी होगी यहाँ पर. ऑलमोस्ट यूनिफॉर्म थ्रू आउट द ईयर. Rainfall somewhere in this range 30 to 90 centimeters. And majority of this rainfall is in winters. Summers mein it is almost dry. Done? So this is that shifting of vegetation that we will have here. Since we have dry summers, तो पानी बचाने के लिए trunk of the trees will be huge. इतनी की कम होगी वहां पर it will have widespread roots. Roots will spread. These are all adaptations only. बस imagine कर लेना पेड़ को पानी दिए क्या करेगा अपनी roots. It will be relatively widespread roots. Stunted trees, it will not go to a great heights. Trees are stunted because of lack of water, lack of rainfall. So because of one or the other conditions कुछ ना कुछ stunting होगी. Stunting is because of lack of water here. So trees बहुत चौड़े होंगे लेकिन बहुत लंबे नहीं होंगे. It will be very broad, very thin, but relatively of lesser heights. Moisture content, growth will be limited to autumn and spring because the moisture will be relatively lesser. So growth of the trees or growth of remaining plants will be in autumn and spring season only. Small leaves, canopy to minimize evaporation. Every kind of adaptation that the tree can do will do here with less water. Agriculture, very prominent here is citrus fruit plantation. So we will see viticulture being developed here. Viticulture is wine making. Wine is made by citrus fruits, grapes and all. So wine making is, yeah, viticulture is one of the prominent feature, yeah, prominent livelihood activity that is in this particular region. Citrus plantations, especially oranges, grapes, lemons, all of these are very prominent in this area. We have seen it is there in California. In California, you will have sun-kissed oranges, famous hai. In Israel also it is developed near Mediterranean. You will find Israel as well. Jaffa oranges, Spain mein Sevilla oranges. So all of these oranges varieties are very prominent there. One major thing that olive oil बहुत ज़्यादा prominent है. Olive oil खाओ healthy है and all. All of this narrative is being set by these Mediterranean countries because they are the net growers of olive oil. We cannot grow olives here. तो कोई ऑयल हेल्दी नहीं है, सारे खराब है. ठीक है, ऑलिव ऑयल बस महंगा है इसलिए, एंड इट इज देन एक्सपोर्ट आइटम दैट इज देयर. इसीलिए इतना ज्यादा नरेटिव होता है कि ऑलिव ऑयल इज हेल्दी. नो ऑयल्स आर हेल्दी. Coming to viticulture, viticulture is wine making. So there are various wines that are prominent all around the world. I have just listed down a few. नाम याद रखने की जरूरत नहीं है, but it is prominent in this Mediterranean region. So you might have heard champagne, sherry, burgundy, bordeaux. All of these wines are there. क्या हुआ? ऑस्ट्रेलिया में पर्थ एंड एडिलेड, दीज आर टू फेमस सिटीज दैट आर देयर having cricket, having Mediterranean type of climate. Then Cape Town in South Africa, famous for fruit plantations. Chile, famous again for wine manufacturing. California for oranges, sun-kissed oranges are there. So all of these are there, famous for viticulture. Viticulture is growing of citrus crops and wine making. Done. नेक्स्ट करते हैं, यू हैव टेम्परेट कॉन्टिनेंटल स्टेपी टाइप ऑफ क्लाइमेट. वी आर कमिंग थोड़ा सा इधर, यहाँ पर वी हैव सीन कैलिफोर्निया, वी आर जस्ट कमिंग नियर टू कैलिफोर्निया. यहाँ पर वी हैव सीन मेडिटेरेनियन, वी आर कमिंग नियर टू दैट. यहाँ पर देखा था उसके पास में, so we are just coming near to the Mediterranean type of climate. This is where we have steppy type of climate. These are temperate grasslands. अब these temperate grasslands have different names in different continents. जैसे here very prominently developed are steppes in Central Asia. In Hungary you have pustas of Hungary. pustas, इनके नाम याद रखना है, मैच द कॉलम ही दे देंगे as it is. pustas of Hungary, steppes of Central Asia. In America we have wheat baskets of the world called as prairies. So these are again grasslands, temperate grasslands, prairies. यहाँ पर pampas of South Africa, velds of South America and downs of Australia. ये याद रखना पड़ेगा. As it is, they might give you a match the column. It is not that hard, करा जा सकता है. Steppes of अरे समोसे बाद में खा लेना. Steppes of Central Asia. Next, pustas of Hungary. Coming to the North America, you will have prairies. Coming to South Africa, you will South America, pampas, South Africa, velds. In Australia, you have downs. जिसको नहीं हुआ है इवेंचुअली हो जाएगा. ये जितने बोल रहे हैं पहले से करके बैठे हैं, इनने अभी नहीं किया है. ठीक है, हो जाएगा इवेंचुअली. Now this is the region which is under the influence of westerlies. So you will have westerlies flowing here. It is not near to the sea, so maritime influence will be relatively less. If maritime influence is less, annual range of temperature will be high. जब जब maritime influence होगा, range of temperature declines. यहाँ पर you will have high annual temperature. वार्म समर्स, कोल्ड विंटर्स. सो बहुत ज़्यादा गर्मी होगी समर में, बहुत ज़्यादा ठंड भी होगी. वार्म समर्स, कोल्ड विंटर्स. रिलेटेड, आई टोल्ड यू चिनूक विंड्स. चिनूक विंड्स ब्लो नॉर्थ अमेरिका में ओनली, एंड it is also called as snow eaters. That means there is some kind of snow that it is eating, and I have told you it is very important for prairies. उस टाइम पे मैंने बोला था it is important for wheat cultivation in that area. So snow हो रही है मतलब cold winters है. At the same time warm summers are also there because of slight continentality effect. ऐसा नहीं है बहुत ज़्यादा अंदर है, but still it is not having any kind of maritime influence. Done. Vegetation. Here, since it is grasslands, we will find extensive grasses there. These are short and nutritious grasses. These grasses are perfect for animal husbandry. So we will find animal husbandry very prominently developed in these regions. Animal husbandry से क्या होगा? यहाँ लिखा नहीं है. हाँ, cattle rearing. So it is very famous for dairy products. That is why when it was RCEP time, RCEP याद है? 2-3-4 साल पहले, it was Regional Comprehensive Economic Partnership. Australia, New Zealand were also involved. They wanted us to open dairy sector for them because they have downs, and यहाँ पर Canterbury grasslands, very prominent grasslands for dairy farming. हमारे यहाँ जो भी एनिमल है 2-4 लीटर दूध दे रही है, वहाँ पर 15-20 लीटर दूध होगा. in the same grasslands. So very high productivity of animals here. They wanted us to open dairy sector for them because they have high productivity of their animal husbandry sector there because of this reason. Temperate grasslands entire converted into ठीक है. Truck farming is one important feature of this is truck farming. Truck farming means they are not growing vegetables that can be stored. It is just ugao, kato and sell it the next day. So perishable items are normally grown here. In USA, we have prairies, very important for wheat cultivation. Maize cultivation is also there. Now maize is used for for fattening of pigs and other animals there because of meat. And same maize is transported to India, जो आप अमेरिकन भुट्टा समझ के खाते हो, ठीक है, which there is fed to animals that are gone to slaughterhouses. So prairies very prominent for wheat and maize. Same way pampas, again very nutritious. Alfalfa grass, pampas is in South America, sorry. Alfalfa grass is very prominent there. Again, wheat exports. So one prominent thing here is wheat आपको देखने को मिलेगा. यहाँ पर welts, again wool production is a kind of animal husbandry itself. So यहाँ पर भी animal husbandry is very prominent in welts of South America, South Africa. Steppes are the wheat bowls of the world. During Ukraine-Russia crisis, one major concern was because of this crisis, wheat prices increased. See the location of Ukraine. Ukraine is located in the very heart of your steppes. Very high wheat productivity is there. It is one of the exporters of wheat to the world. So यहाँ पर बहुत अच्छा wheat होगा. Pustas of Hungary, again grasslands you have. Wheat cultivation very prominent here. लिख लो. Australia, New Zealand, sheep rearing is there. Done. What is the prominent feature in this continental steppe type? These are grasslands. Grasslands are pure grasslands. पेड़ नहीं मिलेंगे यहाँ पे. Very fertile grounds, good for wheat cultivation. Wheat भी तो grass के जैसे ही है, छोटे छोटे plants. So very nutritious grasses are being formed, good for animal husbandry, animal rearing. तो relate करना है animal rearing, animal husbandry से. What all things can happen? ब्लैक, यहाँ का जो सॉइल है ये भी ब्लैक सॉइल ही है, ब्लैक अर्थ सॉइल है, बट इट इज नॉट लाइक द ब्लैक सॉइल दैट इज फाउंड इन इंडिया. इंडिया का ब्लैक सॉइल इज बिकॉज ऑफ volcanism it was formed and because of disintegration of all the basaltic rocks and all. यहाँ का black soil is all मतलब यहाँ का soil is also black but it was not formed because of volcanism. कुछ और process हुआ होगा. Next comes eastern margins. So warm temperate eastern margins. Warm temperate eastern margins. You will have Gulf type, you will have China type, and in the southern hemisphere you will have Natal type of climate. So this type of climate has three different names. किसी भी नाम से option दिया जा सकता है. Either China type of climate or Gulf type of climate or Natal type of climate. Remember, Gulf is not for Persian Gulf. It is for Gulf of Mexico that is here. Confuse mat hona. Gulf type of climate is because of this Gulf. Natal type of climate in southern hemisphere. China is there, China type of climate. One prominent feature of this particular climate is rainfall throughout the year. मैंने अलग से highlight कर रखा है, उसको लिख लेना. Rainfall throughout the year is one prominent feature of China type of climate. Again, because of shifting of pressure belts, it is such that you experience during summers also and during winters also बहुत ज़्यादा अंदर नहीं घुसते हैं, बस समझ लो कि समर्स में भी हो जाता है बिकॉज ऑफ शिफ्टिंग ऑफ बेल्ट्स, विंटर्स में भी हो जाता है. तो विद इन बोथ द टाइप्स ऑफ क्लाइमेट यू विल सी, विद इन बोथ द सीजन्स यू विल सी रेनफॉल. So rainfall throughout the year is a prominent feature of this type of climate as well, China type. So why it happens, summer में क्यों, winter में क्यों, इतना deep में नहीं जाते हैं. There can be some typhoons and hurricanes also impacting this type of climate. तो यहीं पर हमने देखे थे typhoons and hurricanes in this region only. So they are also impacting this particular type of climate, leading to rainfall. Done. इस prominent feature को लिख लो बस. अब vegetation. See, rainfall is almost throughout the year. We'll say relatively higher rainfall. It is warm temperate. Eastern margin temperature is relatively warmer. If rainfall is available, temperature is relatively warmer throughout the year. Rainfall is also throughout the year. Can I say growing season will be relatively longer? So you will have relatively long growing season. Evergreen vegetation is there. Bamboo imagine कर लेना, China imagine कर लेना, almost evergreen. Agriculture, intensive agriculture is being practiced. Rice cultivation, China rice cultivation. लिंक करते जाओ, जो वहाँ चाइना में आप सोच सकते हो, राइस कल्टीवेशन वेरी प्रोमिनेंट, राइस विल बी देयर. वन ऑफ द लार्जेस्ट प्रोडक्शंस ऑफ राइस अकर्स इन दिस एरिया. सिल्क रूट चाइना, तो सिल्क प्रोडक्शन. टी अगेन रिलेट विथ चाइना, टी प्रोडक्शन. some important river basins also lying in those regions. So all of this lie in this particular area. Prominent feature of this is rainfall throughout the year. And because of warm temperatures, long growing season is there. Done. Gulf type, this is China. Gulf type mein again almost all the condition remain same. One prominent cultivation is tobacco cultivation. So Virginia tobacco very famous. यहाँ पे गल्फ टाइप, मैक्सिको टोबैको ऑलमोस्ट यहाँ पे रिलेट होता है. आपने बहुत सारी मूवीज वगैरह में देखा होगा, स्मगलिंग ऑफ एवरीथिंग हैपनिंग हियर इन दिस रीजन्स, कैरेबियन एंड ऑल, ड्रग्स एंड ऑल, ड्रग कार्टेल्स. कुछ नहीं रिलेट हो रहा है क्या? हो रहा है ना, ठीक है. सो गल्फ टाइप ऑफ क्लाइमेट famous is tobacco cultivation in this particular region. In the southern hemisphere you will have Natal type of climate. Natal type of climate, it is because of a place here called a tribe here, I would say. Tribe is also there, place is also there, KwaZulu Natal, and from here this name came, Natal type of climate. It is here in South America, oh sorry, South Africa. South Africa. Important city being Durban here. Sugar cane is produced. Now see, they are producing rice. They are producing rice in China. Sugar cane, tobacco. These are those crops that require relatively higher rainfall. They require, sugar cane को भी high water चाहिए, पड़ा है. Relatively higher rainfall because rainfall is available throughout the year. Throughout the year rainfall is there, इसीलिए ये crops उगा पा रहे हैं यहाँ पर. Done. चलो let's revise what we have done अभी तक. We have already revised till savanna. After that we have seen monsoon type of climate. वो आप बता दोगे. Monsoon तो इंडिया में जितना सब कुछ हो रहा है, that is monsoon type of climate. Next, Mediterranean type of climate. Give me the prominent feature. Winter rainfall, dry summer. In Mediterranean, rainfall will occur in winter because of shifting of pressure belts that are there. Next feature, almost uniform throughout the year temperature. Viticulture and citrus plantations. Give me names of some regions where it is found, this type of climate. One being Mediterranean, उसके अलावा California, नीचे in south of Chile, then Perth, Adelaide and Cape Town. याद आ रही है चीजें? Famous for wine production also, oranges, lemons, olive oil, all of it. Mediterranean done. Next, थोड़ा इधर आओ. Steppy type of climate. What was prominent there? It was perfect grasslands. Next, nutritious grasslands. A- Animal husbandry is there. Wheat bowl of the world. Sorry, northeast. No trees. Perfect grassland. No trees. ठीक है. Give me the regions. Prairies of North America. Next, south में Pampas. Central Asia, हंगरी में पुस्ता. साउथ अमेरिका वेल्स. ऑस्ट्रेलिया डाउन्स. न्यूजीलैंड कैंटरबरी प्लेन्स. मैंने बताया नहीं तो पढ़ा नहीं ये वाला. यू हैव कैंटरबरी ग्रासलैंड्स हियर इन न्यूजीलैंड. मंचूरिया ग्रासलैंड किसी ने पढ़ लिया है तो मंचूरिया ग्रासलैंड. डन. नेक्स्ट, इसके बाद वी हैव सीन ईस्टर्न मार्जिन. Warm temperate eastern margin. We have three types under this: China, Gulf and Natal. China type of climate, prominent feature. Rainfall throughout the year. Long growing season, warmer temperatures, rice cultivation, bamboo cultivation, all of it. Gulf type में tobacco is very prominent. Natal type, sugarcane cultivation. ठीक है. Done. Next we are moving to cool temperate western margin. Cool temperate western margin is British type of climate. Ab, not only here, it is also found in North America, at the tip of your South America. It is almost absent in Africa. यहाँ पर थोड़ा सा मिल जाता है होबार्ट वगैरह में. Tasmania and Hobart, you might get this type of climate as well. Why is it absent here? Why is it absent in Africa? Just see the latitude it is being formed. यहाँ पे land ही नहीं है. There is no land in Africa available near to this latitude. इसीलिए नहीं मिल पाता है यहाँ पर. So normally it will be absent in Africa now. Location is 40 to 65 degree नॉर्थ एंड साउथ ऑफ इक्वेटर. ऑल्दो ये बोला जाता है कि यहाँ टिप पे मिल जाता है कई बार. ठीक है. तो दीज आर द प्रोमिनेंट कंट्रीज. यूरोपियन कंट्रीज, थोड़ा सा यूएस कनाडा में, साउथ अमेरिका एंड ऑस्ट्रेलिया में वी सी दिस. नॉट इन अफ्रीका. नाउ दिस पर्टिकुलर रीजन, it will be under the influence of, from here you will have winds blowing like this. It will be under the influence of westerlies. Plus at the same time, imagine this British या Britain type of climate के लिए इसको imagine करके सारी चीजें लिखना. If I am talking about ocean currents here, can I say it will be under the influence of North Atlantic drift, so which will again bring the moderating effect. So warmer currents will be there, and this warmer currents will lead to moderate climate. Moderate climate means summer will not be very hot, it will be relatively warmer, plus winter will not be very cold, it will be relatively cooler. तो बहुत ठंडा भी नहीं होगा, बहुत गर्म भी नहीं होगा. It will be relatively moderate conditions that are there. It is best climate for human habitation. Britishers हैं अपने according उसी को best बोलेंगे. Although it is actually good because temperature ranges are not much. Annual temperature range is low. बिकॉज समर भी बहुत गर्म नहीं है, विंटर भी बहुत ठंडी नहीं है. लो एनुअल रेंज ऑफ टेम्परेचर दैट इज देयर. रेनफॉल, rainfall can occur almost any time of the year. इसीलिए you might have you seen Sherlock या any other British documentaries, they will always carry a leather coat because of rainfall can occur at any time. And also यहाँ पर onshore winds are there, westerlies, onshore westerlies can bring rainfall as well. And again see, onshore westerlies along with a warm current that is going. वार्म करंट जा रहा है, अगर लैंड पे ठंडा है, इट विल राइज. if it is rising, the air mass that is carried along with the warm current will rise. If it is rising, it will give rainfall. इसीलिए very prominently we get rainfall in this region. सब चीज रिलेट कर लो यहाँ पे. वार्म करंट भी है, एयर मास राइज भी करेगा, फ्रंटल फॉर्मेशन भी इसी रीजन में होता है, फ्रंटल रेनफॉल कैन बी देयर. हियर आल्सो यू विल हैव अ अलास्कन करंट, अलास्का के यहाँ पे. Temperate cyclones, rainfall in winters are also possible. Vegetation, almost evergreen vegetation is there. Tall trees with good canopy cover because rainfall is distributed almost throughout the year. So जब पेड़ को पानी चाहिए, some or the other time rainfall is available. Softwood trees are there, so relatively softwood trees are there. If the trees are soft, then it is good for lumbering also. Oak, elm, birch, all of these trees are there. Bats जो बनते हैं, there are good quality bats being made from these trees as well. Softwood trees है. Trees occur in pure stand. Pure stand is हाँ हाँ. So you will have trees of one type of trees occurring in pure stands. यहाँ से वहां तक सेम ट्री है. It is good for lumbering also, कि एक साथ सेम टाइप के पेड़ काट दिए. If we go into rain forest, वहां पर एक पेड़ यहाँ मिला है, दूसरा इस टाइप का पेड़ बहुत दूर कहीं होगा. So there will be various other trees in between. Gregarious trees, one type of species is found on one land. Lumbering in Canada, Vancouver city. So यहीं पर you will have Vancouver as well. So lumbering is very prominent in Vancouver city. What they'll do is, when it is winter time, if the water is almost frozen, they'll cut trees and they'll just put it on land. पुष्पा देखिए, बस same. Exactly, यहीं से idea आया है उनको. They will all put the trees here. As it will melt, the trees along with water will start coming down. इतना भारी है, उठा के कौन लाएगा, पानी के साथ अपने आप नीचे आ जाएंगे. So this is what happened there. Agriculture, market gardening is done, mainly fruits and vegetables are grown there. Done. Coming to the continental side of it, cool temperate continental type. Cool temperate continental type. Temperate regions में continental means it is not western margin, it is not eastern margin, it is somewhere in between. And in temperate region, somewhere in between you will have Siberian type of climate that is there. ये Siberia region है यहाँ पर. So Siberian type of climate, it is not there in southern hemisphere. आप ये देखो, southern hemisphere में यहाँ पर कितना पतला है. You will not have continentality effect here because it is very narrow to have such a extensive landmass for continentality effect. So southern hemisphere में it is absent. ध्यान रखना. It is present in northern Russia या Siberia region and in Canada plus Scandinavian countries. It is present here in these nations. Climate, because of continentality, very cold winters, warmer summers. So if continentality effect is there, annual range of temperature will be very high. Very high range of temperature is there. At the same time, because of continentality, rainfall will be low because winds will not be able to reach here. So low rainfall, but it is distributed throughout the year. These are two things. Throughout the year हो रही है, मतलब कभी भी हो जा रही है. There is no fixed season that here rainfall is happening in this particular season. It can happen throughout the year, yet it is very less. So very less rainfall is happening, but it is scattered throughout the year. Temperate cyclones, now this is the region where fronts will form and temperate cyclones will occur. ये पढ़ा था blizzards, burans, cold winds. What are other cold winds? 6 पढ़ी थी total. Blizzards, burans, 2 more from B. Bora is in Italy. Adriatic seaside picks up moisture. Next, busters in Australia. 2 more winds, one from M, one from P. Mistral in France. P. Pampero in South America. याद आ रही है 6 winds पड़ी थी, cold winds. Done. Vegetation, you will find coniferous trees, and that too in pure strands. Coniferous trees मिलेंगे. पानी की कमी है यहाँ पर भी. It is not good for vegetation. बाकी ज़्यादा vegetation नहीं मिलेंगे. Relatively softwood trees है. तो pure strands में, if do you see documentaries? David Attenborough, any one of you have seen Planet Earth? इसके भी 2-3 पार्ट्स आ गए. इफ यू आर इंटरेस्टेड, अगर थोड़ा भी इंटरेस्ट आता है एनवायरनमेंट रिलेटेड चीज़ें पढ़ने में, देखने में, खाना खाते खाते बस ये लगा के देख लिया करो प्लेनेट अर्थ. पक्का हर साल 1-2 सवाल एक्स्ट्रा सही होंगे जस्ट बाय दिस डॉक्यूमेंट्रीज. यू विल लव वाचिंग देम. इट इज ऑल अबाउट एवरीथिंग अबाउट अर्थ. सो यू कैन वॉच प्लेनेट अर्थ देयर, कैसे सब कुछ इवॉल्व हो रहा है एंड एवरीथिंग दैट इज देयर. तो यहाँ पर coniferous forest, a pure strands of coniferous trees, vast extents, hundreds and thousands of kilometers of only coniferous forest is there, covered with snow as well. Because of colder, you will have fur bearing animals, warm blooded, fur bearing, बहुत ज़्यादा बाल होंगे उस पे, furs होंगे. This region is also called as taiga. So taiga type of climate is Siberian type of climate only. Harsh weather, because of cold conditions, population density is relatively lesser, so harsh weather will be there. हमने देखा था burans, blizzards, all of this blowing, they are fatal winds, so very harsh type of climate. Done? लिख लो. चलो next, only 2 type of climates are left, we'll be done with this. Next is Laurentian type of climate. Now Laurentian type of climate, cool, temperate, ईस्टर्न मार्जिन, चाइना के ऊपर गए ईस्टर्न मार्जिन में. अब यहाँ पे कहाँ कहाँ मिलेगा? वन इज इन लॉरेंशियन रीजन यहाँ पर. सेकेंड इज यू विल ऑल्सो फाइंड इन रशिया एंड जापान. दिस टाइप ऑफ क्लाइमेट इज फाउंड हियर ऑल्सो, हियर ऑल्सो. व्हाट अबाउट सदर्न हेमिस्फीयर? सी दिस इज फाउंड समवेयर हियर इन द हायर रीचेस. यहाँ पे उतना लैंड ही नहीं है, so it is not found in the southern hemisphere, not in southern hemisphere. China, Manchuria part, southeast Russia and northern Japan, and in US also you will find this. अब near to this type of climate हमने ocean currents नहीं पढ़ा है, but I'll still take a reference of that. Here you will see two currents mixing. Here also you will see two currents mixing. Which two currents mix here? Oyasu and Kuroshio. यहाँ पर लेब्राडोर एंड नॉर्थ अटलांटिक ड्रिफ्ट या गल्फ स्ट्रीम आप बोल रहे हो. तो यहाँ पर यू विल हैव गुड फिशिंग ग्राउंड्स बीइंग क्रिएटेड. एट द सेम टाइम फॉगी कंडीशंस आल्सो क्रिएटेड. फॉग पड़ा था बिकॉज ऑफ फ्रंटल इंटरेक्शंस. वार्म विंड के साथ, वार्म ओशन करंट के साथ, इट विल हैव वार्मर एयर मास. कोल्ड ओशन करंट विल हैव कोल्डर एयर मास. All of these two air mass will interact, forming front there. Because of this frontal interaction, you will have foggy conditions created in this region. So दोनों जगह foggy conditions होगी, but at the same time दोनों जगह it will be ideal fishing grounds. We'll see this in oceanography, how it is creating ideal fishing grounds as well. Again coniferous forest, यहाँ से यहाँ तक हर जगह coniferous ही चलेगा. You will have coniferous trees, softwood trees also being found there. Fishing grounds, one prominent feature is fishing grounds, है ना. Here this is Newfoundland Island, Canada, Newfoundland. You will get Grand Banks, very fertile fishing grounds. नाम याद रखना. Same on the Japan coast. You will have very fertile fishing grounds. Done. यहाँ पर we have 5 lakes, although we'll see this in detail in mapping also. In पांचों lakes का को बोला जाता है Great Lakes. These are called as Great Lakes, and this states that you have here is called as New England states. I have not written. Here also you will have New York situated. New England states में you have Yorkshire in England. Here based on the name of Yorkshire only you will have New York. Well, लिखा नहीं है. New York is also situated here. So New York also has this type of climate that is there. ठीक है, Japan में भी you have this type of climate that is there. It is under maritime influence. Here in this region also, in that region also, in both the regions, maritime influence is prominent in Laurentian type of climate. Polar या tundra region. As the name suggests, it is very near to the poles. It will not have broad daylight for throughout the year. It can be under complete darkness for half of the year. So here you might have summers for 6 months, winters for the next 6 months. So when the tilt is towards the sun, when it is northern summers, it can have summers throughout the year. If it is summers throughout the year, through 6 months, when it is summertime, it can have growing season, but that growing season will not be 6 months. 6 महीने तो थोड़ी बहुत धूप आएगी. Growing season will be only 3-4 months of the time. Same way for the remaining 6 months, it will be winter, less growing season. It is found in upper reaches of Canada, upper reaches of Russia. It is this particular soil here is permanently under permafrost. So you will not see developments, yeah, infrastructure being developed in this region because this permafrost can melt. Thawing of permafrost during summers, this ice can melt, and because of this ice melting, structures are not stable. वो नीचे भी गिर सकते हैं because we don't know yet कि अंदर कितना ice है. Even this ground is frozen. We have some ice, yes, water being frozen within the ground itself. Water is frozen. अब यहाँ पर आपने कुछ पूल बना दिया, लेट्स से कुछ ब्रिज बना दिया यहाँ पर. Then when this thaws, when this melts, even this ground will sink. So this construction cannot remain stable. That is why this area has very limited construction that is there. Very few vegetation, mosses, lichens, छोटे छोटे जो भी plants हो सकते हैं वो grow कर सकते हैं बस यहाँ पर. So very less vegetation. Tribes not important. Major tribes should be desert region tribes or equatorial region types जो हमने याद करी है. These tribes are not that important. Done. अब हाँ, अंटार्कटिका नीचे उसको हम नॉर्मली नहीं, परमानेंटली अंडर फ्रोजन आइस. Now we have understood all of this along latitudes. same variation that we see along latitudes, we see the same along altitudes also. So your altitude mimics the latitude. So if we go in the higher reaches of your mountains, if let's say good amount of rain is there, you might see tropical rainforest. As you go slightly upper, you will see deciduous type of forest, then coniferous type of forest, टुंड्रा, टाइगा, ऐसे धीरे धीरे सारा कुछ आपको यहाँ पे मिलेगा. So this altitude also mimics your latitude that is there. Done? चलो, this was all about climatic regions. एक बार रिवाइज करते हैं. कहाँ तक कर लिया था? China type was done. British type, quickly revise. British type is cool temperate western margin. Warm हो गया, cool है. Cool temperate western margin. Important features: not in southern hemisphere, and rainfall almost throughout the year, under the influence of ocean currents. इधर अलास्कन करंट आएगा वैंकूवर के पास में, इधर आएगा नॉर्थ अटलांटिक ड्रिफ्ट, एंड softwood lumbering is very prominent. In pure strands you will find trees, and good for human habitation, evergreen vegetation. और बताओ? कैनोपी, ठीक है. What about next? Siberian type of climate. Siberian type of climate में prominent features: continentality effect. Rainfall will be very less, very scanty rainfall will be there. सारा पढ़ के क्यों बोल रहे हो? रिकॉल करना है. वो पढ़े जा रहा है एक साथ सारा. सी दिस इज फॉर यू, मेरे को नहीं याद करना है, मैं आपके लिए करवा रहा हूँ. तो ट्राई टू रिकॉल. ठीक है, पढ़ के बोल दोगे तो मैं यही खोल दूंगा, पढ़ लेना. हाँ, साइबेरियन टाइप ऑफ क्लाइमेट, नॉट इन सदर्न हेमिस्फीयर, एंड टाइगर टाइप, एंड हाई range of temperature is there. Coniferous trees in pure strands, and lumbering is not there much in Siberian region. Fur is very common on animals. Warm blooded fur is there, and winds, you have blizzards and buran winds there. Next you have Laurentian type of climate. It is found in eastern margins, cool temperate eastern margins. So Laurentian region in Canada, you will have Newfoundland Island, वहां पर मिलेगा. Japan coast, prominent feature is fishing grounds, so good fishing ground is developed. New England states of USA, वहां भी मिलता है ये. Done. Then you have polar regions, polar climate. Most important ones are savanna, मेडिटेरेनियन. यहाँ से सबसे ज्यादा क्वेश्चन पूछे गए हैं, सवाना टाइप एंड मेडिटेरेनियन टाइप ऑफ क्लाइमेट. ठीक है, चलो. वन लास्ट थिंग दैट इज लेफ्ट इज ओशनोग्राफी. क्या? नेक्स्ट क्लास? चलो ठीक है, विल डू इट इन नेक्स्ट क्लास, बट नेक्स्ट क्लास माइट बी अ बिट लेंदी, तो जस्ट बेयर विथ इट. ठीक है, अभी आपका कल समाधान सेशन है, इसलिए ऑल्सो वी आर लीविंग टुडे स्लाइटली अर्ली, नहीं तो इसको 1 घंटे में खत्म करके फिर छोड़ते. क्या? चलो, थैंक यू एवरीवन, ऑल द बेस्ट फॉर समाधान टुमारो. आई होप यू हैव इनफ एनर्जी लेफ्ट फॉर द सेशन. हाँ, Acha, do drop a comment. I'll send the PDF as well, but do drop a comment, then only I'll send the PDF. By comment I mean it only helps me to improve what all lacunas are there, so that the next class can be better than this. YouTube comment. Chalo, thank you everyone.